Hello, and welcome to ServiceNow 201 Development. My name is Mark Miller, and I'll be your instructor throughout this course. In this section, I'll provide a brief introduction. I'll tell you why you should take this course. We'll cover the course structure and the course outline. We'll go over navigating the course. Then we'll discuss any prerequisites that you should have before taking this course. We'll then talk about what you'll need to take this course. I'll then provide an overview of the instance I'll be using throughout this course, and I'll wrap up this section by discussing the course goals. So, let's get started. So, why take this course? Well, if you want a deeper understanding of how ServiceNow actually works behind the scenes, then I definitely recommend this course. This course will help you master scripting within ServiceNow, so you can do awesome things like build custom applications or build complex integrations to other systems. This course will benefit any developers or consultants, system admins, or really anyone interested in learning more about ServiceNow. So this course is broken up into 10 sections, where each section is made up of videos, slides, demos, and quiz questions. There's also a workbook at the end of the course. Alright, so let's take a look at the course outline. So we're currently in the first section, the course introduction. After this section, we'll jump into section 2, where I'll provide a development overview. Then in section 3, we'll cover the most important scripting locations that you need to know as a ServiceNow developer. In section 4, we'll get started with our first ServiceNow API, the Glide record. Then in section 5, we'll cover the Glide System API. In section 6, we'll switch gears to client-side APIs, where we'll discuss the Glide Form and Glide User API. Then in section 7, we'll discuss the complex and somewhat mysterious Glide Ajax API. In section 8, we'll explore a number of other APIs within ServiceNow, and I'll even show you how to create your own. In section 9, we'll cover how you can become a scripting master by discussing important concepts like debugging and what to do when you get stuck. Finally, in section 10, we'll take everything that we've learned throughout this course and we'll build a custom application. Okay, now let's discuss a little bit about navigating the course. So if you feel like I'm going too quickly over something, you can actually slow down the video, or if I'm going too slow, you can actually speed up the video as well. If you don't understand a concept, try rewatching the videos. If you have questions specific to the course, or even general ServiceNow questions, I highly recommend posting to the course's Q&A. Chances are, if you're asking a question, other students probably have the same question. So, not only would you be helping yourself by asking the question, you can think of it as you're helping the community as well. Throughout this course, I'll have a number of these notification topics that appear in slides. I have a note topic, which is where I'll just add additional information to a specific slide. Caution, which means you should be cautious of whatever the notification is covering. A dive deeper notification, which generally includes a link to an additional article or video. A best practice notification, which outlines a specific best practice on how to do something. And finally, a 101 notification, which notifies you that a specific topic was covered in my ServiceNow 101 administration course. Finally, I have client-side and server-side icons. So the two green circles on the right represent the first being server-side or the second being client-side. So if you see these icons in the top right corner of any slide, then it's safe to assume that the specific topic that I'm covering relates to either server-side or client-side. Hello, and welcome back. In this video, we'll discuss the prerequisites for this course, and I'll provide an overview of the instance I'll be using. Okay, so this is not a beginner level course. Having a solid understanding of ServiceNow is definitely recommended. It's even better if you have personal admin experience on the platform. Having a solid understanding of database concepts like tables, fields, and records will also help you with this course. I also recommend having a general understanding of HTTP and how web apps actually work over the internet. Now, you don't have to be an expert in this field, but just know the difference between client-side or server-side. And finally, because this is a scripting course, JavaScript is a prerequisite. Unfortunately, due to the scope of this course, I will not be teaching you JavaScript. There's literally hundreds of thousands of other amazing courses, videos, and material out there on the internet. And I'll point you in the right direction, but just keep in mind that when we start coding in this course, I expect you to have a general understanding of JavaScript and some object-oriented programming concepts. Alright, so what you will need? Well, you'll need a computer with a modern web browser and an internet connection. That's really it to watch the videos. Now, in addition to that, I highly recommend getting a personal instance. You can do so by going to developer.servicenow.com and signing up for a personal ServiceNow instance. If you follow along using a ServiceNow instance, I highly recommend that you do not follow along in a production instance. So if you work for a company and would like to follow along, I recommend either getting a personal instance or at the very least playing around in a dev instance. Alright, so for the purposes of this course, I will be using my own personal developer instance. Keep in mind that this may have slight modifications from out of the box or the instance that you are using. I try to keep my instance as close to out of the box as possible, but I've had this instance for many years now, so keep in mind that there will be some differences here and there. I am running Istanbul on my personal instance, which is using UI16 and List v3. Again, if you're using a different release of ServiceNow, that's perfectly okay. You don't need to be on this specific version or even be using UI16 or List v3. The core concepts that we discuss in this course are release agnostic. So a business rule will always be a business rule within ServiceNow, whether you're on the Eureka release or the Jakarta release. Now, while there have been some big changes to user interface in ServiceNow, and things might look a lot different, under the hood, it's all just configurations stored as records and tables in a database. So if your instance does look different, try not to focus too much on the looks as opposed to the concepts that we're discussing. The user account I use in this video has the admin role and security admin role. And the browser I'll be using is the latest Mozilla Firefox release. Alright, now let's discuss the text editor I'll be using. So I just want to let you know right off the bat that a text editor is not required. ServiceNow has actually come a long way since the old days where you're typing scripts in an input field. Now they have relatively modern in-browser text editors that you can use and are just as powerful as text editors you run on your operating system. But for the purposes of this course and the readability for you, the student, I chose to go with the Atom text editor. One of the amazing things about Atom is it's an open source text editor by GitHub, and it's completely free. Here's a screenshot of the code we'll be writing within the upcoming videos within Atom. In the majority of the videos, I'll write the code in the text editor, and then I'll copy and paste that code into ServiceNow, just so it's easier to read for you guys. Alright, now let's discuss some of the core goals I wanted this course to have. So the ServiceNow platform is huge, and with every release it continues to grow, introducing new tables, new business rules, new client scripts, etc. And as someone learning the platform and being introduced to this for the first time, it can be extremely overwhelming. So I asked myself, with such an overwhelming number of places to script in ServiceNow, how could I fit this into a course that actually makes sense? Well, in this course I've decided to focus on the what and how rather than the where. So instead of breaking the course up into sections that cover where to script, instead each section will be covering more of the what and how, and then you can apply that to the specific locations within ServiceNow. Now, in section 3, I'll still cover probably 95% of the scripting locations you'll use as a ServiceNow developer, but I'm placing more emphasis on the what and how, specifically covering the ServiceNow APIs. And then once you have an understanding of how the APIs work within ServiceNow, it doesn't matter where you apply those, whether it's a business rule or a script include. Now, at the end of every section where I introduce a new ServiceNow API, I will tell you where this specific API can be used, whether it's client-side or server-side. Now, while I've tried my best to cover all of the most important scripting concepts in ServiceNow, this course does not cover every single scripting component. So, this course should get you 80 to 90% of the way there, but in order to understand the entire platform, you'll still need to read the ServiceNow documentation. Now I'd like to end this section by discussing what to do when you spot an error in this course. So I've spent literally hundreds of hours creating this course, and I tried to provide you, the student, with a quality course. But I'm not perfect, and I'm sure I'll be making mistakes throughout this course. So if you spot one, please report them to me so I can fix them as soon as possible. Hello, and welcome to Section 2. In this section, I'll provide an introduction to ServiceNow, as well as an introduction to development inside ServiceNow. We'll start this section by first covering some ServiceNow basics. We'll discuss important topics like releases, environments, and update sets. We'll also discuss the ServiceNow stack, or group of technologies that comprise ServiceNow. Then we'll go over some important concepts like tables and their relationships, fields and field types inside of ServiceNow, records, and reference fields. We'll then jump into ServiceNow, where I'll show you how reference fields work. Once we've covered those core concepts, we'll be ready to jump into ServiceNow development, where I'll provide a brief introduction. We'll then discuss when scripting is and isn't necessary, and after that we'll discuss JavaScript and the scripting environment within ServiceNow. We'll end the section by covering background scripts, the ServiceNow Studio, and some additional resources that'll be beneficial to you. So, let's get started with some basics. Note that if you've recently watched my ServiceNow 101 course, or feel like you have a solid understanding of the following topics, feel free to skip to the next video. So, what is ServiceNow? Well, ServiceNow is a software as a service platform. ServiceNow uses a subscription model, so customers subscribe or purchase licenses for a given set of users. If someone at an organization says they have ServiceNow, they don't physically own the source code or have it installed somewhere. They simply have a ServiceNow subscription or a group of subscriptions. ServiceNow started in the IT service management space, where it quickly grew and almost monopolized the industry. But it didn't stop there. ServiceNow currently has presence in IT service management, IT operations management, IT business management, application development, security operations, human resources, and much, much more. If you'd like to know more about what ServiceNow is capable of, I recommend visiting ServiceNow.com for a list of all products. So, what do you get when you purchase a subscription? ServiceNow will give you an instance, which represents a few things. An instance represents a specific URL in which you access your instance through. It also represents the instance data that is stored in the hosted database servers, any application logic, and any custom components. We'll discuss the ServiceNow stack in a bit, but for now just know that ServiceNow uses a MySQL database on the back end. Due to this, almost everything in ServiceNow is stored as a record in a table within an instance database. An incident is stored as a record in the incident table. A business rule is stored as a record in the business rules table, and so on. Whenever you hear the phrase out of box in the ServiceNow world, this refers to the state of an instance when ServiceNow first spins it up. So, what comes with the core platform? Or what is loaded out of the box? A lot of ServiceNow best practices represent the idea of maintaining an instance that is as close to out of the box as possible. If you have an instance and you have tons and tons of customizations and complex things going on, it can make it much more difficult for upgrades and maintainability. Over the years, ServiceNow has made a lot of changes to their IT service management processes within the tool based on customer feedback. So if you think of it as the ServiceNow tool, such as incident, problem, and change, represent the industry best practice, and you want to make some complex configurations and customizations to it, then you should really be asking yourself, is my process that much different than the hundreds or even thousands of other customers out there? If ServiceNow in their out-of-the-box state represents an industry best practice and follows ITIL best practices, should I be changing my process? And as a consultant, a lot of the times it's our job to provide the customer with this insight. I've seen this time and time again where a customer's complex configurations and customizations come back later only to bite them in the butt when they look to upgrade or use new tools or applications like the new service portal. So while you, the developer, is capable of creating some very complex customizations and really changing ServiceNow to do anything you want, it's not always recommended. Alright, now let's talk a little bit about releases. So just like any other application you've used, ServiceNow has what they call releases to group together a number of changes to the core platform. ServiceNow is on an approximate 10 to 12 month feature release cycle. At the time of this recording, Istanbul is the current general availability release. This means that new customers will receive instances on the Istanbul release. The feature releases are named after cities around the world. So to the right is a list of past and future releases along with their release year. The ServiceNow release schedule is composed of feature releases, which contain new features and new applications, patch releases, which contain a collection of problem fixes, and finally hot fixes, which are usually a fix to a specific problem that's implemented very, very quickly. A patch release may contain many hot fixes. Note, to check the release version of an instance, Simply type stats.do followed by the enter key in the application navigator. This will bring you to a page which shows you all kinds of useful information about a given instance. Although it depends on your license contract, customers typically receive 3 environments from ServiceNow. They'll receive a production instance, a test instance, and a development instance. The reason for these 3 instances is so admins and developers can customize and develop on the platform without jeopardizing production data. Typically, development is performed on the development environment. Once work is complete there, it is pushed to the test instance, where users go through a user acceptance testing phase. Once testing is complete, the changes are then pushed to production. As an admin, you have the ability to clone instances. So, for example, if the development instance starts to drift far from the production instance, and by that, I mean the process and configurations and customizations in the development instance are not representing the current process and configurations in the production instance, then you may request the development instance to be cloned from the production or test instance. So you would essentially be taking the mirror image of your production instance and cloning that down to development. So then development would mirror the production instance at that point in time. It's best practice to keep all instances as similar as possible, especially the test and production instances, since when you test new updates, you want to be testing those updates in an instance that is as similar to the production instance, if not identical to the production instance, as possible. Alright, now let's talk about update sets. So you might be asking, how do I push changes from dev to test or prod? Well, this is accomplished via update sets. Update sets are used to record most customizations and configurations. Most being the key word here. If you are ever in doubt, I highly recommend going to ServiceNow's documentation to verify what gets captured and what doesn't get captured. Almost everything inside of ServiceNow is stored as a record in a table. If you modify a business rule or client script, you are really modifying the business rule or client script record in their respective tables. Update sets are XML snapshots of the last record modified. So if you were modifying a business rule, the update set would just contain the most recently modified business rule record in XML format. Update sets also have versions, and you can merge 2 or more update sets into one. If 2 update sets have modified the same record, and you merge those 2 update sets, the merged update set will contain the last modified record. When you load an update set, say to a production instance, you can preview the update set before committing the update set. This will catch the majority of issues and compatibility issues if they arise. Now let's quickly discuss what's captured and not captured in update sets. Customizations like client scripts, business rules, and UI policies are captured in update sets. Tables and fields are captured. Reports and workflows are captured. And form modifications are captured. So, what is not captured? Well, data is not captured, such as new records in an incident table or a change table. So, new incidents, new problems, new users, new groups, all of these are not captured. New CIs are not captured in the CMDB, and schedules are not captured either. Again, if you are ever hesitant on what is captured or not, I recommend reviewing the ServiceNow documentation. Also, just because something is not captured in an update set doesn't mean that you can't still import that into another instance. There are methods like exporting the XML record and then importing the XML record into another instance. This is commonly done with groups in the instance. Alright, and finally we'll end this video by discussing the ServiceNow stack. So the ServiceNow stack, or group of technologies that comprise ServiceNow, consists of Apache Tomcat web servers, J2EE application servers, MySQL databases, and the Mozilla Rhino JavaScript engine. This is not an exhaustive list, but should give you a general understanding of the platform and the core technologies that ServiceNow is created on. The ServiceNow data centers consist of thousands of servers that take on the roles of load balancers, web servers, application servers, database servers, and much, much more. The general flow of traffic when, say, a client wants to access a specific incident would be their request goes over the internet and finally lands in the ServiceNow data center. The first thing their request might hit is a load balancer, which determines which servers have extra resources to allocate to process this request. Once a load balancer finds an idle web server, it would then send the request to the web server. The web server would do some processing and send the request to an application server. The application server is what would do a lot of the core logic and generate the SQL to then be passed to the database server where a specific incident would be queried in the incident table. Then the database server would hand the application server that information. The application server might hand that response to the web server where it's packaged up and finally sent back through the internet to the client. Again, there's probably hundreds of technologies involved with ServiceNow since it's such a huge platform, but this group of technologies here represent the core systems used. Hello and welcome back. In this video, we'll take a look at tables, their relationships, and then we'll dip into ServiceNow to show you a few tips on table management. So let's get started. Each ServiceNow instance has over 2,000 out-of-the-box tables. The majority of these tables relate directly to the applications inside of ServiceNow. Each application has one or more tables. For example, there is an incident table for the incident application, and there are hundreds of CMDB tables for the CMDB or configuration application. Each table contains many fields, which we'll go over in the next video. Tables can extend other tables as well. We'll discuss table extensions here in the next few slides. There is also a naming convention used for the tables in ServiceNow. All table names are lowercase and use underscores instead of spaces. However, tables do have human-readable labels, which may contain capitalizations and spaces. If a developer creates a table, it will be prefixed with U underscore and then the name of the table. With an admin role, we can create and modify existing tables. So here at the bottom, we can see my custom table on the left is the table label. However, the actual table name is U underscore my underscore custom underscore table. Table names are important when scripting, as we'll see within the next few sections. Now let's discuss table relationships. So in this diagram, we have a person table, a student table, and a faculty table. The faculty and student tables extend the person table. We can also say that the person table is the parent table, and the student and faculty tables are the child tables. So why do we need a person table at all? Why not just have a student and faculty table? Well, we could, but it would cause unnecessary redundancies, since each student has a first name and last name, and each faculty member has a first name and last name as well. We can put those common fields in a parent table and inherit them. Now, the person table can hold all information that is common among students and faculty, while the student table has fields that are specific to students only, and the faculty table has fields that are specific to only the faculty. An example for faculty-only fields would be something like salary. Extended tables also have the option to add dictionary overrides to their fields. Let's say the person table contains a user ID field, which the student table inherits. However, when we refer to students in the student table, we would like the user ID field to actually be called the student ID. We can do this with a dictionary override, which overrides the person's user ID label with student ID only for student records. So faculty records would still have the inherited user ID label. Dictionary overrides are commonly used in the out-of-the-box system with the task table and the task table's children table, such as incident, problem, change request, etc. Table relationships are very important in the CMDB. The CMDB application consists of hundreds of different tables, which are all related to one another. This allows ServiceNow to create what are called business service maps. So if a physical server goes down, we can see all of the other software and hardware that is dependent on that one server, such as an Exchange server due to table relationships defined in the CMDB. Relationships can be either one-to-many, which is most common, or even many-to-many. An example of one-to-many relationships would be every table has one or more fields. Every field belongs to only one table. An example of a many-to-many relationship would be each user can have many groups, and each group can have many users. Now let's take a look at an example of table relationships within the CMDB. The majority of CI class tables extend the CMDB_CI table. For example, at the bottom of the diagram, we have a Windows Server and Linux Server CI class table. Its parent table is more general, called CMDB CI Server, or the server class. At the bottom right, we have a web application whose parent is a general application. Now let's quickly go over some of the most common tables and their names in ServiceNow. It's important to note that there are thousands of tables in ServiceNow, so it's not realistic to cover them all, nor are you required to memorize them for any particular reason. So first we have the task table, which is the parent table for a number of tables such as the incident table, the problem table, and the change request table. The task table stores common information such as a number field, a short description field, assigned to field, and assignment group fields. Then the incident, problem, and change request tables all inherit these fields since they are children of the task table. We then have the sysuser table, which is where ServiceNow users are stored, and the sysuser group table, where the groups in ServiceNow are stored. The sysuser role table stores all of the roles in ServiceNow. We also have a CMN_location table, which stores all locations in the platform, and a core company table, which is used to store companies or organizations in the platform. We then have our knowledge management tables. So we have KB_knowledge, which stores the actual knowledge articles, KB_category, which stores the knowledge categories, and a KB_knowledge_base, which stores the knowledge base records. Then we have some of the core service catalog tables, such as SC request for the requests, SC rec item for the request items, and SC task for the catalog tasks. We also have SC catalog for the service catalogs, and SC cat item to store the actual catalog items. Then I have two CMDB tables, the CMDB CI, which is a parent table to many other tables, and the CMDB CI server table, which is both a child to the CMDB CI table and a parent to many of the child server tables. This isn't an exhaustive list by any means, but just a short list of what I consider to be some of the core ServiceNow tables. In reality, there are many other service catalog tables a part of the service catalog application, and knowledge tables a part of the knowledge management application. The tables and columns module can be a great one-stop shop for information about a particular table. The list on the left shows all tables within the system ordered by their label. The list in the middle shows all fields on a specific table. Finally, the list on the right shows attributes for a specific field. It also allows you to launch the schema map of a particular table. The schema map is a visual diagram that shows table relationships. We can focus on a table, and the schema map will show all tables that extend or are extended by the focus table, as well as referenced tables. In the image, we can see the focus table is incident, which has a relation to incident task, sysuser, and a number of other tables. Now let's take a look at these modules within ServiceNow. So to start with, we'll go to the Tables and Columns module. And here on the left, we can see a list of all of the tables in the system. So we'll scroll down and select Incident. And the middle column shows us all of the fields on the incident table. If we select a field or column name, then we have the column attributes shown on the right-hand side. So all of the attributes associated with this specific field. We can also expand reference fields. So for example, the company field here is a reference field. So if we click the plus button, we can directly access all of the related fields on that reference table. If I click the Schema Map button, this will load the schema map with the incident table as its focus. So here on the left, we can see all tables that are referencing the incident table. And on the right, we can see all referenced tables by the incident table. We can also expand the columns on the incident table and even expand the task columns since the incident table extends the task table. We can also focus on another table by right-clicking and selecting Focus on this table. Now this has the task table as the focus table. And we can see here that there are many tables that are related. and referenced by the task table. Hello, and welcome back. In this video, we'll talk about records and fields in ServiceNow. Before we get into records and fields, I'd first like to talk about an important concept in ServiceNow, and that's the globally unique identifier. The ServiceNow wiki states, each record in ServiceNow is identified by a unique 32-character globally unique ID called a sysid. In software development, we often need a way to reference an exact record or data structure. And in order to reference an exact record, we must need some type of unique identifier. This is commonly referred to as a globally unique identifier. However, in the ServiceNow world, we refer to this by the sysid. An example of a sysid is as follows. It looks a little bizarre at first because it's a 32-character hexadecimal string. So in this example, we have EF4225, A40, etc. Sysids are used all throughout the system and are very common in scripting within ServiceNow. If you are referencing a specific incident in a script and you need a way to reference that again in maybe another script or just another function, you can do so by using the sysid to point to that exact incident. Sysids are commonly paired with a table name to locate a specific record. So for example, if you have the sysid of a record, in addition to the table name in which that record is stored, you can use these two values to quickly find that specific record. So for example, if you wanted to reference a specific incident and you had that sysid, you could use the sysid plus the table name, in this case incident, to quickly query and locate that incident. Now, in theory, because sysids are unique, you could find that record just by using the sysid. But it turns out it's much more efficient and quicker to find that record by adding the name of the table. Alright, now let's discuss databases, tables, and fields. So a database contains many tables, and a table contains many fields. So the incident table might have the fields number for the incident number, caller for the caller associated with that incident, and short description for the short description for that incident. So the incident table contains many fields, the fields I just listed. Records are stored in tables. So in the screenshot below, we have a list of records that are stored within the incident table. The columns in this screenshot represent the fields on the incident table. So by looking at this list, we can see that the incident table has the fields created, number, short description, category, and opened by. So if we use the analogy of a spreadsheet, we could say that the rows from a spreadsheet translate to the records in a table, and the columns of a spreadsheet translate to the fields on the table. So an individual cell refers to a specific record's field value. So for example, the second record in this list's number is INC 0020154. So again, records are stored in database tables. Records represent a single entity defined by a table's fields. So what makes a specific record unique are the field values associated with that specific record. Each record has a unique key, the sysid. So if you wanted to reference this INC0020154 incident record. You could do so in a script by referencing the sysid, which is this EF4225A, etc. hexadecimal string. Now let's talk about field types in ServiceNow. So ServiceNow has many different field types. There's a string field type, a date field type, a time field type, there's choice field types, true and false field types, list field types, HTML field types, even scripting field types, which we can leverage in custom applications, and reference field types. There are other field types within the platform, but this is a list of the more commonly used field types. So what are reference fields? Well, the ServiceNow docs state reference fields store a reference to a specific row in another table, similar to foreign keys in SQL. So if you're ever looking at a form of a specific record, and you see the magnifying glass shown on the right by the caller field and the location field, these represent reference fields in ServiceNow. So in this screenshot, you can see that we're on the incident's form view. However, there's a field on the incident table called caller that's actually referencing the sysuser table. So when I start typing a name here, it's pulling up a list of records stored in another table in the sysuser table. Same for location. It turns out these reference fields are a fundamental building block to applications within ServiceNow. These reference fields give us the flexibility to create relationships between records. So, for example, if the location field was just a free-form text field, a string field, then we wouldn't have consistent data because maybe every help desk technician has a different way of entering a location. Maybe some people use all caps or all lowercase. Some people wouldn't put a comma after the city. Maybe some people wouldn't even add the state at the end, etc. However, if we create a reference to the location table, and as long as the location table is already populated, then within the incident's record, we're actually storing a reference to that specific location. So then we have the integrity of that data in every field. Popular reference tables are the user table, the location table, and CI tables. However, any table may be referenced by another table. References are everywhere in the platform. And it turns out that the sysid is stored in the referenced field. So again, if we're using the example of an incident record, that incident record has a field called caller ID, which references the sysuser table. Well, if I have Mark Miller as the caller ID, it's Mark Miller's sysid that's actually being stored in that referenced field. Even though it uses the display value of Mark Miller, it's the actual sysid that's being stored there. Reference fields must match an exact record. So if you're ever typing in a reference field and you get a red background shown in the screenshot here, that means that there is no exact match for the text in that field. So this would imply that there's no user in the sysuser table that has a name of Jane. Finally, if we want to filter the referenced records, we can do so by using reference qualifiers. So maybe in the caller field, we only wanted to pull active users from the sysuser table. If a user was marked inactive, maybe they retired or something like that, then we don't want to give the user the ability to reference those records. Alright, now let's quickly take a look at reference fields in ServiceNow. So if I go to the incident table, we'll go to Open Incidents, and we navigate into a specific incident. We can see that there are magnifying glasses next to the caller field, the location field, the configuration item field, as well as the opened by, assignment group, and assigned to fields. So if I right-click on caller and click on Show Caller ID, I can see information about this specific reference field. I can see that the field name is caller ID and that it's of type reference, and it references the sysuser table. If I show the location field, we can see that this is of type reference and it references the CMN_location table. If I click the information icon next to location, I'll be taken into this related record. So here I'm on the CMN location table, viewing the Columbus, Ohio location record. I'll go back to the incident, and now I'll go to Configure Table. And I'll search for the column caller. So if I go into the dictionary entry for the caller field on the incident table, we can see that I have a reference field where we specify the user table, and that we can apply reference qualifier conditions. So if we wanted to only show active users, we could do active is true and add any other filters on the sysuser table. If we go to the top, we can see that this is of type reference. Hello and welcome back. In this video, we'll finally go over an introduction to scripting in ServiceNow. So scripting in ServiceNow is extremely powerful. We can actually leverage existing APIs so we don't have to reinvent the wheel. Now, we'll explore APIs in the next section, but for now, you can think of APIs as an abstraction to do a common task. So a lot of the times we want to access a specific record in a table and make an update to that record. Well, as the developer, instead of writing out that entire process in JavaScript and then writing the SQL to make the initial queries and then the SQL to make the updates, etc., etc., it turns out that there is an API or application programming interface available to us to make that job much, much easier since it's such a common task to perform. These existing APIs in ServiceNow are grouped into glide classes. Scripting in ServiceNow is very flexible. There's really little you cannot customize. The ServiceNow wiki states, the ServiceNow glide classes expose JavaScript APIs that enable you to conveniently work with tables using scripts. Using the glide APIs, you can perform database operations without writing SQL queries, display UI pages, and define UI actions. So you can think of these APIs as building blocks. They provide a blueprint to do a common task. Again, we'll talk more about APIs in the following sections within this course, but for now, just be aware that they provide a framework to do common tasks. So, when is scripting necessary? While ServiceNow gives us the flexibility to customize just about anything via scripting, it's not always necessary. Usually configurations and customizations can be done without any scripting at all. It turns out it's actually best practice to avoid scripting when not required. For example, if you would like to show or hide a field on a form, depending on whether or not another field is populated. You could do this by scripting a client script. However, it's best practice to do this via a UI policy. So generally, the 80-20 rule applies to scripting in ServiceNow. 80% of the time, you can accomplish what you are trying to do without scripting. And roughly 20% of the time, scripting is required. Depending on what you're doing, this may be closer to 60-40, 70-30, or even 90-10. If you are building a lot of custom applications and/or integrations, you may be closer to 60-40. However, if your organization is trying to follow as closely to out-of-the-box as possible, it may be closer to 90-10. So customizing without scripting includes UI policies, workflows without scripting activities, creating new tables, and creating new fields. Scripting is necessary when you need to do more complex things, like creating integrations, creating complex business rules, or client scripts, creating UI actions or complex transform maps, or creating service portal widgets or custom applications. One of the reasons ServiceNow has been so successful is due to just how easy it is to configure and customize the platform. ServiceNow is constantly evolving the platform, and there are a lot of configurations and customizations that can be applied without any scripting at all. So again, if you can achieve a configuration without scripting, that's generally considered best practice. Now I'd like to quickly cover the differences between client-side and server-side scripting. If you took my ServiceNow 101 course, then this slide will look quite familiar. So this is an important concept not just for ServiceNow, but really for any web application. Web applications are very different than your standard desktop applications such as Microsoft Excel or a photo editor such as Photoshop. Desktop applications store the application data, such as a spreadsheet or a photo, locally on your computer's hard drive and are processed using your computer's CPU, as opposed to web applications where the data and processing happen in a data center. Throughout this section and the rest of the course, when I talk about client-side, I'm referring to the browser you, the user, use to access ServiceNow, whether it be your desktop, laptop, phone, or tablet. When I talk about server-side, I'm referring to ServiceNow's data centers, where the application servers and database servers are located and instance data is stored. Anytime you want to access data in ServiceNow, the client or browser makes a request to the servers in the ServiceNow data center over the internet. The application server receives the request and communicates to the database server, where the data is stored. Once the application server receives the data from the database, the server will then package it up in an HTTP response and send it back to your browser via the internet. Your browser then processes this data and renders it on the screen. Now let's take a look at an example. Say we are viewing a single incident record. The client side has limited access to instance data. For example, because we requested information about a specific incident, the server sends us a response with only data related to that specific incident. If we wanted to view or access more instance data, such as another incident, a request and response to and from the servers would be required. So this is what I mean when I say on the client side, we have limited access to data. We only have access to the data that is sent back to us from the servers. The ServiceNow data centers or server side is very powerful, but requires network activity for the transfer of data. This naturally takes a bit of time to travel over the internet. The time it takes for a packet to leave your computer, reach ServiceNow's data center and then return back to your computer is called the round trip time and can be important when troubleshooting network issues. Keep in mind that no matter how fast your internet is, there will always be a slight delay due to the round trip time. On the client side, we have access to the current form, fields and values, UI elements, or the DOM, the Document Object Model, and any client-side APIs. On the server side, we have access to the database, server-side APIs, and script includes. Alright, now let's talk about the programming language we as a developer use in ServiceNow. So one of the awesome things about ServiceNow is there's one language. We use JavaScript on the client side as well as the server side. This makes it very easy for the developer. Wikipedia states, JavaScript is a high-level, dynamic, untyped, and interpreted runtime language. JavaScript is prototype-based with first-class functions, making it a multi-paradigm language, supporting object-oriented, imperative, and functional programming styles. Now, that's quite a bit of a mouthful, and a lot of these keywords are out of the scope of this course. But just know that it's an object-oriented programming language and is interpreted as opposed to being compiled. JavaScript is not Java. They are two completely different programming languages. There's actually a really interesting history to JavaScript, and the creators wanted to piggyback off of the popularity of Java at the time, which is why they used the word Java in JavaScript. But keep in mind that these are two completely different languages. It just so happens that ServiceNow is written in Java. So JavaScript was originally developed to be a client-side scripting language. And because of this, it's supported in every modern browser. Usually when you hear the phrase JavaScript on server side, you'll come across Node.js, which is a relatively new runtime environment for executing JavaScript on the server side. However, in the world of ServiceNow, they use Mozilla Rhino as a runtime environment for executing JavaScript. JavaScript has seen a lot of growth over the past few years due to Node.js and its relatively easy learning curve. It's actually one of the most popular programming languages in the world and is the most popular on GitHub. However, it's also one of the most misunderstood languages. If you would like to know more about this, I highly recommend checking out the book JavaScript: The Good Parts by Douglas Crockford. Alright, so now let's talk about this scripting environment in ServiceNow. So again, anytime we're writing server-side JavaScript, it's being executed on the Mozilla Rhino runtime environment. With the version of Mozilla Rhino that ServiceNow is using, we can use ECMAScript 5 features. However, we cannot use the latest ECMAScript 6 or even 7 features, so keep that in mind when writing JavaScript code. Within the scripting environment, we have access to the ServiceNow APIs, as well as any third-party libraries. So if we're writing client-side code, we have access to Angular, jQuery, and other libraries as well. Now let's quickly discuss background scripts. Background scripts are a location in ServiceNow where we can run server-side code on demand. It's similar to a browser's console, and it's a great place to experiment. And it turns out we'll actually be using background scripts for a lot of the server-side code we write in this course. Within a background script, we have access to the ServiceNow APIs. It's important to note that background scripts should be used with extreme caution due to performance impacts and possible data loss. If you are ever deleting records through background scripts, I highly recommend first logging those records to the screen before issuing the delete command to verify that you're deleting the correct records. The ServiceNow Studio is an integrated development environment, or IDE for short. You can think of it as a one-stop shop for all configuration records, and makes development in ServiceNow much easier. However, Studio is only available for scoped applications and cannot be used on the global scope. So it can only be used when creating custom applications. Because of this reason, we'll only use the ServiceNow Studio and Section 10 when we create our custom application. Now, there are a few important concepts that I want to go over before we end this section. Number one is the variable naming conventions. Within ServiceNow, it's common to use underscores. So an example for a variable hello world would be hello_world, all lowercase. In vanilla JavaScript, you would typically see camel case. So it would be hello capital W world. Now you can use either or, but generally if I create a new variable in a script, I'll use the camel case convention, and if I'm referencing an existing variable in ServiceNow, I'll use the underscore convention. Another important concept is the sysid. And although we've already hit this, I just want to reiterate that it's a 32-character globally unique identifier, and every record in the system has one. So every table, every field, etc. has a sysid. The last important concept I want to discuss now is the difference between a field display value versus the actual field value. Most fields are actually objects, not strings. So for example, in the screenshot to the right, we have a variable field, which is a JavaScript object. The variable field has two properties, value, which is equal to help_desk, and display value, which is equal to help space desk, or the display value for this field. So if we want to access the display value for a given field, we can actually use the getDisplayValue method. Now we'll cover this in much more depth within the following sections, but I just want to bring this to your attention that there is a difference between the field display value, which is generally user-friendly, consisting of spaces and capitalizations, versus the field value, which should not contain spaces. Finally, we'll end this section with additional resources. So because JavaScript is a prerequisite for this course, and unfortunately is out of scope for this course, if you are not familiar with it or need a simple refresher, I highly recommend the following JavaScript resources. Codecademy is a great free resource, and Code School is a great paid resource. There's also JSBin or JSFiddle for testing your JavaScript logic within the browser, and two amazing books I highly recommend any JavaScript developer to read. The first one being JavaScript: The Good Parts by Douglas Crockford, and the second being Eloquent JavaScript. There's actually a free version of Eloquent JavaScript online, so definitely check out the link provided here. In addition to JavaScript resources, there's also a number of amazing ServiceNow resources. There's the ServiceNow YouTube channel, the API Docs website, the JavaScript Primer PDF, which is linked here, and many other third-party websites. Throughout this course, I'll list additional resources, and I'll have an additional resources PDF available at the end of this course, which aggregates all of the additional resources I've listed in this course. Hello, and welcome to Section 3, Scripting Locations. As the name implies, in this section, we'll take a look at the most popular and commonly used scripting locations within ServiceNow. So we'll start this section with an introduction, and then we'll discuss the many scripting locations within ServiceNow. Then we'll start to break down each major location. So we'll cover business rules, client scripts, UI actions and UI policies. We'll discuss script includes, schedule jobs, and even scripting and workflows. Then we'll go over a diagram mapping out roughly where to customize within ServiceNow. We'll end this section by discussing APIs and what they are, and I'll provide some analogies, and then we'll discuss where we can actually use these within the platform. So let's get started. So it turns out that there are a number of places to script within ServiceNow. There's actually over 30 different scripting locations within the platform, and this number continues to grow as the platform grows. So for this course, instead of covering every single location, which some locations you'll never use, I decided to break up this section by the most important and commonly used scripting locations. So some of the most commonly used are outlined here. So we have business rules, script includes, client scripts and UI actions, UI policies and schedule jobs, workflows, transform maps, web services, UI pages and UI macros, service portal widgets, and many more. Now, for the purposes of this section and covering each one of these in more depth, we'll only be covering the locations that are outlined in green. So everything from business rules to workflows. But because this course is designed on the how and less on the where, the fundamental concepts that we learn throughout this course can be applied to just about any scripting location. Alright, so now let's discuss business rules. Business rules are server-side. So they only run on the server side. They will never execute on the client side. And we have our server-side icon in the top right, so anytime you see this, it's safe to assume that that particular component is server-side. So the ServiceNow docs state, a business rule is a server-side script that runs when a record is displayed, inserted, updated, or deleted, or when a table is queried. For the rest of this section, we'll discuss what exactly this means. So business rules are probably the most common scripting location within ServiceNow, and business rules are actually JavaScript that runs on the server. So in today's world, when we think of JavaScript on the server side, you're probably thinking of something like Node.js. However, ServiceNow actually uses Mozilla Rhino, which is a JavaScript runtime written in Java, since the ServiceNow source code is written in Java. Business rules are triggered by database operations. So, as stated in the quote, anytime a record is inserted, updated, or deleted, or even queried, a business rule can run. Out of the box, there are over 2,400 business rules, so they're commonly used all throughout the system. Within a business rule, we, as the developer, have access to the current object, the previous object, and the scratch pad. So what does this mean? Well, for example, say we have a business rule that runs when a new incident is inserted to the incident table. Well, you can think of that specific incident as being the current object. So if we wanted to access the number assigned to this new incident, we could do something like current.number in a script. That's what it means when I say we have access to the current object. Alright, so here's a form view of a business rule. This specific business rule creates a new asset record when a new CMDB item is inserted into the table. So some of the most important fields contain the specific table that this business rule is running on. In this case, the CMDB CI table. The conditions for this business rule. And it turns out there's actually two conditions on business rules. There are the database operations. So you can see we have checkboxes for insert, update, delete, and query. And then we have custom conditions. So using the filter conditions field shown at the bottom, or using the condition script field shown on the right, we can specify when we would like this specific business rule to run. So in the condition to the right, we're saying we only want this to run if the current asset is nil. Or put another way, if the current CI record does not have an asset already associated with it. Or if the current asset CI does not equal the current sysid. So you can either use this scripting condition, or again, the filter conditions, where we would have access to all the fields on this table. So you can get very granular in when you want a specific business rule to run. And finally, there's a when field. So we can either specify if we want this business rule to run before the record is inserted, after the record is inserted, or a few other options as well. Alright, now let's take a look at an example. So for the purposes of this example, we'll say a user sends a request to the server for a specific incident. So this would be a query. The application server requests the record from the database server. The database server responds to the application server with the record. The application server checks for display business rules and then sends the response back to the user. So we have our display event that would fire any display business rules. Then the user modifies the incident record and sends an update request. The application server receives the update, checks for before business rules, then sends that data to the database server to be updated. The database server updates the record, and then finally the application server checks for any after business rules. So using this example of a user updating an incident record, we can see all of the points at which a business rule can run and be triggered. Alright, so now let's cover the use cases for a business rule. So for use case number 1, as we just saw, we could create an associated CI when a new asset record is created. And business case number 2 is when an incident is reopened, increment the reopen count. If you'd like to take a look at more examples, I highly recommend going to the business rules table and just examining some of the 2400 out-of-the-box business rules. But it's important that you do not update the out-of-the-box business rules. Alright, now let's take a look at a demo of business rules within inside of ServiceNow. So to start with, I'll go to the incident table by typing in incident.list in the application navigator, and this will take us directly to the incidents table. Now I'll click the hamburger menu in the top left and click Configure, Business Rules. So here we see a list of all incident business rules. We can see in the top right that there are 29 of them. Some are active and some are deactivated. For the purposes of this video, we'll go into the Incident Create Knowledge business rule. So on the When to Run tab, we can see that this runs after a new incident is inserted, and it's running on insert and update with an order of 100. We can also see that the Advanced checkbox is selected in the top right, so we do have the Advanced tab here. Under the Actions tab, we could set specific values if we wanted to without touching any script at all. But the Advanced tab is more commonly used, where we have complete control within the scripting environment. So here we can see we have a condition of when to run this script, and then the actual script, which is creating the new knowledge article. All right, let's take a look at another one. We'll go into the Reopen Count business rule and select When to Run. And we can see that this runs before the record is updated. And all this is doing is incrementing the reopen count by 1 every time that this event occurs. So if I type in business rules in the application navigator, under system definition, there's business rules, and this shows all of the business rules in the system. In the top right, we can see that we have 2,483 business rules. Hello, and welcome back. In this section, we'll cover client scripts within ServiceNow. The ServiceNow docs state, client scripts run on the client web browser. You can use client scripts to define custom behaviors that run when events occur, such as when a form is loaded or submitted, or a cell changes value. So as stated, client scripts consist of JavaScript that run on the client side. The majority of the time you'll use client scripts on the form view. So when you're within an actual record on the form view, you might use client scripts for when a specific value changes, you'd like to manipulate another field. Client scripts are triggered by field changes, page loads, form submissions, and cell edits. So if you're within the list view, you can fire client scripts when specific cells change as well. Client scripts are shipped to the browser. So you'll write your client script within ServiceNow, and then when a specific form loads that has that client script, it'll get shipped to the browser, and if it's triggered by when a field changes, it'll sit in your browser's memory until that event occurs, and then it'll run. This is an important distinction because an additional request and response to the server does not need to happen. The client script is shipped to the browser when the initial page is loaded. So the script logic runs almost in real time, unless, of course, it contains additional calls to the server. Alright, now let's take a look at the form view. So some of the most important fields are the table, which specifies when we would like this to run. So this runs on incidents. The UI type, which specifies if we would like this to run on desktop or mobile, or even both, which both is generally best practice, especially because the UI type must be both or mobile in order for this to run within the service portal. Then we have a type field, which is where we specify if we want this to run on change, so when a field changes, on load, on submission, etc. We have the field name field that shows up only when the type is on change. So you can read this as when the field name caller changes, we would like to run this script. And finally, the script field, down below, is where we'll place the actual JavaScript that runs within the browser. It's important to note that we do in fact have access to jQuery in this script, since this is running on the browser. but it's not always recommended to manipulate the DOM directly with jQuery. It's best practice to instead use ServiceNow's APIs when available. We'll discuss those APIs later on in the course. Alright, now let's take a look at a few use cases. So the first use case is we would like to highlight the caller field if the user is a VIP. So a lot of the times we place a special icon next to the caller field, or we might want to highlight it a yellow or some other color, only if that caller is in fact a VIP. The second use case is to run the conflict checker for change management. So when we're inserting a new change, there are certain triggers that will run the conflict checker automatically and check for blackout windows and other changes that are happening on that specific CI. Alright, now let's take a look at client scripts within ServiceNow. So to start with, we'll go back to the incident table. So we'll do incident.list. And we'll click the hamburger menu and click Configure. This time we'll click Client Scripts. So here are all the client scripts associated with the incident table. So for the purposes of this video, we'll actually go into the Highlight VIP Caller client script. So if I select the UI type, again we can see Desktop, Mobile/Service Portal, or All. The main difference between using Desktop or Mobile, Service Portal, or even All is that within a UI type of Desktop, we can use some of the older, now deprecated glide form methods, which we'll get to in section 6. But for new instances and going forward, it's best practice to only use the currently supported APIs. So I would highly recommend that you make all client scripts a UI type of all going forward. Now for the type field, we have onCellEdit, onChange, onLoad, and onSubmit. So if we have onChange selected, we have the field name. And this allows us to select any field on the incident table. So if that field changes, it'll trigger the execution of this script. And finally, we have the script here. So all it's doing is some logic and some CSS. So we have an image that is displayed next to the caller field if they are in fact a VIP. Now let's take a look at another client script. So we'll go into onLoad hello, which is a client script I use in the Glide Ajax section. But this specific client script runs on formLoad. For the purposes of this section, keep in mind that it's not important to focus on the scripting right now. We'll get into exactly what we're doing later on in the sections when we're discussing the APIs. For the purposes of this section, I just want to cover the different locations you can apply scripts to. So we'll definitely come back to the actual scripts that you're seeing here, and we'll discuss what's going on behind the scenes. And finally, if we type in client scripts within the application navigator, under system definition, we can click on client scripts, and this will take us to all the client scripts in the system. Hello, and welcome back. In this section, we'll be discussing UI actions. So, the ServiceNow docs state, UI actions add buttons, links, and context menu items on forms and lists, making the UI more interactive, customizable, and specific to user activities. UI actions can contain scripts that define custom functionality. So from this description, we can see that there's a lot going on with UI actions. UI actions can run server-side, or client-side, or even both. UI actions can be buttons, menu items, or links shown in the images here below. UI actions are typically configured for form views, so you'll generally only see UI actions within a form view of a record. Alright, so let's check out the form view of a UI action. So some important fields are the table. So in this case, we have this UI action running on the problem table. We have show on insert or update buttons. So when selected, this specific UI action will only show on updates. So if we're inserting a new record for the first time, in this case a new problem, this UI action will not appear. Then we have the client checkbox. So if we select this, we'll instruct ServiceNow to run some JavaScript on the client side as well. Then we have what type of UI action this will be. So on the right, we have form view button, context menu, form link, list banner button, list bottom button, etc. We also have a condition field, so we can specify specifically when this UI action will show. So in this case, we only want this to show if the current user has the ITIL role and the current problem record's RFC field is nil or does not contain a value. And finally, at the very bottom, we have the script field where we apply any server-side or client-side logic we would like to execute. Alright, so now let's take a look at server-side UI actions. On the server side, we have access to the current object. So again, if this was on a problem record, we would have access to that current problem record's fields. We also have access to the Glide Record API and the Glide System API, and really any server-side API. Again, we'll discuss more about these APIs later on in the course. Server-side UI actions are generally the default behavior. So in order to have a specific UI action be client-side, you'll actually need to select the client-side checkbox. It depends on what you're doing within the specific UI action, but generally they offer better performance since they are on the server as opposed to being on the client side. Alright, so let's take a look at client-side UI actions. So if we would like a specific UI action to be client-side, again, we would make sure that the client-side checkbox is selected. By selecting the client checkbox, we'll then see an onClick field. And the onClick field, we specify the name of the method we would like to invoke when the user either clicks this button or link, etc. So in this specific example, when the user clicks this UI action, the resolve incident function will be called. We can use the action.setRedirectURL to redirect the user to another page within ServiceNow. We can even call other UI actions on the current form by using one of the following. So gsft submit, and then gel, and then passing in the UI action name, which is specified in the action name field, or using gsft submit, and then passing in the keyword null, gform.getFormElement, and then the UI action name. Now finally, if we would like to run server-side and client-side JavaScript, we could do so by selecting the client checkbox, specifying an onClick method, and then creating the onClick function. So the order of operation in this scenario would be first, when the user clicks the UI action, the client-side code will run. Then for our server-side code, we would actually place that within an if statement. So we'll do if type of window equals undefined, then we'll either call a server-side function or place the code directly in that if statement. And all this if statement is saying is if a window currently exists, which is your browser window. So for this example, if the window does not exist, then it's safe to assume that this is on the server side, and we can place our server side logic here. Alright, now let's take a look at two use cases for UI actions. So in the first use case, we'd like to trigger a Salesforce integration, which creates an associated Salesforce ticket. In the second use case, we would like to reject an approval record. So when the user clicks reject, that'll actually mark that current approval record as rejected. Alright, now let's take a look at UI actions within ServiceNow. So to start with, we'll head back to the incident table, we'll click the hamburger menu, and we'll click Configure UI Actions. To start, we'll go into the Close Incident UI action. And we can see here that this only shows on update, and that it is in fact a form button. Then under the Condition tab, we only want this to appear if this current condition evaluates to true. Finally, we have the script below, which sets the incident state to closed and updates the incident. Now let's take a look at the Create Change UI action. So for this one, we can see that this is a form context menu by the checkbox on the right, and this only runs on update as well. Alright, now let's find a client-side UI action. So we'll go into the Reopen Incident UI action, and we can see that the client checkbox is selected, and that on click, we will invoke the Reopen Incident function, which is defined here in the script below. So everything within this function is client-side code. Then on line 18, we say if type of window equals undefined, we would like to call the server reopen function. And then all of the code within the server reopen function is server-side code. So we have access to the current object. Hello, and welcome back. In this video, we'll take a look at UI policies. So the ServiceNow docs state, UI policies offer an alternative to client scripts for dynamically changing information on a form. Use UI policies to define custom process flows for tasks. So UI policies are client-side logic, and probably about 99% of the time require no scripting at all. UI policies are typically used on forms to do things like set a field to read-only or mandatory, or even show or hide that field based on certain criteria. UI policies are a way to set an action on a field based on certain conditions without scripting that logic. So how is this done? Well, let's take a look at the form view. So first we have the table. So in this example, you can see that we have the asset table here. And then you specify a condition. So there are a set of conditions when this UI policy runs. It runs if the substate is pre-allocated, and if the class is not consumable, and if the class is not software licensed. Then at the bottom of the form, we have UI policy actions. And this is where we select what fields we want to set to mandatory, visible, or read-only. So in this screenshot, we have the install status being set to read-only, the assigned field set to hidden, and the location field set to read-only. Finally, there is the ability to run scripts. If the Run Scripts checkbox is selected, then we get script fields to execute if our conditions evaluate to true, as well as if they evaluate to false. Now let's take a look at two use cases for UI policies. The first use case sets an incident short description field to read-only if the incident state is closed. In the second use case, we'd like to hide an incident's resolution notes field if the state is open. Now let's take a look at UI policies within ServiceNow. Alright, so we'll navigate to the incident table. We'll click the hamburger menu and click Configure UI Policies. And we'll go into the Make Fields Read-Only on Close UI policy. So here we can see that the condition is if the incident state is closed, then we would like to do the following under the UI actions. And essentially we have a number of incident fields, and we're setting all of those to read-only. If we go into one of these UI policy actions, here we have the ability to select the field name, in this case opened, and then we have the ability to set whether we want this to be mandatory, visible, or read-only. Now let's go into the Show Close Code and Notes if closed or resolved. So here we can see that this runs if the incident state is resolved or if the incident state is closed, or if the state is resolved or state is closed. And what does this run exactly? Well, the UI policy actions have two records, the close code and the close notes, and we're setting those to mandatory, as well as visible. Alright, now let's look for a UI policy that has scripts. So we'll do run scripts is true and search. And now we'll go into shown basic auth user and password if use basic auth is true. So on when to apply, we can see that this will run if the use basic authentication is set to true. So under the script tab, we see that we're running one line of JavaScript on line 2. Keep in mind these scripts are client-side. So let's go into one more. We'll go into the pre-allocated constraints. And we can see that in the execute if true field, we have 4 or 5 lines of JavaScript here. Hello, and welcome back. In this video, we'll take a look at script includes in ServiceNow. So the ServiceNow docs state, script includes are used to store JavaScript that runs on the server. Create script includes to store JavaScript functions and classes for use by server scripts. Each script include defines either an object class or a function. Script includes run only when called by a server script. So script includes are in fact server-side JavaScript, and they're used to store JavaScript classes and functions or methods. You can think of script includes as reusable snippets of code that you might reference or invoke from another place in the system. It's important to know that a script include only runs when it's invoked from another place. So just because you create a script include in the script includes table, unless you call that script include from somewhere else in the system, then that script include will never run. Script includes are unique since they can be called from anywhere. They can be called from the server side, and they can also be called from the client side, as we'll see here in just a second. So let's take a look at the form view of a script include. First, we have the name, which is important because we'll use this name to call this script include in other places. So it's always important that we give it a unique and meaningful name. Then there's a client callable checkbox, and if this is checked, the system will auto-generate some JavaScript for us in the script field and make it extend a Ajax class. We'll get to this more in section 7, so don't worry about the details for now. Just know that if the client callable checkbox is checked, then we can invoke this script include from the client side. And finally, at the bottom, we have our actual JavaScript and the script field. Now let's talk about some script include characteristics. So there are two types of script includes. There are classless script includes, where there is no JavaScript class being created. These script includes must have the name of the script include equal to the function name. So you see here on the right in the image, the name getFormUIAction of the script include must be the exact same as the name of the function in the script field, getFormUIAction. These classless script includes are server-side only and cannot be invoked from the client side. Now, on the other hand, in a class script include, these can be invoked from the client side or server side, and they typically extend another class, like shown here in this image, how this agent schedule Ajax is extending the abstract Ajax processor. Again, we'll talk a lot more about the specifics and what's going on in the script fields in section 7. But for now, just know that there are classless and class script includes. Some important attributes to a script include is the script include name, which as stated is used to invoke this script include from somewhere else in the system. The type property, which will automatically be generated for us when we provide a name in the script include name field, and the prototype property, which we can use to extend a class in JavaScript. Alright, now let's take a look at extending script includes. So any class may be extended. A script include can extend another script include. This makes them very modular. So a common script include that's extended from is the abstract Ajax processor. So the abstract Ajax processor comes out of box, and it gives us helper functions so we're able to call the extended script include from the client side. The syntax we use to extend another class is the class name .prototype equals object.extends object, where we pass in the extending class name as the first argument, and then our script as the second argument. We generally don't have to type this out if we're extending the abstract Ajax processor. By checking the client callable checkbox, the system will automatically generate this code for us. Alright, now let's quickly take a look at two use cases. So in the first use case, we're simply creating commonly used helper functions and storing those in a script include. So maybe we perform a calculation so often that we abstract that calculation in its own script include. So then we can just call this script include, passing in a few arguments, and we don't have to keep writing out these calculations every time we reference them. In the second use case, we call a custom function via Glide Ajax. And as stated before, Glide Ajax is a ServiceNow API that we'll discuss in Section 7. Alright, so now let's take a look at script includes in ServiceNow. So if we type in script includes here, we can click on the script includes module under the system definition. And here is a list of all of the script includes in this instance. You can see that we have roughly 1,300 script includes. It's important to note that we didn't access this page by first going to something like the incident table, clicking the hamburger menu, and clicking configure script includes. That's because these script includes aren't tied to a specific table or application. You can think of these as being more modular, so you can reference these script includes from anywhere in the application. Alright, so let's jump into a script include. We'll go into this out-of-the-box SAML2 update 1 script include, which stores a lot of the code that is used when the SAML2 plugin is enabled. We can see that the client callable checkbox is not selected, and that there are many methods created in the script field. Now let's go back and check out the state flow script include. We see a number of methods in this one as well. Now let's go into a client callable script include. So we'll filter client callable equals true, and we'll select the CSP utils. These are helper functions for the consumer portal. So in this one, we can see that the client callable checkbox is selected. And that on line 2, we see the name of the script include, CSP utils.prototype equals object.extends object abstract Ajax processor. So this is extending the abstract Ajax processor script include. And this has a number of methods as well. Hello and welcome back. In this video, we'll take a look at scheduled jobs in ServiceNow. The ServiceNow docs state, scheduled jobs are automated pieces of work that can be performed at either a particular time or on a recurring schedule. Scheduled jobs are server-side JavaScript, and we typically schedule them when to run, hence the name scheduled jobs. However, there is an execute now button for testing purposes. So if we have a scheduled job with some JavaScript that runs once a month, we can also click the execute now button to test our scheduled job and run it immediately. Scheduled jobs gives us the ability to schedule reports, scripts, charts, and other cool things. When we go to create a new scheduled job, we get a series of questions asking us what we would like to do with this new scheduled job. Typically, when creating a scheduled job, you'll either be running a report or running a custom script. Scheduled jobs are very flexible on when you would like them to run. They can be scheduled for daily, weekly, or monthly, periodically, once, or even on demand, where you can provide a condition in the condition field. You can trigger scheduled jobs in server-sided scripts by using the following method: snc trigger synchronizer .execute now. Now let's take a look at the form view of a scheduled job. So first we have the name of the specific scheduled job. We also have an active checkbox. So if a scheduled job is not active, then it will not run, which is nice because then we can create a scheduled job, configure everything, and then just simply use the active true or false if we would like it to be scheduled or not. We also have the run field. This gives us the ability to select whether we want this to run monthly, weekly, daily, etc. Because we have monthly selected, we also have the ability to provide a day. So what day of the month would we like this to run? As well as a time field. So this is running at 3 a.m., the first of every month. Then in the run this script, we have our server-side JavaScript that we are running here. Finally, there is a execute now UI action that when clicked will run the script in the run this script field. Alright, let's take a look at a couple use cases for scheduled jobs. So in the first case, we're just simply scheduling a monthly report. So maybe we would like a report of all of the incidents within the last month scheduled to run on the first of every month. In the second use case, we schedule a script to retire old records from a specific table. So maybe we have a custom application and a specific table holds some type of active record. And if they go over a certain threshold, or if they're so many days old, we would like to delete or simply deactivate these records. So we can do so in a scripted scheduled job. Now let's take a look at scheduled jobs within ServiceNow. So in the application navigator, I'll type in scheduled jobs, and under system definition, we'll click scheduled jobs. This will take us to a list of all the scheduled jobs in the system. So if we go into trend of closed incidents, we can see that this runs monthly on the 1st at 3 a.m. and it executes the code in the run this script. If I click the New button, we'll be taken to an interceptor where we have a list of available options. So if we would like to generate a scheduled report, or generate a type of record from a template, or even run a custom script, we can do so by selecting the link in the blue. So for this, we'll select automatically run a script of your choosing, and here we can see that we can specify the run choice, so we can run it once on a specific date and time, or we can run it periodically. So we specify a repeat interval, number of days, hours, and starting date and time. There's also a run on demand option, where we can provide a condition where if evaluated to true, we'll run the script in the run this script field. Hello, and welcome back. In this video, we'll take a look at workflows, specifically scripting and workflows. First, let's cover some basics on workflows. The ServiceNow docs state, the workflow editor is an interface for creating and modifying workflows by arranging and connecting activities to drive processes. So you can think of workflows as automated sequences of activities. And it's in these activities where we'll actually be writing JavaScript. Workflows are server-side JavaScript and do not get executed on the client side. There are many different locations to script in a workflow, since there are many different activities that offer a scripting component. There's also different scopes in a workflow. So what data do you have access to when you're scripting in these workflow activities? We'll go over that in just a bit. Workflow contexts are created when workflow conditions evaluate to true. So, for example, if I create a new change, and that change is of type comprehensive, then a new workflow context is created using this comprehensive change workflow as its blueprint. Workflows also have versioning, and there's a checkout and publish feature. So you can check out a workflow which will essentially create a new working version, and it won't affect the currently published workflow version in the system. Now let's take a look at scripting and workflows. Scripting and workflows should be looked at as somewhat as a last resort. There's many out-of-the-box features in the workflow engine, specifically many out-of-the-box activities that should be used in place of scripting. So only use scripts if the out-of-the-box features or activities aren't enough. Some of the most common activities that support scripting are approval activities, the run script activity, if, switch, and wait for condition activities, the create task activity, notification activities, the scriptable order guide activity, and rest message and soap message activities. I recommend checking out the wiki article and the link below for a comprehensive guide to all workflow activities. As a developer, it's a good idea to read through these lists of activities to know what exactly is available to you with the out-of-the-box activities. Alright, now let's talk a little bit about the scope you as the developer have while scripting in a workflow activity. So for example, if this specific workflow is on the change table, then we'll have access to the current record or the current object. This current object stores all of the field values for this current change. We also have access to the workflow.scratchpad object. And it's here where we can share values between activities. So if we write something to the scratchpad in one activity, we can access that from another activity. There are also activity-specific variables that are only defined within specific activities. And of course, there are local variables where we define local variables within an activity. So if we're in a if script activity and we define a local variable there, then we can only use that variable within that activity. Scopes can be a little tricky at first, so I recommend playing around with workflows to get a feel for what you have access to. Also, I highly recommend the wiki article shown in the notification below for more information on general scripting within workflows. Now let's go through some of the most common workflow activities that use the script field. So the first one we'll take a look at is the if condition. The ServiceNow docs state, the if activity checks a condition or script to determine if a yes or no transition should be taken. If the workflow creator specifies both the condition and the advanced script, both must evaluate successfully for activity to take the yes transition. So in the image shown in the bottom left, we have an if condition activity, any user approvals, and in our script, we're finding if a specific variable on the workflow.scratchpad has any value assigned to it. If it does, we return yes. If it doesn't, we return no. And it's this code that determines which path the workflow takes. It's important that you set the answer variable to either yes or no. You're not using Boolean JavaScript values true and false. You're actually using the string text yes or no. Now let's take a look at the wait for condition. So the ServiceNow docs state, the wait for condition activity causes the workflow to wait at this activity until the current record matches the specified condition. The workflow evaluates the wait for condition activity each time the current record is updated. Use this activity to pause a workflow indefinitely until a particular criteria is met by a record update. So a wait for activity will cause the workflow to wait at this point in time until the logic evaluates to true. And it gets evaluated every time that record is updated. So in the image shown on the left, we have a check all subtasks are an active wait for activity, and we're running a glide record query and setting the answer variable to the return value of has next. This condition script gets evaluated every time that this record is updated. For now, don't worry about the actual code in the condition script. We'll cover this specific API in section 4, glide record. For now, it's just important to understand what the actual wait for condition is doing. Now let's take a look at the approval user activity. So this activity creates a user approval, and the answer variable must be set to either a comma-separated list or an array of the user or group sysids that we would like to send the approval to. So in this approval user activity, we have complete control over who we're assigning these approvals to with the additional approver script. And now we'll take a look at two quick use cases for workflow scripts. In the first use case, we want to dynamically assign approvals to a specific group of users. And in the second use case, we would like to trigger a web service call via a workflow activity. Now let's take a look at workflow scripting within ServiceNow. So to start with, I'll type workflow in the application navigator, and we'll open up the workflow editor. This will open up a new browser tab, and we'll search for change. We'll start by going into the comprehensive change workflow. So you can see here that each one of these rectangles is a workflow activity. Each workflow has a begin and end state, and then we define the flow with the activities in between the begin and end states. So we'll open up this first run script, and we can see here that we're just simply setting the current change's approval to requested. We also have a manager approval, user approval activity. As well as some other activities. On the right, if I go to the core tab, you can see all of the out-of-the-box workflow activities that are available to us. Under the conditions group, we have if statements, a switch statement, the wait for condition, or wait for workflow event. We also have the run script activity under the utilities section. Now let's go into the out-of-the-box item designer, generate approvals for current sequence workflow. So in this workflow, we have an if statement that branches, and if we open up this activity, we can see that we're setting the answer variable to yes or no, depending on if there is a user approval IDs variable on the workflow scratchpad. There's also a few run script activities. So in this run script, we are saving the user approvals result to the scratchpad. If I click the hamburger icon in the top left and go to Properties, we can see the properties of this specific workflow here. that it is in fact on the SC-Rec item table, and it is in a published state. Hello, and welcome back. In this video, I'll provide a rough guide on where to customize, and then we'll cover APIs. Alright, so as the title hints, this should only be used as a rough guide on where to customize. So first you should ask yourself if you'll be customizing on the client side or server side. If client side, ask if you're setting a specific field to required, read-only, or visible. If the answer is yes, you'll typically use a UI policy. If the answer is no, you'll typically use a client script. If the original question, client or server, was server, then you ask yourself, is it on a record action? So do I want to run a script when a new record is inserted or updated? If the answer is no, ask yourself, will this be a button or menu? If that answer is yes, you'll typically use a UI action. If that answer is no, you might use a script include. If the on-record action is yes, you'll typically use a business rule for this. Again, this guide only considers 5 scripting locations, which are the most common, but keep in mind that this is a rough guide and should just be used as a general template. Alright, so now let's talk about APIs, or Application Programming Interfaces. So an API provides building blocks to help you, the developer. APIs define how to interact with a service or system, and they provide ways to do common tasks. So if, for example, you wanted to retrieve a record from a database, you would do so by using ServiceNow's Glide Record API. This API provides a layer of abstraction so you, the programmer, don't have to mess with writing the actual SQL statements and handling the returned records. The Glide Record API does that all for us. Some of the most popular ServiceNow APIs are Glide Record, Glide System, Glide User, Glide Form, Glide Ajax, and Glide Date Time. There are many more ServiceNow APIs available to you, so I recommend checking out the link below to review all of the APIs. Throughout the rest of this course, we'll go into each one of these APIs in much greater detail. To help solidify our understanding of what an API is, let's go over an analogy. So for this analogy, we'll say our goal is to build a house. Well, in order to build a house, we need materials for the house. So this can be thought of as scripting locations. We need the foundation, doors, electrical, and other materials as well. Then in addition to the materials, we also need tools to help us construct a house from the materials. We can think of these tools as being the APIs available to us. So we have our Glide Record, which acts as our hammer, our Glide System, which acts as our screwdriver, etc. So coming back around to the scripting locations within ServiceNow, we can see that we've covered business rules, script includes, client scripts, UI actions and UI policies, schedule jobs, and workflows. The APIs that we will discuss in the rest of this course generally fall into 2 categories: client-side APIs and server-side APIs. Server-side APIs can be used in any server-side scripting location, and client-side APIs can be used in just about any client-side scripting location. So you should start to see that the locations of the scripts aren't as important as knowing how to interact and work with the APIs. So where can I use this? We talk about the the scripting locations and the different APIs, but where can I, the developer, actually use certain features within ServiceNow? Well, as I stated, components are typically broken up into two categories, the client side and the server side. On the server side, we have things like business rules, and on the client side, we have things like client scripts. On the server side, we have script includes, as well as UI actions, and we also have UI actions on the client side as well. So, these are the scripting locations. But what about the APIs? Well, it turns out that we can use the Glide User and Glide Form APIs on the client side. So these are typically referred to as client-side APIs. And we can use the Glide Record, Glide System, and Glide Date Time APIs on the server side. If you're still a little confused as to what is going on, bear with me. In the next few sections, we'll actually get into the APIs and discuss and take a look at what they actually do. Hello, and welcome to Section 4. Now that we've reviewed where we can apply scripts and introduced the concept of an API, it's time for us to look at our first ServiceNow API, the Glide Record. We'll start this section with an introduction to Glide Record, followed by a quick analogy to help solidify our understanding. We'll then jump into the Show Me the Code section, where we'll go over a brief snippet of code to show you what exactly the API looks like in a scripting environment. After that, we'll cover a very important topic in ServiceNow called dot walking. Next, we'll cover the Glide Record API diagram, where we'll take a look at some of the properties and methods associated with Glide Record. We'll then look at a list of common Glide Record methods and discuss the functionality behind them. After that, we'll discuss the stages of a Glide Record, and then we'll walk through the acronym CRUD and how it applies to the Glide Record. Once we've covered these topics, then we can finally jump into ServiceNow and actually start writing some code and background scripts. After the demo, we'll discuss Glide Record Secure and the Glide Aggregate API. And finally, we'll end the section by discussing when we can use these APIs, a little bit about best practices, and then go over the API documentation. Finally, at the end of this section, you'll find exercises as well as quizzes for you to try. Alright, so before I introduce the Glide Record, let's first talk about a fundamental concept about web applications, or really just any application that persists data, which means that stores data for long term. So let's say we have our application server here on the left and our database server on the right. Let's say we would like to access data that is stored in the database. For example, we'd like to access data about a specific incident. Well, because ServiceNow uses MySQL as its database, and since MySQL is a relational database management system, we'll have to write some SQL in order to retrieve the data. But it turns out SQL can be a bit tricky and just really not very fun to work with. So we as the developer want an easier way to access and interact with this data. It turns out we can do so by introducing an API specifically designed to do just this. Here we have what we'll call our database API for now, which kind of acts like a middleman. As the developer, instead of writing SQL, we can access data in the database by interacting with the API via JavaScript. Because we've introduced JavaScript, now we have the power of a full object-oriented programming language at our fingertips. This gives us a level of abstraction that helps with security, ease of use, and powerful helper functions. Well, it turns out this database API is called Glide Record, which is what we'll be discussing in this section. Glide Record is the most common API you will use as a ServiceNow developer. This API is accessible to the developer on the server side and is used for any type of database operation, commonly summed up with the acronym CRUD. CRUD is an industry term used to refer to the 4 functions of persistent storage, which are create, read, update, and delete. Anytime you need to read an existing user record, create a new incident, update an existing problem record, or delete a change, you will use the Glide Record API to perform the database task. As mentioned before, this API generates the SQL for us, so we as the developer don't have to worry about writing SQL from scratch. We can think of the Glide Record as having 2 stages. In the first stage, we build out the actual query. So we'll select the table we want to query on and start to build out the filter that we apply to the SQL. For example, we could say we want to show all priority 1 incidents that were created within the last 2 weeks. Again, we can create this filter, and this happens within the first stage. Once the first stage is complete, the actual SQL is sent to the database where the records are received back from the database, and you can think of the second stage starting at that point in time. Now, in the second stage of our Glide Record, we can think of this as a collection of records or a list of records from the queried table. This is where we do the actual processing of the records. So, for example, if we wanted to update specific fields or even delete certain records, we could do so here. In this stage of the Glide Record, you can think of it as being an ordered list of records. For example, when we view a list of incidents on the incident table, Glide Record is being used behind the scenes to query the database and retrieve the data related to a specific filter of incidents. Alright, so before we go any further, I'd like to first introduce you to the Show Me the Code slide. Now, I understand this slide may be a bit overwhelming to some of you, but don't worry. We'll cover all of these topics later on in this section. The goal of this slide, as well as the Show Me the Code slides in future sections, is to give you a practical example as soon as possible, providing you, the student, with a holistic approach. Now, I could talk for hours on the theory and concepts of Glide Record, but that wouldn't do you, the student, much good in learning this topic for the first time. This is why when I've taken programming courses in the past, I've always enjoyed instructors who take a moment early on when introducing a new concept to show some actual code. So if you do not understand a certain concept in this slide, or in future Show Me the Code slides, feel free to even skip this slide and power through the rest of the section. Alright, so in this example, we'll start simple. We'd like to print a list of all priority 1 incidents to the screen. Now, let's walk through this line by line. On line 1, we are instantiating an object by calling the new keyword along with the constructor Glide Record. We pass in 1 argument, which is the system name of the table we'd like to query. This is simply a string type. We then assign this to a variable named incident.gr for Glide Record. Note that it is best practice to give meaningful names to variables, such as incident.gr instead of simply gr. Throughout this course, when I am teaching the concept of Glide Record, I will typically use the name of the table or record that I will be querying from, along with a capital GR afterward to signify that this is a Glide Record object. But feel free to come up with your own convention, as long as it's related and has some type of contextual meaning to what you are doing. So now that we have the Glide Record object assigned to the incident.gr variable, we can start to call methods on the object. On line 2, we can call the addQuery method, which accepts 2 arguments. First, a string, which is the name of the record's field we would like to filter on, and the second argument is the system value. This addQuery method is very similar to something you would see in the GUI interface or the backend of ServiceNow when you apply a certain filter to a table. So even on the incident table, if you click the filter icon, you can apply these conditions to the filter. Well, it turns out that this GUI interface is actually using the Glide Record API in the background and using something very similar to what we've defined here on line 2. On line 3, we perform the actual database query operation, which generates the actual SQL for us, sends it to the database for it to get processed, and then returns the records to us in a JavaScript object. It's the query method that ends stage 1 of the Glide record and starts stage 2 of the Glide record, where we can then think of everything after this line as a list of records, in this case, incidents. On line 4, we can use a JavaScript while statement to loop through all of the returned records. We use the Glide record next method to determine if there is another record in the array. If so, we continue to line 5. So finally, on line 5, we use another ServiceNow API, Glide System, which is referenced with GS, in order to print the incident number to the screen. Note that we are able to access the number field by simply adding a period followed by the name of that field. Alright, now let's take a step back and I'll provide a very simple analogy for Glide Record. And this analogy will be buying groceries at a grocery store. And the process is as follows. First, we'll select which grocery store we'd like to go to. This can be analogous to selecting a database table to query. Second, we'll grab a shopping cart in the store. The cart can be thought of as the Glide record object. Third, we'll place groceries in the shopping cart. The groceries can be thought of as records from the table. Every grocery item has specific attributes to it, like the name, its price, and color. These item attributes can be thought of as field values for a record, like the caller on an incident record. Finally, it's time to check out at the cashier. This last step can be thought of as performing some kind of action on the records, whether they are for display, updating, deleting, or even creating new records. Alright, so let's kind of apply this analogy to a real-world example. So again, using our first example we discussed in the Show Me the Code section, we'd like to print all incidents to the screen that have a priority of 1. While these steps may vary depending on the Glide record methods that you are using, there are typically 4 steps involved in this process, just like we saw in the analogy. The first step is selecting a table to query. In this example, it's the incident table. In the second step, we build our filter if required. Again, in this example, it's priority 1 incidents. The third step is where we tell ServiceNow to make the actual query against the database table along with our arguments. This is when the Glide record actually generates the SQL, runs it against the MySQL database, and processes the returned rows into a Glide record object. Again, this kind of marks the end of stage 1 and the start of stage 2. Finally, the fourth step is where we would process these records, whether we would just be querying them, deleting them, or updating them. In this example, we're just simply printing the numbers to the screen. We'll talk more about the stages in the third video in this section. However, for now, you can think of steps 1, 2, and 3 as being in the first stage, the build query Glide record stage, and the fourth step in this diagram as being in the second stage, or the process record stage. It's important to note that any ServiceNow table, so any of the 2,400 out-of-the-box tables or any new tables that you create, can be queried using this Glide record API. Hello, and welcome back. In this video, we'll go over the concept of dot walking. We'll introduce the Glide record API diagram, And we'll also go over a scripting example where we map out the API. Alright, so dot walking is a very important and powerful concept in ServiceNow and is used all throughout scripting. So it's crucial that we cover this topic now. As I've stated before, ServiceNow is based on a relational database system. So we have the concept of primary and foreign keys. If you don't know what these are, don't worry about it. The topic is out of the scope of this course, but just know that these keys are used to form relationships between tables. If you'd like to know more on primary keys, check out the Dive Deeper notification below and click on that wiki article. Alright, so for example, let's say we have 4 tables. Table A has a total of 4 fields, 3 of which are string fields, and the 4th a special kind of reference field. Table B has a total of 5 fields, 3 of which are string fields, and 2 are reference fields. Table C has only 3 string fields, and finally Table D has 2 string fields. Let's start by looking only at Table A and B. We can say that as long as field 1 in Table B is always unique, that this could be used as our unique key. Put another way, if we can guarantee field 1 is always unique, we can use that then as a reference in Table A, which is going to be referencing that specific record in Table B. Now let's take a look at Table B and C. We can also have a reference to Table C, which is stored in Table B. In addition, we can also have a reference to Table D, which is stored in Table B. It turns out that we can have as many references to other tables as we want, or that makes sense. This is very common in the world of CMDB and asset tables. So why are these reference fields so important anyways? Let's say we queried Table A in a glide record script, but we wanted to access a field from Table B. Well, we can do this since Table A has a reference field to Table B. All we need to do in the script is use a period or dot to walk to the next table. We can even dot walk from Table A to Table C or D since Table B has a reference field to Table C as well as Table D. To solidify our understanding, let's look at a real-world example. In this example, we will be querying the incident table. However, we would like to find the caller's location. It just so happens that this will include 3 separate tables inside of ServiceNow. The first table is the incident table, which we will be using for our initial glide record query. The second table is the user table, which has a system name of sys_user. And finally, the third table is the location table, which has a system name of cmn_location. So on the incident record, there is a reference caller field. Here you can see Businessman Bob is already populated. Below are some additional details about this field. We can see that to access this field, we can use incident.caller_ID, where caller_ID represents the field name, which is shown here as the field. This field is stored on the incident table, which is a type of reference that references the sys_user table. Now, if we click the information icon next to the related record, we'll be taken to the user record, which is stored on the sys_user table. We can see that on the user record, there is a field called location, which in turn references the location table named cmn_location. Finally, if we click the information icon on the location field of the user record, we'll be taken to the actual location record on the cmn_location table. Here we can see that the name field on the location table represents the physical name of the location, in this instance, Columbus, Ohio. Also, it's important to note that this is just a string field and not a reference field. So now let's look at what this code would actually look like. On lines 1 and 2, we are using glide record get method. We'll go more into the get method in the following slides, but just for now, know that this is grabbing a specific incident record via its sysID. The important thing to note here is that we are on the incident table, yet we can still print the name of the location the current caller is at by simply writing incidentgr.callerID.location.name. This prints Columbus, Ohio to the screen. To recap, dot walking is very powerful and found all throughout ServiceNow. It is possible due to the nature of relational databases. We are able to leverage reference fields to grab values from other tables without actually querying each table. We'll use dot walking all throughout the rest of this course. Alright, now let's go over the glide record API diagram. If you know what UML class diagrams are, then this should look familiar to you. But if not, don't worry, we'll cover everything you need to know. So this is an API diagram that I'll be using throughout the rest of this course for any API we discuss. You can see that at the top we have the name of the API, in this case glide record, and the green ovals on the left represent properties or general topics associated with this API, while the rounded rectangles on the right represent the methods or functions associated with this API. It's important to note that oftentimes the properties associated with an API are actually private and are only accessible through getter methods. So a lot of the times, if we are setting or even getting properties, we would be accessing those via methods instead of directly. So within the glide record API process, so to speak, we define a table and a query, and then once we send this query to the database, we'll receive records as well as the record fields. And on the right are some common glide record methods, such as add query, set limit, add encoded query, etc. We'll cover these methods in the following videos, and we'll actually dissect them and get a better understanding of what they're actually doing. But for now, I just wanted to introduce you to this API diagram. So in the next slide here, let's go ahead and run through a code example and map out the methods and properties to our API diagram. We'll start with the glide record constructor, which accepts one argument, the name of the database we're looking to query on, as a string type. This is stored within the table variable. Next, we will call the add query method, passing in two arguments, priority, which is the incident field we'd like to query for, and 1, which represents the priority 1 field value. Glide record takes these values and gives us a nice query string that ServiceNow can then use to generate SQL for us. Again, the actual query string that's generated from this add query method can be shown within the query string property. On line 3, we call the query method, which takes all of the data we've added to the glide record object, incident.gr, and performs the actual database query operation, where it then packages up the return results and reassigns it to the incident.gr variable. Then we use the next method, which will iterate through our glide record object or list of records returned by the database. Then, once within the while loop, we can finally start to process this data. In this case, print the number of the incident. So again, the purposes of this slide was to show you some code and map the properties and methods to the class diagram. We'll see these class diagrams come up in the following sections throughout the rest of this course. Hello, and welcome back. Now let's go through a list of common glide record methods. This is not an exhaustive list, but a list I came up with that I believe represents some of the most popular and important methods. In the next video, we'll actually demo these methods in background scripts within ServiceNow. But for now, hang tight. So first we have the query method, which we should be fairly comfortable with for now. Within the previous videos, we've seen it used a couple times. This method is what actually calls the database and sends the SQL that was generated from the other methods that we used. Next is the new record method. This is used when inserting a new record into a table with glide record. This method creates a new record, sets any default values for that record, and then generates and sets the sysID. We then have the insert method, which is used to insert the record after setting field values. We have an update method, which is similar to insert, but instead of inserting a new record, it would update an existing record with the field values that we updated. Next is a delete record, which I'm sure you can guess deletes a record. We also have a add query method, which adds filters to the SQL query. We've seen this in the past couple videos. Next is an add encoded query, which is very powerful and accepts an encoded string, which we'll see in the next video. It essentially takes this encoded query, processes it, and generates the SQL for us. It's very similar to the add query method, but as you'll see within the next video, can be a little more powerful and requires less code. Then we have the hasNext method, which returns a Boolean value if there is another record in the glide record to loop through. Then we have the next method, which performs the actual iteration. Next is the get method, which is a shortcut for grabbing a specific record. Then we have order by, which accepts a field as its argument, which will order the list of records in ascending order based on this field. We also have the order by descending method. Finally, we have a can create, can write, can read, and can delete method, which use ACLs within the system and determine if the current user has the ability to create, write, read, or delete. These are commonly used within script includes, which we'll see in the following sections. Alright, now let's discuss the two stages of a glide record. We can think of the first stage as the building query stage. This is where we build the query using JavaScript, which will then generate SQL for us and run that against the database. So in the building query stage is where we actually define the filter conditions. So here on the left we have our glide record API diagram, and on the right we have our database, in this case MySQL database, where our data is stored in ServiceNow. So the awesome thing about glide record is it allows us to query the database while only using JavaScript. We don't actually have to write the SQL statements. So it essentially takes our JavaScript. In this case, our table is incident and our query is priority equals 1. So all priority 1 incidents. And the glide record API works its magic and takes this JavaScript and spits out the actual SQL that will run against the MySQL database. So for example, in this case, select star from glide record table or incident, where glide record.query or our priority equals 1 query. So again, all of this is happening within this initial build query stage, or the first stage. So how do we build these queries? Well, we have two options. In the first, we can use the chain methods, where we can chain a number of methods together, like add query, add or condition, add null query, add not null query, add active query, or add inactive query. Or the second option, we can use encoded queries, which use the method add encoded query. So let's take a look at the first option, the chain methods option. So with this option, we will add these methods or chain these methods to the current glide record object. As shown in the script here, we can see on line 1, we create our glide record, and then we start to chain methods onto it. So this query reads, find all priority 1 incidents or priority 2 incidents that have a category of hardware or software and were created after 2017 January 1st that contain a short description, or short description is not null. So again, this is the first option to stage 1. So next, let's take a deeper look at the add query method, since this is one of the most important methods in option 1. So add query accepts either 2 or 3 arguments, and there's a pretty big difference between the two. The add query method either accepts 2 or 3 arguments. If we only pass 2 arguments to the add query method, we would be passing the field name as our first argument, and then the field value as our second argument. In this example, the field name is short description, and the field value is test. If we decide to pass 3 arguments in, again, we pass the field name as the first argument. However, for the second argument, we pass an operator, in this case, contains. And then as the third argument, we have the field value. So with 2 arguments, we have the field name and field value. With 3 arguments, we have the field name, field value, as well as the operator that sits between them. Below are 2 lists of operators that we can pass in. The first list is used for number fields, so we can do things like if this number is greater or equal to another number. And we can use the second list with strings. So does a string contain this value, or does a string start with this value, etc. In this example, we're saying, does the short description contain the word test? Note that if we only pass in 2 arguments to the add query method, an equality operator is assumed. Now let's explore the second option, encoded query, within stage 1. So for complex queries, I generally prefer this option as it is much easier for the developer. So first we would head to the table in ServiceNow and actually build out the query using the graphical user interface. So in this example, you can see here that we have priority is critical or is high, and category is hardware or is software, and it's created after 2017-0101, and the short description is not empty. So we have this same filter that we saw in the previous example. Now in step 2, we would copy this query. So you simply go to the breadcrumbs and to the very last filter, in this case, short description is not empty, right click on that breadcrumb and then click copy query. This will copy the encoded query that ServiceNow uses to process this filter. Then, once that's copied to our clipboard, in the third step, we add this to the add encoded query method, which in this case is a long string that contains the encoded query ServiceNow uses to process this. So you can see in this example, there's a lot less code required. However, it does require us to in turn go back to ServiceNow, create this query, copy it, and then paste it in our code. All right, so that was an overview of stage 1 of the glide record. Now let's take a look at stage 2, the process record stage. So stage 2 starts after we execute the query method. So the query is executed in MySQL, and the MySQL database returns us the records from our filter. These records get sent to glide record. Glide record does its magic and maps out these database fields to JavaScript properties. So then our records get returned to us back into our glide record variable, where we then have access to the record's fields that are the actual properties of that current record. One of the most important methods in stage 2 is the next method, which iterates over our returned list of records. When I was first learning about glide record, this is one method that caused a bit of confusion for me, so I hope this slide will help you to avoid this confusion. The next method has a few magical functions baked into it. After we run the query method on a glide record object, we receive an iterable object returned to us in our original glide record object. So what does this mean? Well, it means that if our query we build in the first stage of the glide record actually returns one or more records, then a list of those records are within the incident GR object, which we can iterate over. For more information on iterators, check out the below wiki link or even this YouTube video that helps explain what an iterator is. In order to access the first record, we first need to iterate to it. So by calling next on the incident GR variable, we iterate to the first item in the array or list. So in our example, let's say we have a total of 4 incidents that have a priority of 1 in our incident table. These 4 incidents are represented below the block of code and are contained within the incident GR object. The JavaScript while loop will continue until it receives a false value, which is returned by the next method if no more objects are within the array. So in this example, the code within the while loop will run 4 times. On the first run, we get our first incident, which happens to be INC 000123. One of the most powerful parts to the glide record API is that we have access to all fields on the table we're querying, in this case the incident table. So if we wanted to print the sysID instead of the number to the screen, we could simply change the incident.number text on line 5 to incidentgr.sysID. While we're still within the while loop, we have access to the current object, in this case incident INC 00123. So line 5 will be executed and print the number to the screen, and then continue with the while loop, where we are then taken to the second object in the array, and so on until we get to incident 4, the last item in the array-like object. Hopefully we are starting to see the power of the glide record API, as opposed to writing all of these operations within SQL. So as we saw on the last slide, we were able to access any incident field of the iterated object by simply adding a dot and then the name of the field. Once the query method is called and the object is iterated to, a record's fields become properties on the current glide record object. Keep in mind, we use the field's name in the script as opposed to the field's label. So if we wanted to access an incident's contact type, we'd write contact underscore type instead of capital C contact space type, which is the label as opposed to the name. Now we'll take a quick look at the get method. So you might be asking yourself, if I need to get a specific record in a script, do I really need to write 5+ lines of code just to get it? Well, the answer is no, thanks to the get method. Oftentimes, when writing scripts, we'll have the sysID of a specific record, whether it's a reference field or obtained from another glide record query. As long as a given field on a table is truly unique, then we can use the get method to retrieve that record in 2 lines of code. However, it is important to note that this is very different than using the query method with glide record, which returns an iterable object. Get only returns one record, even if the filter provided matches more than one record. So only use the get method with truly unique values like sysid or the system-generated values like the out-of-the-box number field. Let's take a look at an example. Here we have 3 lines of code as well as the class diagram on the left. You can see we're still providing the name of the table on line 1 to the glide record constructor. So nothing has changed here. But on line 2, instead of adding an add query method or just calling the query method, we simply use the get method, which either takes the sysid as an argument, or if we have another unique field, we can pass in the field name and the field value as an argument. Pretty cool. So in this case, because I know the number field is truly unique, I can pass in the number field as the first argument, and then the specific incident number to the record I'd like to receive. In this case, INC 000001. Hello, and welcome back. In this video, I'd like to revisit CRUD and map out the glide record methods to the CRUD acronym. So as discussed before, CRUD stands for create, read, update, and delete. And these map quite nicely to glide record methods. So create maps to the insert method, read maps to the query method, which has an asterisk by it, because technically the query method can be used on really all of the CRUD operations, not just read. But it turns out that if we wanted to read a record, we would also need to run the query method as well. So moving along to update, we have the update method, easy enough, update to update. And then finally, delete, we have the delete record method. So let's take a deeper look at these 4 methods. Here on the right, I have some code to create a new incident with the short description as test123. There's a few things that need to happen before we can actually create or insert a new record. So 1, we need to first build the glide record, which means passing in the table we want to create the record on. 2, we need to actually perform that query method that will actually initialize the glide record object, so to speak. Then we call the new record method. This will actually set all of the default values associated with a new record, in this case a new incident, as well as automatically generate the sysid for the record as well. And the 4th step is where we actually set the values that we would like on this new record. So again, in this example, I'm just simply setting the short description. However, you could set all of the fields or just a selection of the fields that you would like to have for this new record. And then finally, in the 5th step, we actually make the insertion. So we call the insert method. It's important to note that the record isn't actually saved to the database yet until we call this method. So even though we call the new record method, that object is still in memory and has not been saved to the database yet. Alright, moving on to read. So on the right, I have some code that queries the incident table and shows all priority 1 incidents. Within the while loop, we're just simply printing the incident gr.number to the screen. So again, for this to happen, we need to follow a few steps. First, we'll build the glide record. 2 is optional, where we apply any filter conditions to the glide record. In this example, priority is 1. 3rd, we need to run the actual query method. 4, we need to iterate to the objects or rows with the next method. And finally, in the 5th step is where we actually print or copy the variables or whatever it is that we need to do in order to achieve our read operation. Next is update. Here we have some code that updates all of the priority 1 incidents and sets their priority to 2. So in the first step, again, we'll build the glide record. In the second step, we add any filter conditions, which is optional. In the third step, we'll query the database. In the fourth step, we'll iterate through our records. The fifth step is where we actually set the field values. So on line 7, I'm setting incident.gr.priority equal to 2. And then finally, the sixth step is where we call the update method, which will actually update the record in the database. Similar to the insert method, the update method, the field values are not saved to the database until the update method is called. So if we never had incident.gr.update on line 8, the priorities would not be saved to 2. They would remain at 1. Finally, we have delete. On the right, I have some code which is going to find the incident inc 0000001 and delete that record. So in the first step, we're building the glide record. In the second step, we're adding the filter, which is optional. Third step, we're querying. The fourth step, we're iterating to that record with next. And in the fifth step is where we call the actual delete record method. Hello, and welcome back. In this video, we'll finally get our hands dirty with some actual code where we'll run it in background scripts within ServiceNow. Keep in mind, I'll be using the Atom text editor by GitHub while scripting in all of these videos. I will then copy the code from Atom and then paste it into ServiceNow. I prefer this method just because I think using a text editor like Atom will be easier to read for you, the student, and overall just be easier to present to you guys. Alright, so let's get started. First, we'll go ahead and type in background scripts in the application navigator. And since we'll be using this so much, we're going to go ahead and star this, so this will be added to our favorites. So we'll click this, and this will bring us to the background scripts within ServiceNow. As you can see, this is nothing fancy. This is simply just one large input field where we can click the Run Script button below, which will execute the script we write against the backend or in the backend of ServiceNow. So this would be all server-side stuff. And then we can also select the scope as well. We won't really be discussing scope in this course, but you do have that option here. So again, this is also why I chose to use a text editor as well, because specifically in background scripts, there's no formatting or line numbers or anything that would help you guys out. All right, so first, although we're still in the glide record section, we need to cover something called gs.print. And GS stands for glide system, which we'll be discussing in the next section. But for now, just know that gs.print is a simple method that prints whatever we put within the argument to the screen. So we'll go ahead and test this out by first doing a gs.print hello world. Because this is a very simple example, I decided to just type this up right within the background script itself. So here you can see we have hello world as a string value, and we'll go ahead and click run script. And that does exactly what we expect. It prints hello world to the screen. Alright, so we'll delete that. And now let's talk about glide record. So we'll jump into Atom. And if you are following along, make sure you have JavaScript selected as the language in the bottom right-hand corner. This will help with syntax and error checking. Although Atom is not an IDE, so it won't check strict syntax rules for JavaScript, it will help in some ways. So I definitely recommend having JavaScript selected here as the language. All right, so to start, we'll create a new variable, incident.gr, and we'll be querying the incident table. We've seen all of this before. And we're actually not going to apply any filters here. We will just be querying the entire table here. And while incident.gr.next, we're just going to go ahead and print out the incident number. Now, it's also important to point out that this is in my personal developer instance. So I don't have many incidents in the incident table. But for example, if you were in a production environment or even a test environment that maybe has hundreds of thousands or even millions of incidents, just keep this in mind that this could be a performance impact. So we'll go ahead and copy all of this code and then paste it in the background script and click Run Script. And now you can see that this printed all of the incident numbers and the incident table to the screen here. Alright, so let's go back and play around here. So let's try removing line 3. And we'll see what happens. So you can see we removed the while loop as well as the incident.gr.next method. So we'll click Run, and you can see we're not getting anything here. So this kind of shows just how important that .next method is. Now it's important to note we don't need the while loop. The while loop is simply to iterate over all of the incidents in the array-like object. But if we were to simply just put in incident.gr.next, you can see that without a loop mechanism, it will simply go to the first incident in the array and print that. It's only when we add the while loop where it goes through the entire array. Alright, so now let's go over add query. We'll add in priority and we'll give it a value of 1. So now this will query the incident table and find all priority 1 incidents. And we'll go ahead and put priority 1 incident and then append the incident.gr.number. And then do a semicolon, and then finally print the actual priority. So we'll copy this, paste it in the background script, and click Run. Of course, our query is correct, and we see all of the 1s representing priority 1. So here it's important to point out that when we do incident.gr.priority, we are simply getting the value stored within that field. Now it's important to note that since priority is a choice field in ServiceNow, there is a system name and a display name. So if we wanted to print the display name, we can use a powerful getDisplayValue method, which will automatically grab the display value for any field that we add this method onto. So here you can see that instead of just getting the number 1, we can see that we get the actual display value, which is 1 critical. Alright, so now let's go to the incident table within ServiceNow. We'll go ahead and create a favorite, since we'll be coming back to this quite a bit in these examples. And we'll navigate into an incident. Now we'll click the hamburger icon and copy the sysid of this record. We'll then navigate back to the background scripts and we'll show off the get method. All right, so we'll start a brand new glide record. And now we'll use the get method, where we'll pass in one argument, which is the sysid of the incident we were just viewing. And then on line 3, we will simply print the incident's number. We'll go ahead and copy this and paste it in the background script, and you can see that we have the incident number here. Again, the get method can accept either the sysid as one argument, or it can accept two arguments, the first being the name of the field, and the second being that field value. And again, keep in mind that these must be unique. Now we'll go back to the code, and we'll print the number this time as well as the sysid. Yep, so we can see that this sysid is the exact same as the one we've pasted on line 2. Alright, so now we'll show a very powerful method, the add encoded query. And to start with this one, we'll actually navigate to the incident table, and we're going to build a query in the GUI interface. So we'll actually click the filter icon on the incident table. And here we'll provide a category of inquiry help. Active is true. And opened by is Mark Miller. So these would translate to adding 3 separate add query methods to our glide record. However, because we're doing the add encoded query, we can actually do all of this in one method. So we'll go ahead and click run, and this will show us all incidents that are active equals true, category is inquiry help, and opened by is Mark Miller. But if we go back to the very top, we can see that we have the query or the breadcrumbs here at the top. Well, we can actually right-click the very last one and click Copy Query. And this is actually going to copy the encoded query ServiceNow uses to generate the actual SQL that is then sent to the MySQL database. So if we go into our text editor, we'll create a new glide record. And this time we will add encoded query as the first method. And add encoded query accepts one argument, which is a string of that encoded query. So what we'll go ahead and do is assign that encoded query to a query string variable, and then simply pass that variable in as the parameter. So if you look closely enough at this encoded query, you can actually see what it's doing. We can see category equals inquiry, which is the name of that actual choice value. Active equals true. And opened by equals me, or the sysid of my user record. So now we'll go ahead and apply the query method and loop through all of the incidents, where it will then print the incident number to the screen. So we'll copy this, paste it in our background script, and click Run Script. And here we get a list of all of the incidents that match that encoded query. So you can see here just how powerful the add encoded query method is. With simply one line of code, we can add extremely complex queries that might have many, many conditions applied to them. All right, so now let's create a new incident using glide record. All right, so now we'll go ahead and create a new glide record. We'll give it a table of incidents since we want to create a new incident record. And we'll do new incident.new record. Now, if you remember from the previous videos, new record will actually initialize the record for us and set any default values and generate the sysid. So we'll go ahead and provide a short description. And you can see that we're simply taking the glide record object, which is new incident, and we're just doing a dot and then the name of the field we would like to set, in this case, the short description field, followed by an equal sign and a string value of the short description. Finally, we'll use the insert method, which will actually insert this record into the database. So without this insert, the short description would never get saved. All right, so we ran the script, and now we'll go to the incident table. And just to verify, we'll pull up the incident. And you can see here that this is the incident with the short description we just added in the code. All right, now let's try something just a little different. One of the cool things about the insert method is that it actually returns the sysid if we assign it to a variable. So in this example, on line 4, we'll create a new variable called new incident sysid, and we're actually going to assign the return value from new incident.insert to the new incident sysid variable. And to test this, we'll go ahead and print the new incident sysid to the screen. So we'll copy the code, paste it in the background script, and run it. And you can see here we have our sysid. So we'll copy this. We will go to the incident table, bring up the most recent incident, paste this in the short description field, and then we'll actually copy the sysid of this current incident and paste this in as well, and they should be the exact same sysid, and they are. All right, cool. So now let's do something a little different. Let's say we'd like to create 5 new incidents. So for this, we're going to do a few things here. To start with, we're going to create a new variable on line 1, new incidents, which will be an array. And then on line 2, we'll keep track of a counter. We'll go ahead and assign this to 1. And then on line 3, we'll create our glide record. So we'll provide a table of incident. And then on 4, we'll do a while loop. So we'll say while the counter is less than or equal to 5, so this should run 5 times, we are going to create a new incident. So on line 5, we'll do incident gr.new record, which will initialize the record. And then on line 6, we'll set the short description of the new record to incident number plus the counter value. On line 7, we'll increment the counter. And then finally on line 8, we will push the sysid of the newly created record to the new incidents array. And then on line 10, we will simply print the array to the screen. So we'll go ahead and copy this and paste it in the background script. And then click Run Script. And you can see here that we have a comma-separated array of the sysids. So we have our 5 sysids here of the 5 incidents that were just created. So if we go to the incidents table, we can see that we have 5 incidents here with the counter appended at the end. All right, so now let's go over deleting a record. Now, if you're ever deleting records in a background script, I highly recommend first printing those records to the screen to verify that your filter is correct and that you'll be deleting the records that you want to delete. So first we'll create a new glide record. And let's say we want to delete all of the incidents that have a short description of incident number 3. So again, to start, we'll simply just log this to the screen, and then we'll come back and actually perform the delete record. So for now, on line 5, we'll do gs.print, and we'll do incident.gr.number. And we'll also add the short description here as well, just to verify. So we'll copy this, we will paste it in a background script, and we'll run it. So here we can see 20170 is that specific incident. So now we'll jump back into our code, and since we verified that our query is correct, we'll go ahead and delete the record now. So we'll do incident.gr.delete record, and that's it. So we'll copy this code, we'll paste it in the background script and run it. And now we'll go to the incidents table and verify that there are no incidents in the incident table with a short description of incident number 3. Hello and welcome back. In this video, we'll be continuing our demo. So let's start with the order by method. The order by method accepts one argument, which is the field that we would like to order the list by. So we'll go ahead and create a new glide record object. And we'll order by the short description. And on line 3, we'll go ahead and add the query method. And then we'll simply print the number of the incident, followed by the incident's short description. So we'll copy the script, paste it in the background script, run the script, and here we can see that all of our incidents are in alphabetical order. So by default, the order by method is ascending. So if we want it in descending order, there's actually an order by descending method. So we'll go ahead and apply that now. Copy it, paste it, and run it. And now we can see that it is in descending order. Alright, so now let's go over the setLimit method. The setLimit method accepts an argument, which is a integer, and this will set a limit for the query. So if we only want, let's say, 10 records to show, we would pass in the value of 10, and only the first 10 records would be returned to the glide record. So to test this, we'll actually create a new glide record, and this time we'll provide a table of problem. So we'll be querying the problem table. We'll do problem gr and set limit of 5. So we'll want the first 5 problem records on the problem table. We'll go ahead and query. And then simply print the problem number to the screen. We'll copy and paste, run the script, and you can see here that only 5 problem records are showing due to our setLimit method. We can also combine this with the order by method. So we'll order by short description and retrieve the first 5 records in alphabetical order. We'll actually go back and change the number to the short description so this can be a little more clear to us. We'll copy paste, run it, and now we can see that the short description is in alphabetical order, showing the first 5 problem records. Alright, so now let's quickly run through the can create, can read, can write, and can delete methods. These methods will check the ACLs and verify that the current user can perform these functions. So we'll create a new glide record on the problem table. We'll go ahead and query it. And then after, we'll just do a simple if statement. And we'll do if they can create and if they can read and write. And delete. We'll go ahead and print to the screen. I have access to create, read, write, and delete. Now, obviously, if a specific user did not have access to do any one of these functions, then line 4 would not get printed to the screen since we're using AND logic. Alright, now we'll go over the getRowCount method. So we'll go ahead and create a new glide record on the incident table. And we'll just do a simple print of the getRowCount method. We'll copy and paste this into the background script, run it, and you can see that we have a total of 154 incidents on the incident table. Now let's go over the hasNext method. So although the hasNext method sounds similar to the next method, it's actually quite different. The hasNext method returns a Boolean value, either true or false, if there is another record in the array-like object. It's important to note that this does not perform the actual iteration like the next method does. Let's take a deeper look. So we'll create a new glide record on the incident table, query it, and then on line 3 we'll print incident_gr.hasNext. Because we know that there are incidents in the incident table, we can expect to see true printed to the screen. Let's copy and paste this code and run it, and we can see that true is printed. Now we'll actually change the hasNext to next. Copy and paste this in the background script and then run it. So here we can see that we're getting true as well. So it turns out the next method does return a Boolean in addition to iterating to the next object. Alright, so now let's take a look at another example. Oftentimes we'll find the hasNext method in an if condition. Sometimes we want to do a glide record where we only expect one record to be found based on the filter we apply. So if we perform an if condition, such as incident_gr.hasNext, then we know for a fact that we found our matching record. So before we go any further, try to guess what will happen here. Alright, so let's actually copy this code and paste it in the background script and run it, and we can see that we're not getting anything printed to the screen. Strange. So if we go back to the code, we can see that we're using the hasNext method on line 3, which does not perform the actual iteration to the first object in the array. It's just simply returning a Boolean value, true or false, if there is a next value. So even though there is a next value, on line 4 when we try to print incident.gr.number, there's nothing at the pointer, or the actual incident hasn't been iterated to, so there's nothing for us to print. If we were to change this hasNext to simply the next method, then you see we successfully get the number of the first incident in the incident table. Hopefully, now you understand the difference between the hasNext and next methods. Next is what actually performs the iteration to the object in the array. And now to test the hasNext method, we will add a query of priority, and we'll pass in a value we know doesn't exist. So we know that there is not a 0 priority on the incident table, so we'll go ahead and apply this. And when we print hasNext to the screen, and when we print the hasNext method, we should expect to see false. And we do see false here. Now let's revisit the get method. So before, the first time we used get, we passed in the sysid. But as I said before, that as long as we provide a truly unique value passed in the get method, then we can use any field we'd like as well. So in this example, we'll use the number field and we'll pass in a specific incident number, incident 20168. So here you can see that we did retrieve the incident using the number field with get. Now we'll take a look at the getLink method. So the getLink method will retrieve a link to the current glide record. So in this case, we can expect to see the link printed to the screen for incident 20168. And you can see that we have the incident.do $sysid equals the sysid to that incident, followed by some additional parameters. So if I copy this and add this to the URL, you can see that we're taken to this incident record. Now let's test the delete multiple method. For this, we'll actually use the add encoded query method as well. So let's go to the incident table and let's say we'd like to delete all incidents that contain a string of incident space pound. So we'll do short description contains incident pound. And you can see that we have 4 here since we've already deleted the incident number 3 incident using the delete record method earlier. So we'll actually come up here and copy the query and then head to our text editor. So actually before we delete any records, let's first practice logging these to the screen. So we'll simply add a while loop and we will add the short description of the incident to the screen. Copy the code, paste it in the background script, and you can see that we have the 4 incidents here, incident 1, 2, 4, and 5. So now that we've successfully logged them to the screen, let's go ahead and delete these using the delete multiple method. So one nice thing about the delete multiple is that we don't have to add the query method or the while loop. The delete multiple method actually takes care of all of that for us. So we'll copy this code, paste it in, run the script, and we get nothing back. So it looks to be successful. And to test this, we will actually use the code we just ran to log the incidents to the screen earlier. Copy this, paste it in, and you can see that we're getting no incidents back. Again, to verify this, we'll head to the incidents table and verify that there are no incidents with a short description containing incident space pound. Alright, so we've covered inserting new records and deleting records. Now let's cover updating records. Alright, so before we actually write the code to update a record, let's go to the incident table, select an incident, and we will copy that number. And let's say we want to update the urgency of this record. So you can see this incident currently has an urgency of 3. Let's actually change that to a 2 within our code. So we'll go to our text editor, create a new glide record. Use the get method and pass in the incident number. And then on line 3, we'll do incident_gr.urgency equals 2. Now, this hasn't actually been applied yet. So on line 4, we need to actually call the update method. So we'll do incident_gr.update, and this will actually save the changes to the database. So we'll copy and paste that code, run it, and then head back into that incident, and we can see that the urgency is now 2. Now let's run through one more update example. Let's say we would like to update all of the incidents that have an urgency of 2 and update them to have an urgency of 3. So before we do this, let's just simply print all of the urgency 2 incident records to the screen. And you can see we have those here. And now on line 6, we'll add incident_gr.urgency equals 3. And on 7, we'll call the update method. Copy and paste the code. And now we can see that we have no incidents that have an urgency of 2. Alright, now let's cover the add null query method. So the add null query method accepts one argument, which is the field that we would like to apply a null query to. So we'll jump into the code and we'll create a new glide record. And then on line 2, we'll say incident_gr.addNullQuery and pass in short description. So what this will do is find all incidents that do not have a short description. In addition to the add null query, there is an add not null query, which is the opposite. It will it will return all incidents that have some sort of short description. Hello, and welcome back. In this section, we'll discuss the Glide Record Secure, as well as the Glide Aggregate APIs, and how exactly these relate to the Glide Record API. So, Glide Record Secure is a class which is inherited from Glide Record. This means it has all of the same methods. In addition to doing all of the things Glide Record does, it also automatically checks ACLs for us, so we don't have to use methods like can read, can write, can update, or can delete within a standard Glide Record script. Glide Record Secure automatically handles this for us. If a specific user does not have the privileges for a given CRUD operation, then the code within the Glide Record Secure won't be executed. Glide Record Secure is commonly used in script includes. Because script includes can be called or invoked from just about anywhere in ServiceNow, like the service portal, it is important to keep security and who the current user will be in mind at all times. For example, Glide Record Secure isn't as important in, say, a business rule that already has security defined within the business rule condition filter, or for a table that already has all ACLs defined. In episode 15 of Tech Now, ServiceNow's podcast, Andrew Kincaid does an amazing job at showing the differences between Glide Record and Glide Record Secure. If you'd like to know more about the differences and when to use each, check out the video podcast on YouTube. Alright, so in this slide we can see that if we use Glide Record Secure, we don't have to write nearly as many lines of code as opposed to Glide Record. Glide Record Secure automatically factors in these conditions for us. So if a write process is being done and the user doesn't have the access to write, that code won't execute. Now we'll take a look at another API that is related to Glide Record, Glide Aggregate. Glide Aggregate extends the Glide Record class and is used for performing aggregate queries such as count, min, max, sum, and average. This is commonly used within reports and any scripts or lists that perform calculations, like the average time an incident stays open. It's important to note that the Glide Aggregate API only works on number fields. It doesn't make sense to find the average for the short description field. Also, it's much more efficient to run Glide Aggregate instead of Glide Record's getRowCount method. This is because the Glide Record's getRowCount method actually loops through the entire return list of items, incrementing a counter variable each time. This naturally takes time to process and go through the list. If this list is hundreds of thousands of records in length, this can cause a significant performance impact. Instead, use Glide Aggregate's count aggregate to retrieve the total number of records for a given filter. This is different since it leverages an SQL aggregate statement and does not need to loop through each record on a Glide Record list. For more information about Glide Aggregate, check out the API docs. Hello, and welcome to the last video in Section 4. In this video, we'll go over where we can use Glide Record, Glide Record Secure, and the Glide Aggregate APIs. Then we'll do a section recap. And finally, we'll end this video by going over the ServiceNow Docs API website. Alright, so you might be asking yourself, where can I use Glide Record, Glide Record Secure, and Glide Aggregate within ServiceNow? Well, because these APIs deal with the database, We can only access these APIs on the server side. It's important to note that there are ways to use glide record in a client script on the client side, but this is not recommended and is now deprecated, so we won't be covering it in this course. Instead, we'll go over an alternative and the recommended approach to retrieving information about a specific record on the client side in Section 7, Glide Ajax. Alright, now let's review what we've learned in this section by going over a section recap. So we learned that we use glide record when dealing with database operations, and that CRUD stands for create, read, update, and delete. We also learned that glide record, as well as glide record secure and glide aggregate, are server-side APIs. We went over the 2 stages to the glide record API. The first stage is the query building stage, and the second stage is the process record stage. This is where we actually process the records that we've queried from the database. Then we covered one of the more complex methods, a part of the glide record API, the next method, and we learned that it actually iterates over the returned records from the database. We also covered the get method, and that we use this method to retrieve a specific record when using a unique field, such as the sysid. We also discussed that it's best practice to use glide aggregate over glide record when dealing with aggregates like counts. The glide aggregate API is just more efficient at performing these aggregate calculations than glide record is. We also discussed that it's best practice to log records before deleting them with something like a background script. Although I mentioned you can use glide record in client scripts, it's actually best practice to avoid this and instead use something called the Glide Ajax API, which we'll discuss in Section 7. Finally, we discussed when it's appropriate to use glide record secure, such as in script includes when we need that additional layer of security. Alright, now let's jump into a quick demo where I'll show you how to use the ServiceNow Docs API website. So here we have the current homepage, and we have a number of options in the header here. If you do not already have a personal developer instance, I highly recommend signing up under the Program tab. Under the Learn section, there's some training documentation as well as some step-by-step guides I recommend checking out as well. But for now, let's hover over the API section and click on Server. Here we'll be taken to all of the server-side APIs within ServiceNow. We'll scroll down and locate glide record. So to start with, the API documentation provides a brief overview of the specific API we're looking at, in this case glide record. And then it lists all of the methods associated with this API. It also has examples to most of the methods shown on the right-hand side as well, which can be very helpful when learning new methods. So if we click on Delete Record, we'll be taken to this method where we can see that it says what it does, deletes the current record, and on the right it shows an example of doing so. The documentation also shows any parameters for a given method, as well as the return type. In this case, we can see that the get method accepts 2 parameters, one being the name and the second being the value, and it returns a Boolean data type. While we don't cover every single method in this course, I do recommend going through this API documentation sometime and just simply reading what the method does so you get a better overall understanding of what's actually out there and what's available to you as the developer. It's also important to note that on the documentation page, in the bottom right-hand corner, there's the version of ServiceNow. In this case, we can see that we're on Istanbul, but if you're working on an older version, you can select that and the API documentation will change according to what version of ServiceNow you're on. Even with my years of experience on the ServiceNow platform, I still come to this API documentation quite a bit. Hello, and welcome to Section 5, where we'll be covering the Glide System API. We'll start this section with an introduction to Glide System, followed by the Show Me the Code slide. Then we'll go over the Glide System API diagram. Next, we'll cover a list of common Glide System methods, followed by dissecting some of the most important methods out. Then we'll cover the concept of events in ServiceNow, and do an event demo as well. Then we'll jump into ServiceNow, where we'll actually write some code using the Glide System API. Finally, we'll end this section by discussing where we can use the Glide System API and cover the API documentation. The ServiceNow docs state, the Glide System API provides a number of convenient methods to get information about the system, the current logged-in user, etc. The Glide System API is server-side, so you cannot access Glide System on the client side. As a developer, generally you'll use Glide System to access information about the system or user data. You reference the Glide System API by GS. The Glide System API does not need to be invoked like the Glide Record API did. It's just automatically available to you at any time within a server-side script. There's also a number of helper methods available to us within the Glide System API. Alright, so let's check out some code. In the first example, we want to print a list of all incidents where the caller is the current user. So how can we dynamically get the current user? Well, it turns out there's a Glide System method that will return that information to us. So all we have to do is use this in the add query glide record method. We simply add gs.getUserID and ServiceNow handles the rest. This method actually returns the sysID of the current user. Easy enough. In the second snippet, we'd like to create a user greetings message for the service portal. We want the message to say, "Good morning, Mark," "Good afternoon, Mark," or "Good evening, Mark," depending on the time of day. Instead of using Mark, we also want to dynamically use the name of the current user. Well, it turns out there's a Glide System method that will return the user's display name that is stored in their user record. So here on line 11, we simply add gs.getUserDisplayName, which will return the current user's display name to us. Now let's take a look at the Glide System API diagram. As stated before, Glide System is actually referenced using GS within our scripts. Its properties have to do with user data, session data, as well as some date data. Some common methods include getMessage, eventQueue, beginning of last month, getUser, hasRole, etc. In the following videos, we'll take a deeper look at these methods. Hello, and welcome back. In this video, we'll take a deeper look into some common Glide System methods. Alright, so we'll actually be going over the first 5 of these methods here within the next few slides. So for the time being, let's go ahead and skip down to the sixth one, get session. The get session method will return the user ID that ServiceNow uses to keep track of sessions inside of the system. This can be important when dealing with security or things like the service portal. The next method is print, which we should be familiar with this by now. It simply prints something to the screen, kind of like a console.log within a browser. The next 5 methods are used for system logs. These can be helpful when debugging scripts. We'll go into these in more detail in the 9th section of this course, where we'll actually be covering debugging in depth. But for now, just know that they will log messages to certain places within the system logs. Next is the generate GUID method, which will generate a globally unique ID for us, which is commonly referred to as the sysid within ServiceNow. This can be helpful when we need to generate a sysid or some other type of unique identifier, possibly in a custom application. Again, the system ID or GUID is a 32-character hexadecimal string. The next method, getUser, will return the current user object to us. We can even chain additional functions onto this, as we'll see in the demo video. The hasRole method will take a string argument, the name of the role, and test whether or not the current user has this role. This is used all throughout the system and is quite powerful when factoring in security in your application. We then have the isLoggedIn and isMobile methods, which can be helpful in service portal scripts. Next is the nil method, which is very helpful when testing whether or not a value is null. We'll take a look at this method in more depth here in just a few slides. The setRedirect method will redirect the user to the provided URL string. This is commonly used within record producers after a user inserts the new record. A lot of the times we would like to redirect them to that newly inserted record. In addition to getProperty, we also have the ability to set a property with setProperty. Alright, now let's look at some common message and log types. So let's start by addErrorMessage and addInfoMessage. Here we see 2 messages, the addErrorMessage, which is shown in red, and the addInfoMessage, which is shown in blue, which are actually shown to the user on the client side. Now let's take a look at 3 different log methods, gs.log, gs.warn, and gs.error. Here on the left, we can see the application navigator and that these 3 methods actually map to modules here. Also on the right, we can see a log entry on the log table. So anytime you use gs.log in a script, you can find these log messages by navigating to the script log statements module under system log. If you use gs.warn, you can find these under the warnings module. And finally, if you use gs.error, you can find these in the errors module. The log, warn, and error methods can be helpful when you would like to diversify the type of messages you receive from scripts. So if there's a serious problem in a script that would not allow it to continue running, you would use something like an error. Whereas if you were just simply printing something to the log table, you could just use a log method. Alright, now let's discuss Glide System's getMessage method. Because ServiceNow supports a number of languages, we need a way to grab translations for specific messages. Well, the getMessage method does just this. Let's say we have the word welcome on the service portal, but we'd like it to say hola if the current user has Spanish selected as their default language. Well, using the sys_UI_message table, we can do this very easily. getMessage accepts one argument, the ID of the message, typically just the full message as a string. Then behind the scenes, it uses the current user's language and queries the sysUI message table where it finds that specific translation. By default, if no mapping or language is found, it will use the system default language, which is typically English. So in the diagram below, we can see that my current language is set as English, and on line 2, when I use gs.getMessage and I pass in the variable message as an argument, it would query the sysUI message table and find a key of welcome with a language of English and send me the message value. It's very common to use this when dealing with translations in customer-facing portals like service portals. Alright, now let's move on to the glide system getProperty method. Oftentimes when we are scripting, we need to reference some type of value found elsewhere in the system. Well, we can use system properties to store these values on the sysProperties table. The getProperty method accepts the name of the system property as a string and returns the property's value to us. It's best practice to use properties instead of hard-coding something like sysids or other values into scripts. Instead, you should create a new system property for a sysid and then reference that value in the script. It just adds an additional layer of abstraction so we don't have to edit the actual code if that value were to change. You can simply go into the sysProperties table and update that value within ServiceNow. So in this example, we would like to grab the value of the glide.ui.buttons_bottom property. So we call the getProperty method and we pass in this name as a string. Now ServiceNow will go to the sysProperties table and retrieve this value for us, in this case, a Boolean of true. Alright, and we'll end this video by taking a look at Glide System's nil method. Oftentimes we would like to find whether a variable has a value assigned to it or not, and then perform logic on that. But because returned variables like glide record fields are actually objects in ServiceNow, we can't just simply test for a blank string or a falsy value. For example, say we have a variable field which has a value and display value property. Now let's pretend this field variable is actually a glide record field, like the number on an incident record. Well, if we wanted to test whether the field contains a value or not, we cannot simply do field equals a blank string like what we see here on line 6. This would actually return false, because field is an actual object with properties as opposed to just being a string data type. So instead of using something like this, we can leverage Glide System's nil method. So now on line 4, we use gs.nil and then we pass in the glide record field, in this case incident gr.short description. Hello and welcome back. In this video, we're going to put the Glide System API on the side right now and discuss an important concept in ServiceNow, events. In this video, we'll go over how events in ServiceNow work, go over a brief demo, and discuss how this fits with Glide System. So what is an event? Well, events can be many things. User events can be things like mouse clicks, mouse movements, or key presses. So say you're playing a game in your browser, the game needs to be able to record these events and act upon them. For example, a left mouse click would fire a weapon, and a right mouse click would reload. System events generally have little to no human interaction. These can be things like time. Simply, time passing could be an event. Once something reaches 10 p.m., perform this action. System events can also be database operations, as we'll see here in a second, such as any CRUD operation that we would have against the database. System events can also be caused by network activity. For example, say there's a third-party web service that's interacting with our application. Well, if we receive network activity from this service, then we could act upon this. Alright, now let's take a look at events in ServiceNow. I would like to point out that this topic was discussed in my ServiceNow 101 administration course. So if you have access to that course and this isn't making complete sense, I recommend checking out the video in ServiceNow 101 as a refresher. Alright, so events in ServiceNow can be triggered by CRUD operations on tables. In the world of ServiceNow, we act upon these triggers using business rules. So we can say if a new incident is inserted, then perform this logic or run this script. Events can also be triggered by workflow activities. So say we have a workflow for a catalog item. Well, if the catalog item is finally approved by the approver, this would in turn trigger the approval workflow activity and continue within the workflow process. Finally, events can be triggered by scripts. So we can have scheduled jobs or web services or so on. Events in ServiceNow must be registered, and we'll go over what that means in more depth here in just a second, but this is essentially informing ServiceNow of a specific event. So with that, there are three main components to the events in ServiceNow. The registry, where it's actually registered, an event action, such as a script action or a notification, and the event log, where once the event is executed, the system creates a log entry for that event. Alright, now let's explore these three components in more depth. So first we have the registry event component. So here we have a screenshot of an event in ServiceNow. ServiceNow.201.hello.world is the event name. Normally we apply a table, but for the purposes of this example, we'll leave the table field empty. And then it's best practice to populate the fired by and description fields on an event as well. The event registry record isn't where we're actually performing any type of logic. It's just a way to let ServiceNow be aware that this event is out there and exists. So now let's take a look at event actions. So an event has occurred, let's act upon this. So the two most popular event actions in ServiceNow are script actions and notifications. On the left, we see a screenshot of a script action. And a script action is just simply a server-side script that runs when a specific event is triggered. So we can see here that we select an event name in the dropdown. In addition to script actions, we can have notifications fired when an event is triggered. So maybe we would like an email to be sent to a group of users when a knowledge base article is about to expire. As shown on the right, we can see that we specify the actual event name within the notification record as well. And finally, we get to the third component, the event log. So this is a log of all of the events that happen in ServiceNow. The log shows the name of the event, as well as two parameters that you can pass in, which we'll take a look at here in a second, and some additional information about what happened with that event. Alright, now let's break down the process of the event queue. So because events can be so many different things, we might have a number of events that are happening. ServiceNow handles this with something called an event queue. It's essentially a queue data structure, so it's first in, first out, of events that happen within the system. So if we take a look at this, on the left we have our triggers, in the middle we have our event queue, and on the right we have our event actions. So here in the event queue, we go to the first event, the login event, where it's processed, and let's say that login event actually triggers a script action. So the system would run that script action and then log this to the event queue. Next would be the create record event in this specific queue. So once the CRUD operation occurs, let's say an email notification happens, such as a new incident has been created. That would also generate a log to the event log. And then finally we have a save record event. Maybe this was on a workflow activity, and this triggers an email notification. So again, the system would process this and then log a record to the event log as well. Alright, so let's revisit script actions. As I stated before, script actions are server-side scripts that are invoked via registered events. So any event in ServiceNow can call upon a script action. The scope of the script action includes the current object or the current glide record object, as well as an event object which contains param1 and param2 properties that we can pass in different values for. Alright, so why are we covering events in Section 5, Glide System? Well, it turns out that there is a Glide System event queue method, which we can use in scripts, and this will actually add a specific event to the event queue to be processed. The event queue method has 4 parameters. First, the event name. Second, the glide record object. And the third and fourth are optional parameters, that parm1 and parm2 that we just discussed. So on the right, let's say we have our event queue of login event, create record event, save record event, and then we have a custom event we would like to add to the event queue. Well, we can do so by calling the gs.eventQueue method and passing in the arguments. By calling this script, that would add our custom event to the event queue, where the events would then be processed. Alright, now let's put all this together and take a look at an actual demo. This is going to be a very simplistic example, but I think it'll help you conceptualize what's going on here. So for the purposes of this demo, we are simply going to log the text hello world to the system logs. So first we have to create an event registry record. So here under the registry we create a new event and we'll call it ServiceNow.201.hello.world. Again, we'll leave the table blank for this example, and then fill in fired by and description. Next, we want to create a script action. So this is where we'll actually perform the log to the system logs. So we'll create a new script action, we'll give it a name, and then we'll select that event name we just created in the event registry. And finally, in the script section, we'll just do a simple gs.log hello world, and as a second argument, we'll do marks logs as the source. Next, we'll head over to the background script, where we'll actually add the event to the event queue via the gs.eventQueue method. You can see here we're passing in the name of the event, ServiceNow.201.hello.world. So once we've ran that, we can head to the logs and we see that our hello world is logged to the system. Events in ServiceNow go beyond the scope of this course, but I wanted to give you a general understanding of events and why we would want to use the gs.eventQueue method within scripts. Hello, and welcome to Section 6, Glide Form and Glide User. We're finally halfway through the course, and this will be a great section because we'll discuss not one but two client-side APIs, Glide Form and Glide User. So this section's outline is as follows. I'll provide an introduction to Glide Form and we'll do a Show Me the Code section. We'll talk about the client-side environment and we'll discuss the Glide Form API diagram. Then we'll take a look at some common Glide Form methods and do a Glide Form demo. After that, we'll jump back into the slides where we'll do a Glide User introduction and a Show Me the Code section for Glide User. Then we'll cover the Glide User API diagram and go over the Glide User methods and end with a Glide User demo and a section recap. So, what is the Glide Form API? Well, as stated in the ServiceNow docs, the Glide Form API provides methods to customize forms. The global object, g_form, is used to access Glide Form methods. Glide Form methods are only used on the client. These methods are used to make custom changes to the form view of records. So there are three important takeaways from this. One is its client side, so we cannot use this on the server side. Two, we use Glide Form to make changes to the form and the fields on the form. And three, we reference this API by using g_form. Alright, now let's take a look at the Show Me the Code slide. So in this example, we want to set short description to mandatory when priority changes. It's important to note here that we could accomplish this by using a UI policy, but for the purposes of this demo, I wanted to use the gform.setMandatory method instead. So here in the first image, we can actually see in the client script, we have a type of onChange and the field name is priority. So whenever the priority field changes, it's going to execute the following code. So on line 5, we have our gform API, where we're accessing the setMandatory method, which takes in two arguments, the first being the field value, so short description, and the second argument being a Boolean. We want to set this to mandatory, so we'll pass in true. So with one line of code, we can see just how easy it is to, in this example, make a field mandatory. Alright, now let's talk a little bit about the client-side environment. So client-side means it's running inside of your browser. So all of the code is already shipped to your browser. In client-side scripts, we have access to client-side APIs, where most of these are actually accessible via the global JavaScript scope. Within ServiceNow, you can press Ctrl-Shift-J to open up the client-side JavaScript executor. Whatever code you type into here will be ran on the client side. This is kind of similar to background scripts where we run server-sided code, but in this case, it's client-side code. Finally, since we're on the client side, within our scripts, we can always debug to the browser using something like the browser's console.log method or a console.dir method. I would like to point out that it is best practice to avoid manipulating the DOM directly in ServiceNow within something like a client script or UI action, and it's recommended instead to use the gform API. Now let's take a quick look at the Glide Form API overview. So here we can see we have the Glide Form API, and on the left we have the form and fields properties. And on the right we have a number of methods such as getValue, setValue, addErrorMessage, addInfoMessage, and so on. Within the next few videos we'll take a deeper look at what these methods actually do. Hello, and welcome back. Now let's take a look at some of the common Glide Form methods. So we have add error message and add info message. And you might be asking yourself, well, we've already seen this in Glide system. But as it turns out, that's actually on the server side, and these are on the client side. So GlideForm gives us a way to add error and info messages on the client side as well. We also have the ability to add new options to a choice list on the form, or even clear out those options. Clear value is a common method for wanting to perform some type of logic, and if true or even if false, we would like to clear a value from a field. We also have disable attachments and enable attachments methods, which do just that. We can also get the label of a field using the getLabelOf method. If we have a choice field, we can get the option of the currently selected choice using the getOption method. We also have a getReference method, which is an interesting method that we'll take a deeper look at here in a few slides. We have a hide related lists method, which does just that. It'll hide the related lists found at the bottom of a form. We have an isMandatory method, which will check if a field is mandatory or not. We have a remove option method, which will remove options from a choice field. And then we have set disabled, set read only, and set visible methods, which will set fields to disabled, read only, or whether they show on the form or not. And finally, we have a set value method, which will set a new value to a given field. Alright, so let's go over probably two of the most common methods to GlideForm, the getValue and setValue methods. So these are essentially getter and setter methods for just about any field on a given form. GetValue accepts the field name as an argument and will return to us that value within that field. And setValue accepts the field name that we want to set a new value to, and second, the new value as an argument. So here on the left we have some code, and on the right we have a snippet from the incident form. So on line 1 we have var category equals g_form dot getValue, and we're passing in the field name category, which will return to us the value of the currently selected category selection, which is inquiry help. So that'll actually be assigned to the category variable. Then on line 3, we create a variable new category and assign that to software. And then finally on line 4, we use the setValue method, where we pass in category for the field, and then the variable new category, which is actually software. So this would update our category field on the incident form to software. Alright, now let's look at the getReference method. There's only so much data that is shipped to the client from the server. So on the client side, you can say that we're kind of limited to the data we have available to us without making another request to the server. It turns out when we're on a form view of a record, the server only sends us on the client side any field that's directly related with this record. So, for example, if the incident form has a reference to another record, maybe the location record, we don't actually have that location record's data available to us on the client side. We would need to make another request to the server if we wanted to grab a field on that related record. Well, it turns out that that's what getReference does. And it does so by using JavaScript callbacks. So say we're on the incident record, and all of the fields that relate to this specific incident have been sent to us from the server. However, we want to access fields on the incident's caller user record. So we could do this by using the getReference method. So let's take a look at an example. On the left here we have our client, and on the right we have our server. So when we go to a specific incident's form view, all of the incident fields are sent to us on the client. as well as this client-side code. So on line 1 here, we can see we're using the gform getReference method, where we're passing in the field of the referenced record, as well as a caller callback. So this caller callback is a callback function that will actually be invoked once the server returns our response to us on the client side. So when this code is executed, then the client would make a request to the server where it would ask for the caller's user record. The server would then package that up in a response where it would send it back to the client. And once the client received that, the client would invoke the caller callback function. And then line 3 would run where we set the description of the incident to a value of the caller's first name plus a space plus the caller's last name plus the text says hello. Hello and welcome back. In this video, we'll jump into ServiceNow and show off the GlideForm API. So one of the cool things about client-side APIs, or more specifically JavaScript that's sent to the browser, is that we can actually inspect this and get a first-hand look at the API itself. So we can actually log the API to the browser's console, in this case Firefox's web console. So we can type console.dir and then pass in the argument of the name of the API, which is g_form. So when we do this, we can see a nice list of all of the properties associated with this API. That's one of the benefits of using the dir method over the log method. So I'm sure you're familiar with something like console.log for client-side scripts. Well, if you use the .dir, it formats it in an easier way to read. So now we have the entire gform API exposed to us. We can see that there are a number of properties associated with this. For example, if we go to the elements property, we can see that this is an array with 29 items. And if we go into one of these items, which is actually an object, we can see that these are the actual fields on the form. And each field has properties themselves. So this kind of exposes to us how ServiceNow is working behind the scenes on the client side. To get a deeper understanding, I recommend trying this on your own and just kind of going through all of the properties associated with these and play around with them. Alright, now let's take a look at the JavaScript executor. So on a Mac, if you hold down Control-Shift-J, the JavaScript executor will appear within ServiceNow. This is where we can run client-side code and leverage ServiceNow's client-side APIs. So let's start things off by using the getValue method on the gform API. So let's bring up our text editor and create a new variable, field value, and we'll actually call the getValue on the category field. So what this will do is actually pull the current value of category on the form and assign that to our variable field value. And then on line 2, we'll just do a simple alert, and we'll put in the field value variable. So if we copy and paste this in the JavaScript executor, we can see that we get a client-side pop-up of hardware, because that is the current selection of the category field. So now let's take a look at setValue. So for this example, let's say we want to set the category field to software. So we'll use the gform.setValue method. The first argument is the name of the field, and then the second argument is the value that we would like to set that field to. So we'll copy and paste that code, run it, and we can see that the category changed to software. Now let's take a look at the clear value method. So let's say we just want to clear the category field. So we'll just do gform.clearValue and we'll pass in the field name of category. We'll copy and paste that in, and we can see that the category is then set to none. Now let's take a look at the save method. So the save method just simply saves the current record. So we'll just do gform.save, and we'll copy and paste that, and click Run My Code, and we can see that the screen actually refreshes since this record has in fact been saved. Now let's look at the setDisabled method. So this method takes two arguments, the first being the name of the field we would like to set to disabled, and the second argument is Boolean, true or false, whether we would like to set it to disabled, which would be true, or not disabled, which would be false. So because we want to set this field to disabled, we'll go ahead and pass in true. We'll copy that code and run it, and you can see that the category is now set to disabled. We'll go ahead and re-enable it. So we'll pass in false, copy that, paste it, and we can see it has been re-enabled. Now let's quickly take a look at the hide related lists method. So what this will do is simply hide the related lists found at the bottom of a form view. So if we run this, we can see that there are no longer related lists at the bottom of this form. Now let's take a look at the isMandatory method. So this method will return true or false depending on if the current field is set to mandatory. So we'll pass in category here, and we can see that it is not mandatory. Alright, so let's insert a new line above this and set it to mandatory. So we'll use the setMandatory method and pass in category and the second argument of true, since we want to set this to mandatory. And now we can expect to see true in the alert box since it has been set to mandatory. So we'll go ahead and copy and paste that code, and we can see here that it is true, and more importantly, on the form we have the red asterisk representing that this field is in fact mandatory. Now let's take a look at the isNewRecord method. So this returns a Boolean value, whether if the current record on the form is a new record or not. So for this, we'll just do an alert with some text, is this a new record? And then pass in the value assigned to isNewRecord. So if we copy and paste that code, we can see that that is in fact false. Now let's take a look at the gform add info message and add error message. This is similar to the glide system add error message and add info message methods, but this is actually happening on the client side with gform. So we'll log some info text and some error text. And then we can clear those messages with the clear messages method. Alright, now let's take a look at the getLabelOf method. So this method takes the name of the field and returns us the field label. So for this example, we'll go ahead and pass in the field name of category. And we should get category with a capital C back, since that is the label of the field. Let's try a different field name, such as caller ID. In this case, the field name is caller ID. However, the field label, what the actual user sees, is just caller. So we'll pass in caller ID, and we should just get back caller here. Alright, and we'll end this video by taking a look at the getTableName method. So for this, we'll go ahead and create a new variable, table name, and we'll assign it the value given to us from getTableName. And we'll just do a simple alert. And we can see here that if we copy and paste it, we get incident as the table name. So we're able to retrieve the name of the table we're currently on from the client side. Hello and welcome back. In this video, we'll take a look at the Glide User API. So the ServiceNow docs state, the Glide User API provides access to information about the current user and current user roles. Using the Glide User API avoids the need to use the slower Glide record queries to get user information. So as the developer, we'd use the Glide User API on the client side to retrieve user information. We can reference Glide User by G_user, and it's a relatively small and simple API. We'll see here in just a moment that there's really only a handful of methods and properties on this API. Alright, now let's take a look at the Show Me the Code slide. So in this example, we would like to check if the current user has the ITIL role. So on line 1, we can see that we create a new variable, has ITIL, and we assign it the value returned to us from the hasRole method. In this case, it accepts a string argument, which is simply the name of the role, in this case ITIL, and it will return a Boolean value, either true or false, if the current user has the given role. So on line 2, we're saying if has ITIL is false, we want to alert the message, you do not have sufficient privileges. Alright, now let's take a look at the Glide User API overview. So again, we can access the Glide User API by using G_user anywhere on the client side. And some of the properties that this API contains are first name, last name, user ID, and username for the current user. And as far as methods, we have hasRole, hasRoleExactly, hasRoleFromList, and a few others. Alright, now let's quickly go through these one by one. So, first name, last name, user ID, and username are simply properties on the GUser object. So they just hold the value of the current user's information. In this case, their first name, their last name, their user ID, and their username. Alright, then we have the getClientData method, which will return to us a value that was set using the putClientData method. We also have the getFullName method, which will return to us the current user's full name, so their first and last name. And then we have some roles methods. So we have hasRole, which accepts one argument, simply the name of the role, and returns to us a Boolean value, true or false, if the user has that role or not. Then we have hasRoleExactly, which is similar to hasRole, but it tests whether the user has the explicit role, or if it was inherited, it would return false. So oftentimes roles can be inherited from other roles, Well, the hasRoleExactly method would check if the user has been explicitly assigned a specific role. Next, we have hasRoleFromList, so we can actually provide a list of roles to this method, which is just a comma-separated string. And finally, we have the hasRoles method, which simply tests whether or not the current user has any roles at all and will return a Boolean value of whether or not they have any roles. Alright, so let's take a deeper look at the hasRoleExactly method. So again, it takes the name of the role as its argument and returns true only if the user has the specified role, even if they're an admin. So in this case, because I am an admin in my personal instance, I automatically receive the approval admin role, so the hasRole on line 1 returns true. So on line 2, when we use the hasRoleExactly, it's testing whether I've been explicitly assigned this role or if I've inherited it from another role. So in this case, because I haven't been explicitly assigned this role, it actually returns false here. So this shows the difference in using hasRole and hasRoleExactly. Alright, and finally we'll take a deeper look at the Glide user properties. So the Glide user API is a little different from the rest because it actually has documented API properties. Because they are simply properties on the object, we don't need any getter methods to access them. We can access them by just simply using guser dot and then the name of the property. So for example, we could log the user's first and last name by doing guser.firstname plus a space plus guser.lastname. And on line 2, we log the user ID using guser.userid. Line 3, the username, guser.username. Line 4, the department, guser.department ID. And finally on line 5, their roles using guser.roles. Hello and welcome back. In this video, we'll jump into ServiceNow and take a deeper look at the Glide user API. So as I stated in the Glide Form API video, one of the cool things about client-side APIs is we can actually log them in the browser's web console. So if we bring up your browser's console, we can do a console.dir and pass in the guser API. And here we get a formatted list of the object, so all of its properties and methods. We can see that we have an all roles array, which is just an array of the roles that the current user has. We have a client data object, as well as some properties, department ID, first name, full name, last name, and some additional methods and properties. So if we open up the proto object, we can see here the methods associated with this API. So get full name, get roles, get username, hasRole, hasRoleExactly, etc. Alright, so to start with, we'll take a look at the first name, last name, and user ID properties. We'll do a simple alert, and we'll just say hello, guser first name, plus a space, plus guser last name, plus the string, your user ID, plus guser user ID. So if we copy and paste this in the JavaScript executor, again, we can access this on a Mac using Control-Shift-J, and paste that in and run the code. We can see that the alert box says, hello, Mark Miller, your user ID is, and then the sysid of my user. All right, so instead of accessing two properties, the first name and last name, we can use a shortcut by using the getFullName method. So here we'll just do hello and then guser getFullName. We'll copy and paste that, and we can see here that it says hello, Mark Miller. All right, now let's take a look at the hasRoles method. So we'll just do a simple alert. Do you have any roles? And then log guser.hasRoles. Again, this method just returns a Boolean value if the current user has any roles or not. And we see true here because I do in fact have roles. All right, now let's take a look at the hasRole method. So for this, we'll do an alert. Do you have the ITIL role? And we'll do guser.hasRole and pass in the string value of the role name, which is just ITIL. Copy and paste that, and we can see here that it says true because I do in fact have the ITIL role. And finally, we'll take a look at the username property. So we'll just do an alert. Your username is, and then guser.username. So we can see here that my username is mark.miller within the system. Hello, and welcome to the last video in section 6. So, where can we use the GlideForm and GlideUser API? Well, it should be no surprise that these are, in fact, client-side APIs, and that we cannot access them on the server side. Alright, so as a developer, we'll use the GlideForm API to access information or manipulate a form in ServiceNow. So if we're on the incident form or problem form, and we need to manipulate the data somehow, we would use this gform API. If we would need to access information about the current user, we would use the GlideUser API. Again, both GlideForm and GlideUser are client-side APIs, and if we try to access them on the server side, we would get an undefined error. If you'd like to access the ServiceNow JavaScript executor on the client side, use Control+Shift+J, and it'll pop up a dialog box within your browser. Hello, and welcome to section 7, where we'll be talking about the Glide Ajax API. Alright, we have a lot to cover in this section, so we'll start off with a Glide Ajax introduction, then we'll cover what Ajax is in the industry, and we'll talk about synchronous versus asynchronous, and then we'll talk about the stages of Glide Ajax, followed by an example showing the Glide Ajax process. After we have the foundation set, then we'll actually jump into the Show Me the Code slide, where we'll go over an example. After that, we'll actually revisit script includes and discuss the role they play with Glide Ajax. Then we'll briefly cover the JavaScript callback and talk about how it's used with Glide Ajax. Next, we'll go over the difference between JSON and XML and discuss some of the pros and cons. Then we'll do a Glide Ajax API overview along with its methods. And then we'll finally jump into a demo where I'll demo 3 separate Glide Ajax examples. And then we'll end this section with a section recap. Okay, so the ServiceNow docs state the Glide Ajax class enables a client script to call server-side code in a script include. Sounds easy enough, but it turns out this is more complex than some of the other scripting examples we've seen. Okay, so the Glide Ajax API itself is a client-side API, but it's actually used to call server-side script includes. So there are client-side and server-side components to this process. It's similar to something like jQuery's Ajax method, if you're familiar with jQuery. Ajax stands for Asynchronous JavaScript and XML. It was popularized by Google in Google Maps and Gmail, and it's a way to make client-side requests to the server side without requiring a page reload. So there's actually a browser API, the XML HTTP request, that is used to make Ajax calls. And it turns out that behind the scenes, Glide Ajax is actually calling this browser API to make the request. But there's a layer of abstraction, so we don't have to worry about that. We just interact with Glide Ajax. So there's actually synchronous and asynchronous requests. And hopefully this slide will help to shed some light on these topics. Alright, so let's take a look at what these words mean in the world of web applications. So we'll start on the left-hand side with synchronous. And the left vertical line represents the client, and then the vertical line on the right represents the server. And in this diagram, we're going to be looking at requests from the client and responses to the server. So in a synchronous environment, when the client sends a request to the server and then is waiting for the response, the client is actually blocked. So it must wait for the response before it can start processing other events. So in this example, we can see that when the request is sent out, the client is blocked until it receives the response back from the server. So within a synchronous environment, we can see that the client or the browser is actually blocked. So it's unable to process events until it receives this response from the server. This is still a problem and fundamentally bad practice to build a web application in this nature, because we're never truly sure of how long the response is going to take from the server. So if we were to travel back in time to the late 90s, this response could take seconds, possibly even minutes to return. And in that amount of time, the client side will be completely blocked. So it'll essentially be frozen until it receives this response. Well, that's where Ajax comes into play with the asynchronous component. So now let's take a look at the asynchronous side. So on the right, we can see that when the client sends the request, that it is not blocked. And in fact, we can even make another request. Because we're not blocked, we can still compute, we can still process things. So you can see here in this diagram that the client has actually made 2 requests without even receiving the first response yet. So we can say asynchronous is non-blocking. And this is exactly what we want in modern day applications. Alright, next let's look at the 3 stages of Glide Ajax. So in the first stage, the client-side code calls the Glide Ajax API, which behind the scenes is making an XML HTTP request to the server. So this stage is triggered by some type of event, usually found in client scripts, such as an onload or when a field value changes, then the code that contains the Glide Ajax API is executed. So the second stage starts once the server receives this request from the client. So in the second stage, the server-side code processes the request and returns a response back to the client. So then in the third stage, client-side code processes the response. So we have to tell the browser what to do with the response from the server. So whether we're updating a field or doing some other type of event, we have to tell the browser what's going to happen once this request has been received. So we can see in the stages, it kind of goes from the client to the server back to the client. And at each stage, we need to explicitly tell the browser and the server what we want to do. All right, and finally, let's look at the two scripting locations to Glide Ajax. So as I've mentioned before, even though the Glide Ajax API is a client-side API, we are still accessing server-side code. So there are, in fact, two scripting locations. So the first, obviously, is the client-side code, which contains the Glide Ajax API and methods. These are oftentimes stored in either client scripts or UI pages. And we have an example here at the bottom on the left of a UI pages client script. And then on the right, we have our server-side code. The server-side code is stored in a script include. And on the bottom right, we have an image of a script include. Hello, and welcome back. In this video, we'll take a look at an example of the Glide Ajax process from start to finish. So for the purposes of this example, we'll say that when we're on a task record, such as an incident, after the form loads, we would like to make an Ajax request to the server side, updating the location of the current user, leveraging the browser's geolocation API. So again, once the page loads, the browser will pull in the current user's location and make a request in the background via Glide Ajax to the server side to save that to the record. Alright, so here on the first slide we have our client on the left and we have our server on the right. So in step 1, the client makes a request for a page that contains a client script with the Glide Ajax code. So in this diagram, the client is requesting a task form. So in step 2, we can see that the server processes the request from the client and sends the client the task form data along with the client script. In step 3, after the onload event occurs, the client-side script is executed, which calls the Glide Ajax API. Then in step 4, the Glide Ajax API accesses the browser's XML HTTP request API and generates a request. In step 5, the browser's XML HTTP request API sends the geolocation data back to ServiceNow in the background. So the user does not need to be redirected to another page. It's all happening in the background. In step 6, the request from the client invokes a script include on the server side where request data is used to call specific methods with arguments. Then, if this specific script include is sending any data back to the client, it will then be packaged up in the form of a response. So here in step 7, the browser receives a response from the server side. And finally, in step 8, the client script callback processes the returned data from the server and updates the location field on the task. Hello, and welcome back. In this video, we'll finally take a look at some Glide Ajax code and then walk through the stages of Glide Ajax. So in this example, we would like to update the short description field of an incident to Hello World once the page has loaded. So although it's not a very practical example, I tried to keep the initial one simple so we can understand what's going on. So here we have a client script on the incident table that's executed on load. And then on the right, we have our server-side code, which is the script include. So again, we start things off on the client side once a specific event is triggered. So in this case, the onload event would trigger the execution of this script. So on line 3, we create a new object which will hold the value returned to us from the Glide Ajax API. And when we call the Glide Ajax API, we pass in the name of the script include that we're looking to run. So in this case, we pass in the string name ServiceNow 201 Glide Ajax, which again is the name of the script include in ServiceNow. This must be the exact same. Now on line 4, we have ga.addParam. So we're adding a parameter to the Glide Ajax request. So we have the first argument, which is the name of our parameter, sysparm name. And then the second argument is the name of the first function or method we would like to call. In this case, say hello. So the first 2 lines instruct our code to execute the say hello method found within the ServiceNow 201 Glide Ajax script include. Then on line 5, we have ga.getXML, where we pass in the name of our callback function, Ajax processor. It's important to note here that we're just passing in the name of the function. We're not actually invoking the function with parentheses at the end. So line 5 is what actually triggers the Ajax request. So now the request will be sent to the server where the say hello method is invoked. And finally, we get to a return statement where we just simply return the text hello world. Once ServiceNow sees a return statement in the script include, it'll automatically package up the result and send it back to the client side in XML format. So once this comes back to the client side, our Ajax processor callback function is invoked, where we pass in the response as an argument. So on line 9, we create a new variable, answer, and we assign it the value returned to us from response.response.xml.documentElement.getAttribute answer. So what that's doing is actually stepping through the XML of the returned result, and our hello world is stored within an answer XML node. So that's getting the attribute of answer and assigning that to our JavaScript variable answer. And then on line 10, we're using the gform.setValue method where we're setting our answer to the short description field. Alright, so I know that was a lot to take in, so let's spend the rest of this video taking a deeper look at the 3 stages of Glide Ajax. Alright, so it all starts with Glide Ajax, and I have a circle with the number 1 in the top right corner showing that this slide relates to the first stage of Glide Ajax. So we're on the client side, and some event is about to happen where we create our Glide Ajax object. So in this example, the onload event is what triggers our Glide Ajax code to run. So first, we create a new Glide Ajax object. Second, we add the name of the script include method as the sysparam _ name parameter. And third, we call the getXML method and pass the name of the callback as an argument. It's important to note that we can pass as many parameters to our script include as we would like, as long as they start with the name sysparm _. So we could have sysparm _ first name, sysparm _ last name, etc. However, the sysparm _ name is specifically what the system looks for to invoke the first method. So the sysparm name parameter will always be the name of the method we would like to first call in the script include. And as stated before, on line 5, we pass the name of the callback Ajax processor as opposed to invoking the function, which would be Ajax processor parentheses. All right, so once that getXML method is called, the browser sends the actual AJAX request to the server, ending stage 1 and starting stage 2, where we find ourselves on the server side. So we talked about script includes earlier in this course, but let's revisit them. So again, script includes run on the server side, and they contain reusable snippets of code, making them very modular. If you find yourself writing the same functions again and again, consider putting them in a script include and invoking the script include from another source. It's important to note that script includes are only executed when invoked from another source. So in this case, client side using glide AJAX, or on the server side using the new JavaScript operator. We'll take a closer look at this in the next section. Script includes may also extend other JavaScript classes, which can be very powerful when building more complex applications. And in the next slide, we'll take a look at how glide AJAX actually leverages this inheritance. So when script includes are used for glide AJAX, we must have the client callable checkbox set to true. What this does is actually modifies the JavaScript in our script, and it'll automatically extend the abstract AJAX processor class, which we'll go over in the next slide. So script includes that are called from glide AJAX typically query a table and return a record or set of records back to the client side as JSON, where then it is then processed and rendered on the client. Glide AJAX script includes have access to any variable from the client side that starts with the sysparm underscore. And again, the sysparm underscore name is used to invoke the first method in the script include. Alright, so let's quickly discuss extending the abstract AJAX processor. Again, we're still on the server side in script includes, so we're still in stage 2. So abstract AJAX processor is actually an out-of-the-box script include, and you can find it in any instance. This provides helper methods that we actually use when working with the glide AJAX API. Again, we can see that the client callable field is checked. So if we take a closer look at the code found in the Show Me the Code slide, on line 2, we can see here that we have our newly created class, ServiceNow 201 Glide AJAX, and we're actually extending the abstract AJAX processor. So we do ServiceNow 201 Glide AJAX.prototype equals object.extends object, where we pass in abstract AJAX processor. And then as of the second parameter, we pass in our script and the script include. So now we can leverage all of the methods found in the abstract AJAX processor within our extended ServiceNow 201 Glide AJAX script include. Alright, so while we're still in stage 2, let's quickly walk through the Glide AJAX script include process. So first, the method passed in sysparm name gets invoked. The server-side scripts are ran, and then we come to a return statement which ends the server-side script execution, and then ServiceNow packages up our response in XML and actually sends it back to the client. Once ServiceNow sends the response to the client, stage 2 is done, and now we get to the last stage, stage 3. So let's take a deeper look at this returned payload. So as I've stated before, it is XML. So even if we encode an object in JSON on the server side, it still gets wrapped in XML and sent as a response. Then on the client side, we use the following to retrieve the answer value found in the answer node, which is response.responseXML.documentElement.getAttribute, where we pass in the string argument of answer. And here we can see a snippet from the Chrome developer tools where I'm actually inspecting the network traffic. And we can see here the raw XML that is actually returned to us from the server. So we can see our answer node, hello world. And here is the full XML payload. Alright, so now let's quickly discuss the JavaScript callback. So a callback is a function that is passed as an argument, which is then executed at a later time. Callbacks can be a little tricky to completely understand, and unfortunately they're out of the scope of this course, but if you would like to learn more about them, I highly recommend checking out the article found in the Dive Deeper notification below. The only thing you need to know is that once the client receives the response from the server, this callback function is invoked. So stage 3 starts when the client receives the response from the server. It'll automatically call our AJAX processor function, where we can then process the response with any client-side code. Again, in this case, we're simply setting the short description to the answer value. Alright, now let's take a look at the 2 ways to transfer data between the client and server. So the first is JSON. It's JavaScript object notation. JSON is very easy and fast to parse and uses collections of key value pairs with support for arrays. XML stands for Extensible Markup Language and uses nodes and node attributes, but can be a bit of a pain to parse. If you'd like to learn more about the differences, I recommend checking out the YouTube video and the Dive Deeper notification below. So here's a quick comparison of XML to JSON. So here we have a collection of 3 incidents. We can see that the XML looks very similar to HTML. It turns out HTML is actually a subset of XML. So we have the opening and closing tags for each node. Now on the right we have the JSON, which although it's a couple lines longer, actually contains less characters. And we can see that we can leverage arrays. Alright, now let's quickly take a look at the getXML answer method. So this is actually a shortcut to the getXML method and the response.responseXML.documentElement.getAttribute answer. So if we use this method in place of the getXML, so on line 4 we're calling ga.getXML_answer and then passing in the callback function, we don't actually have to use this long response.responseXML, etc. The API actually does that for us and then just simply passes that answer value to us as opposed to the full response value. So we can comment line 8 out and simply go gform.setValue, short description, and then the answer, which is passed in as an argument. Alright, so although the Glide Ajax API is fairly complex and there's a lot going on behind the scenes, the actual API is fairly simple and straightforward. We have 3 main methods exposed to us. The add param, where we're adding parameters to the request, the getXML, and then the shorthanded getXML answer methods, which actually trigger or initiate the request to the server. Hello and welcome back. In this video, we'll take a look at 3 Glide Ajax examples within ServiceNow. So we'll start nice and simple by using Glide Ajax on an incident form. So we'll say when an incident form loads, we would like Glide Ajax to reach out to the server, grab a string value from a script include, in this case hello world, and send it back to us. When we receive it on the client side, we'll update the short description of the current incident. Alright, so let's get started. So we'll start by creating the script include first. That'll house our methods for this video. So we'll navigate to script includes and click new. And we'll give the script include a name, ServiceNow 201 Glide Ajax. Now this name is important because we'll use this when we reference our script include in the Glide Ajax script. Now when I leave the name field, you can see that the script field auto-populates with some JavaScript. And then in addition to that, when I click the client callable, which allows the script include to be called from the client side, which is exactly what we want for our Glide Ajax, some additional JavaScript is populated in the script field. So now we can see that on line 1, we have our ServiceNow 201 Glide Ajax class created. And then on line 2, it's actually extending the out-of-the-box abstract Ajax processor script include. So you can see our script include is extending the functionality from another script include. This is why script includes can be so powerful, because they're modular. Alright, and now it's time to write our method. So our first method name will just be simply say hello. So we'll write say hello semicolon, and note that it's a semicolon instead of an equals sign, because this is actually a property in a JavaScript object. Then we'll provide the function keyword, and then we'll simply return hello world. So when this method gets called and executes, all it's going to do is return the text hello world back to whatever called it, in this case, the Glide Ajax client script. Alright, so we'll simply submit it. And we'll go ahead and copy the name so we can paste this in the client script we're about to create. So now we'll navigate to the incidents table and click the configure client scripts, where we'll create a brand new client script to house our Glide Ajax JavaScript. So we'll provide a name, and we'll say we want this to run on load. Now, when we select on load, you can also see that some JavaScript is generated for us. Just a simple function on load, which will get called once ServiceNow has loaded and rendered all of the resources required for this specific page. So we'll just go ahead and copy that JavaScript and paste it in our text editor. And now we'll write our Glide Ajax JavaScript. So on line 3, we'll create a new variable, GA, and we'll initialize our Glide Ajax API. So we'll do new Glide Ajax, and then we will type in the name of our script include, ServiceNow 201 Glide Ajax. Now on line 4, we'll add the name of the method we want to call. So we'll do ga.addParam, and then we'll pass in the keyword sysparm_name, which again, this is the name of the first method we'd like to call. We'll provide say hello, and then on line 5, we'll do ga.getXML, and we'll pass in the name of our callback function, and then we'll create this callback function. So on line 8, we'll do function Ajax processor, and we'll have response passed in as an argument. And then on line 9, we'll grab the answer from the response. So we'll do response.response.document-element.getAttribute answer. And now we'll simply update the incident's short description field with our hello world text. Alright, so we'll copy and paste that in the script field, and we'll go ahead and submit this. Now we'll navigate back to the incidents, and when we go into a specific incident, we'll see that the short description field, in fact, gets overwritten by our hello world text. We'll go ahead and reload the form again, and we can see that initially the short description appears, then the glide Ajax JavaScript gets executed, and then the request is sent to the server. The server processes that, sends us a response where the hello world text is updated. So now we'll take a look at this packet within the Mozilla Developer Tools under the Network tab. So if we click on XHR, we'll filter all XML responses. And we'll go ahead and reload the ServiceNow form. And we're looking for an XML http.do file. Alright, so this one looks to be it. We can see that the sysparm processor is ServiceNow 201 Glide Ajax. And if we go to the response tab, we can see the actual XML. So we can see that the answer node contains the hello world text. Pretty cool. Now we'll go ahead and deactivate that client script so it no longer loads. Okay, now let's take a look at the second Glide Ajax example. So in this example, we'll use a UI page where we'll write our Glide Ajax code, and then we'll leverage the same script include as before, just providing a new method that will be called. So in this example, we would like to log the status of a specific incident every 5 seconds to the browser's console using the UI page. So we'll start by adding the new method to our script include. So we'll navigate back to our script include, and we'll jump back into our text editor, and we'll create a new method, getIncidentStatus. So here on line 5, we'll get the incident number passed to us by using this.getParameter and then the name of the parameter, in this case sysparm _incident _number. So then we'll do a simple check. So we'll say if the incident number is not null, then we'd like to continue. So on line 7, we'll do a glide record query where we'll get the incident with the number that was passed to us. So here we'll simply return the incident state. If the number was null, we'll simply return a message, no incident was found. Alright, so we'll copy and paste that new method into our script field. We'll go ahead and save that. And now it's time to create the UI page. So we'll navigate to UI pages. Click New. And provide a name. And since we're logging the state to the console, we don't actually need the HTML field. But for the purposes of this example, we'll just go ahead and put in example2 in an H1 tag. And now we'll jump to the client script section. So in order to get this Glide Ajax code to execute every 5 seconds, we'll leverage the browser's setInterval method, which takes two arguments. The first argument is an anonymous function, which is where we place the code we would like to run. And then the second argument is the time in milliseconds. So we'll put in 5,000 for 5 seconds. And then we'll create the function process request. So within the process request function, we'll initialize our glide Ajax. So we'll pass in the name. We'll add the parameter for the method name. In this case, get incident status. And then we'll pass in another parameter, the sysparm incident number. So we'll quickly grab an incident number, and we'll go ahead and paste that in. So nothing fancy, we're just hard coding an incident number. And then on line 9, we'll do ga.getXML. We'll provide the callback, Ajax processor, and then we'll create the callback function. We'll grab the answer from the XML node, and then we'll simply log the status to the console. All right, we'll save this. We'll open up the console, and we'll click Try It. All right, so now we see that we're getting the state of active. So if I bring up another window with that incident and change the state to new, and save that, we can see that we're now getting the new status. And real quick, we'll inspect the package again, and we can see that the answer is the state of the incident, in this case, new. Note that you should never use something like this in a production instance. This code is just for demo purposes. ServiceNow provides other APIs that are much more efficient than using the browser's set interval function. Hello, and welcome back. In this video, we'll take a look at our third and last example of Glide Ajax. In this example, we'll use another UI page, and we'll grab a number of incidents, and we'll print those to the console. So to start with, we'll add a new method to our script include, and we'll call this getLatestIncidents. So on line 16, we'll create a new variable, incidents, and we'll assign this as an array, which will hold our incidents. Then on line 17, we'll create a new variable, limit, and we'll actually grab a limit passed to us from the client, which we'll use in a setLimit method for glide record. So because this will be passed as a string, we'll have to use the JavaScript parseInt function, which will parse this string into an integer. So on line 18, we'll do a simple check. We'll make sure that there is, in fact, a limit, and that the type of this limit equals a number. Then we'll start our glide record script. We'll order by syscreated on, and then we'll set the limit to the limit passed to us. And then we'll query this. So on line 24, I'm creating a new variable record, which is just now a blank object. And then on lines 25 through 27, I'm creating properties on this object, number, sysid, and short description. And I'm setting those values to the incident values. Finally, on line 28, I'm pushing this object to our incidents array. And then after that loop is executed, I'm returning the array. But first, I'm actually going to encode this into JSON. So one of the ways to do this is to use the JSON API in ServiceNow. So we'll just do new JSON.encode, and we'll pass in our array incidents. So ServiceNow will automatically encode our incidents array into JSON and return that back to the client. All right, so we'll copy and paste that code. And now we'll create our UI page. So we'll provide example 3 and an h1 tag. And then we'll write our client script. So we'll initialize our Glide Ajax API. We'll call the getLatestIncidents method. And we'll pass in a value of 5 for our limit. So this should pull the 5 latest incidents. Next, we'll add our getXML method, passing in our Ajax processor callback. Then we'll create our Ajax processor method, passing in the response. We'll go ahead and log the response to the console. And then grab the answer from the response using response.response.document-element.getAttribute answer. Then we'll go ahead and log the answer. And finally, we'll parse the JSON. So we'll create a new variable JSON, and we'll assign that the value from answer.eval.json. We'll go ahead and log this. And then on line 12, we'll go ahead and log the short description of the first incident within the JSON by doing JSON 0index.shortDescription. We'll go ahead and save this, click try it. open the console, and we can see that we get a number of things back to us. So first is the response payload, the object XML HTTP request. And then we have our answer, which is currently a string representing the JSON. And then we parse the JSON. So then we have 5 objects. And then finally we've logged the first incident short description, incident number 5. We'll switch over to the network tab, find the XML HTTP.do file, go to the response, and we can see the raw XML. Hello, and welcome to the last video in section 7, where we'll do a quick section recap. So, where can we use Glide Ajax? Well, we just saw that we can use the Glide Ajax API on the client side. However, there's multiple components involved in Glide Ajax, where we call script includes on the server side as well. So whenever we want to use Glide Ajax, we're actually using components from the client side, using Glide Ajax API and callback functions, as well as server-side code, which is stored in script includes. As a developer, we use the Glide Ajax API when we'd like to access server-side data while on the client side. So, for example, if we're on a catalog item and the user populates a certain field, maybe we would like to take that field and grab a value from the server side and populate another field on the form without the user having to be redirected somewhere else. We want this to happen in the background. Glide Ajax is available to us within any client-side scripting location. We use script includes to store the server-side code we'd like to run with Glide Ajax. By default, and at the recording of this video, XML is returned by the Glide Ajax API. We use APIs to encode and decode the JSON. These can either be ServiceNow APIs, like what we see on the server side, or even browser APIs if we want to parse JSON within the client-side code. We can actually call the browser's parse method. Hello, and welcome to Section 8, where we'll explore other APIs within ServiceNow. We'll start this section by first looking at the Glide Date Time API. We'll go over some of the popular methods, and then take a look at a demo. Then we'll transition into the Glide Element API. We're already familiar with some of these methods due to Glide Record, but we'll take a deeper look at these. Next is the XML Document To API, which might be used for things like web services. Then we'll quickly take a look at a list of other APIs within the ServiceNow platform. And then we'll cover some of the undocumented APIs. And I'll show you a few tips and tricks on how to find out more about these undocumented APIs. Then we'll take a look at script includes and even creating our own API using script includes. We'll end this section with a section recap. So let's get started. The ServiceNow docs explain the Glide Date Time API as the scoped Glide Date Time class provides methods for performing operations on Glide Date Time objects, such as instantiating Glide Date Time objects or working with Glide Date Time fields. As a developer, you'll use the Glide Date Time API anytime you need to do date time operations or format date times, or convert between date and time formats. This is a server-side API and cannot be accessed on the client side. This slide shows us 3 ways to instantiate a glide date time object. The first way, on line 2, is we just simply do new glide date time without any arguments. This will create a new glide date time object with the current system time and assign that to the GDT variable. The second option on line 5 is we can actually pass in a string value of the date time we would like the glide date time object to be representing of. So here we can see we pass in 2017 05 25 space 12 02 30. Finally, the third option shows a variable with that string already assigned to it, and then we're just simply passing in that variable as an argument. So lines 5 and 9, the glide date time are essentially identical. There's just a different method of passing in that string value. Here's a list of some of the common glide date time methods. This doesn't represent all of them, but just some of the more commonly used methods. So we have an add method that adds milliseconds to a glide date time object. We have add days UTC, which adds days to the glide date time object. Add months UTC, add seconds, add weeks, add years, etc. We have before and after methods that will compare 2 glide date times to each other. We also have the compare to method. We have an equals, which will compare 2 glide date times and return true if they are equal to each other. We have a getDate method, which will return the date stored in the glide date time object. We have getDayOfMonth UTC, getLocalTime, getMonth UTC, getTime, getWeekOfYear UTC, getYear UTC. We have an isValid method, which will test if the glide date time object is valid. We have on or before or on or after methods. And then we also have a subtract method, which we'll take a deeper look at here in just a second. Alright, so the subtract method will return the difference in days, minutes, and or seconds between 2 dates. So on line 1, I have a new glide date time object assigned to the variable start, which represents January 1st, 2017 at 9 a.m. On line 2, I have another variable, end, which is assigned a glide date time that represents January 7th at 8 a.m. of 2017. Then on line 4, I create a new variable, difference, and assign this the value returned to us from glide date time dot subtract, where we pass in 2 arguments, the start and the end time. Then on line 5, we'll simply print the display value of this difference. So here we can see that the difference between the start and end dates is 5 days and 23 hours. Alright, enough slides. Now let's actually jump into ServiceNow and take a look at the API. So for the purposes of this API, we'll be using our handy-dandy background scripts where we'll execute our code. We'll start things off by recreating what we saw in an earlier slide. So we'll create 3 GDT variables, GDT, GDT2, and GDT3, and assign these the values of our instantiated glide date time object. Finally, we'll go ahead and print each one of these to the screen. So if we copy and paste this code in a background script and click Run, we can see that we do in fact have 3 glide date times. If I come back to the code, I'm going to quickly put in the type of JavaScript keyword, which will now print the type of value this is. So just to show you that this is not a string and it's actually an object in JavaScript, we'll go ahead and do type of all 3 variables, and we can see that we get object. So that represents our glide date time object. All right, now let's take a look at the add days UTC method. So we'll keep line 1 where we just create a new glide date time object of the current date. And then on line 2, we'll go ahead and log that. So we'll give it a value of now plus the GDT. And then on line 3, we'll do gdt.addDaysUTC, where we pass in an integer 3 representing the number of days we'd like to add. Now we'll go ahead and print this to the screen. So if we copy and paste this code, we can see that the new value represents 3 days in the future. All right, now let's quickly look at add months UTC. So for this, we'll simply change the method name and leave it as 3. Copy and paste that code and we can see that it's 3 months in the future now. And we'll also do the same for add years UTC. So we can see that this is 3 years in the future. Now let's take a look at the before method. So this will test 2 dates and see if the second date is before the first. So on line 1, we'll keep our new date. And then on line 3, we'll create a new glide date time. And we'll do a gs.print is GDT before GDT2. And then do gdt.before, where we pass in the second glide date time object as its argument. So we'll copy and paste that, and we can see that we get false here. And this is actually the case because the glide date time object is evaluating these based on the second. And because the system is processing these within the same second, GDT isn't technically before GDT2. So to fix this, we'll go ahead and throw a string value in our first glide date time that we know is in the past, and test this again, and we do in fact see true. Alright, now let's use the compare to method. So the compare to is similar to the before or after, except instead of getting a Boolean value back, we get a 0 if the dates are equal, we get a 1 if the initial date is before the compared date, and we get a -1 if the initial date is after the compared date. So let's take a look. We can see that we get a -1 here because GDT2 comes after GDT. If we reverse them, we'll get a 1. And then if we make them both equal to each other, you can see that we get a 0. All right, now let's take a look at the subtract method. So for this, we'll go ahead and pass in a string value to our first glide date time that we know is in the past. We'll go ahead and print that to the screen. And then we'll create a new glide date time object, GDT2, with the current time, and we'll go ahead and print that. And then finally, we'll create a new variable, difference, and assign it the value returned to us from glide date time.subtract GDT2. Finally, we'll go ahead and print this to the screen. So you can see that there is a 3-minute difference between the two. It's important to note that seconds are not evaluated with this method. Hello, and welcome back. In this video, we'll take a look at the Glide Element API. So the ServiceNow docs state, the scoped Glide Element API provides a number of convenient script methods for dealing with fields and their values. Scoped Glide Element methods are available for the fields of the current glide record. So, as I stated in the last video, we've actually played around with Glide Element before. We just weren't aware of it because glide record and glide element go hand in hand. It turns out that anytime we want to manipulate a field value with glide record, we're actually using glide element. So as the developer, we'll use glide element when accessing glide record fields and manipulating glide record fields. This is a server-side API, so we cannot use this on the client side. Alright, so let's take a look at glide element's getDisplayValue method. Now, obviously, we should be very familiar with what this does. However, let's take a deeper look at it. So on the left, I have some code where in the first example, direct access, I'm trying to print the caller ID of a specific incident to the screen. In the second example, on line 9, I'm trying to print the caller ID field to the screen using the JavaScript's toString method. Finally, in the third example, on line 14, I'm using the glide element's getDisplayValue method on the caller ID. So, what will these three print? Well, it turns out that line 4 prints the sysID. Because this is a reference field, the sysID is actually stored in the reference field. On line 9, we also see that we get the sysID of that field. So this doesn't work either. Every table that's being referenced from a reference field has a display value defined. Oftentimes it's the number on something like an incident field, or maybe the user's full name on the sysuser table. Well, it turns out that every table that is referenced via a reference field actually has a display property that's set. On something like the incident or problem table, this is commonly the number field. On the sysuser table, this is the name field. So when we use the getDisplayValue, it's actually pulling whatever the display value is set on the user table, since caller ID references the sysuser table. So for the third example, we can see that we get Mark Miller instead of the sysID. Alright, now let's take a look at glide element's getHTML value. So this does just what it says. It gets the actual HTML stored within an HTML field. So for example, we'll use glide record to query a specific knowledge base article. And if we print kbarticlegr.text, which is the text of the actual knowledge base, this is an HTML field type. But if we print the text using the getHTMLValue method, we can see that the actual HTML is fetched and sent to us. Now let's take a look at the getJournalEntry glide element method. So there are certain fields in ServiceNow, such as comments on an incident or problem table, that actually keep a journal. So when you leave a new comment and that comment gets saved, It keeps track of the time and some other metadata about who saved that comment. If we try to retrieve these comments just using incident.gr.comments, say on line 3, we wouldn't get anything back. Because this is a journal field, we need to use the getJournalEntry method. And if we pass in a -1, this will go ahead and send us all of the journal entries affiliated with the comments field. Alright, and now let's jump into ServiceNow and take a deeper look at Glide Element. So to start with, we'll actually copy the sysid of an incident, and we'll quickly provide a caller in the caller field. So we'll provide Mark Miller. We'll save that record. And now let's jump into our text editor. So in this first example, we'll actually recreate what we just saw in one of the slides. So on line 4, we'll print incident.gr.callerID using the direct access. On line 9, we'll print incident.gr.callerID.toString using the toString method. And finally, on line 14, we'll print incident.gr.callerID.getDisplayValue using the getDisplayValue method. So as we can see again, the first two have the sysid, which is what's stored in that reference field, but the third has the display value. Now let's quickly jump into a knowledge article and copy the sysid of this specific knowledge article. We're actually going to be grabbing this HTML text found in this text field here. So let's jump back into our code editor. We'll do a glide record and pass in that sysid within the get method. And now we'll print the HTML using kbarticlegr.text.getHTMLValue. Here we can see that we have the raw HTML sent to us. Now let's go back into an incident and let's add some comments to the comments field. Next, let's copy the sysid and then jump in the code editor to take a look at get journal entry. So we'll create a glide record and pass in the sysid within the get method. And then on line 3, we'll print incident.gr.comments.getJournalEntry -1, which will print all of the comments stored in the journal field. So here we can see the comments. We can see the metadata associated with them. So when this comment was created, who it was created by, and the actual comment itself. Now if we provide a 1, we'll get the first comment back. Alright, so as we saw in the glide system video, it turns out glide element also has a nil method. So let's test this out now. So let's say we want to print all of the incident numbers to the screen whose short description is nil or null. So we'll create a new glide record. We'll do our while statement. And then within that, we'll do an if statement. If incident gr.shortDescription.nil, then we'll go ahead and print that incident number to the screen. Alright, and here we can see a handful of incidents without their short description. To verify, we'll copy a number and we'll search for it. And we can see that there is no short description within the short description field. Hello, and welcome to Section 8, where we'll explore other APIs within ServiceNow. We'll start this section by first looking at the glide date time API. We'll go over some of the popular methods, and then take a look at a demo. Then we'll transition into the glide element API. We're already familiar with some of these methods due to glide record, but we'll take a deeper look at these. Next is the XML document to API, which might be used for things like web services. Then we'll quickly take a look at a list of other APIs within the ServiceNow platform. And then we'll cover some of the undocumented APIs, and I'll show you a few tips and tricks on how to find out more about these undocumented APIs. Then we'll take a look at script includes and even creating our own API using script includes. We'll end this section with a section recap. So let's get started. The ServiceNow docs explain the glide date time API as the scoped glide date time class provides methods for performing operations on glide date time objects, such as instantiating glide date time objects or working with glide date time fields. As a developer, you'll use the glide date time API anytime you need to do date time operations or format date times, or convert between date and time formats. This is a server-side API and cannot be accessed on the client side. This slide shows us 3 ways to instantiate a glide date time object. The first way, on line 2, is we just simply do new glide date time without any arguments. This will create a new glide date time object with the current system time and assign that to the GDT variable. The second option on line 5 is we can actually pass in a string value of the date time we would like the glide date time object to be representing of. So here we can see we pass in 2017, 05, 25, space, 12, 02, 30. Finally, the third option shows a variable with that string already assigned to it, and then we're just simply passing in that variable as an argument. So lines 5 and 9, the glide date time are essentially identical. There's just a different method of passing in that string value. Here's a list of some of the common glide date time methods. This doesn't represent all of them, but just some of the more commonly used methods. So we have an add method that adds milliseconds to a glide date time object. We have add days UTC, which adds days to the glide date time object. Add months UTC, add seconds, add weeks, add years, etc. We have before and after methods that will compare 2 glide date times to each other. We also have the compare to method. We have an equals, which will compare 2 glide date times and return true if they are equal to each other. We have a getDate method, which will return the date stored in the glide date time object. We have get day of month UTC, get local time, get month UTC, get time, get week of year UTC, get year UTC. We have an isValid method, which will test if the glide date time object is valid. We have on or before or on or after methods. And then we also have a subtract method, which we'll take a deeper look at here in just a second. Alright, so the subtract method will return the difference in days, minutes, and or seconds between two dates. So on line 1, I have a new glide date time object assigned to the variable start, which represents January 1st, 2017 at 9 a.m. On line 2, I have another variable, end, which is assigned a glide date time that represents January 7th at 8 a.m. of 2017. Then on line 4, I create a new variable, difference, and assign this the value returned to us from glide date time dot subtract, where we pass in two arguments, the start and the end time. Then on line 5, we'll simply print the display value of this difference. So here we can see that the difference between the start and end dates is 5 days and 23 hours. Alright, enough slides. Now let's actually jump into ServiceNow and take a look at the API. So for the purposes of this API, we'll be using our handy-dandy background scripts where we'll execute our code. We'll start things off by recreating what we saw in an earlier slide. So we'll create 3 GDT variables, GDT, GDT2, and GDT3, and assign these the values of our instantiated glide date time object. Finally, we'll go ahead and print each one of these to the screen. So if we copy and paste this code in a background script and click Run, we can see that we do in fact have 3 glide date times. If I come back to the code, I'm going to quickly put in the type of JavaScript keyword, which will now print the type of value this is. So just to show you that this is not a string and it's actually an object in JavaScript, we'll go ahead and do type of all 3 variables, and we can see that we get object. So that represents our glide date time object. Alright, now let's take a look at the addDaysUTC method. So we'll keep line 1 where we just create a new glide date time object of the current date. And then on line 2, we'll go ahead and log that. So we'll give it a value of now plus the GDT. And then on line 3, we'll do gdt.addDaysUTC, where we pass in an integer 3 representing the number of days we'd like to add. Now we'll go ahead and print this to the screen. So if we copy and paste this code, we can see that the new value represents 3 days in the future. Alright, now let's quickly look at addMonthsUTC. So for this, we'll simply change the method name and leave it as 3. Copy and paste that code and we can see that it's 3 months in the future now. And we'll also do the same for add years UTC, so we can see that this is 3 years in the future. Now let's take a look at the before method. So this will test 2 dates and see if the second date is before the first. So on line 1, we'll keep our new date. And then on line 3, we'll create a new glide date time. And we'll do a gs.print is GDT before GDT2. And then do GDT.before, where we pass in the second glide date time object as its argument. So we'll copy and paste that, and we can see that we get false here. And this is actually the case because the glide date time object is evaluating these based on the second. And because the system is processing these within the same second, GDT isn't technically before GDT2. So to fix this, we'll go ahead and throw a string value in our first glide date time that we know is in the past, and test this again, and we do in fact see true. Alright, now let's use the compare to method. So the compare to is similar to the before or after, except instead of getting a Boolean value back, we get a 0 if the dates are equal, we get a 1 if the initial date is before the compared date, and we get a -1 if the initial date is after the compared date. So let's take a look. We can see that we get a -1 here because GDT2 comes after GDT. If we reverse them, we'll get a 1. And then if we make them both equal to each other, you can see that we get a 0. Alright, now let's take a look at the subtract method. So for this, we'll go ahead and pass in a string value to our first glide date time that we know is in the past. We'll go ahead and print that to the screen. And then we'll create a new glide date time object, GDT2, with the current time, and we'll go ahead and print that. And then finally, we'll create a new variable, difference, and assign it the value returned to us from glide date time.subtract GDT GDT2. Finally, we'll go ahead and print this to the screen. So you can see that there is a 3-minute difference between the two. It's important to note that seconds are not evaluated with this method. Hello, and welcome back. In this video, we'll take a look at the Glide Element API. So the ServiceNow docs state, the scoped Glide Element API provides a number of convenient script methods for dealing with fields and their values. Scoped Glide Element methods are available for the fields of the current glide record. So, as I stated in the last video, we've actually played around with Glide Element before, we just weren't aware of it, because glide record and glide element go hand in hand. It turns out that anytime we want to manipulate a field value with glide record, we're actually using glide element. So as the developer, we'll use glide element when accessing glide record fields and manipulating glide record fields. This is a server-side API, so we cannot use this on the client side. Alright, so let's take a look at Glide Element's getDisplayValue method. Now, obviously, we should be very familiar with what this does. However, let's take a deeper look at it. So on the left, I have some code where in the first example, direct access, I'm trying to print the caller ID of a specific incident to the screen. In the second example, on line 9, I'm trying to print the caller ID field to the screen using the JavaScript's toString method. Finally, in the third example, on line 14, I'm using the Glide Element's getDisplayValue method on the caller ID. So, what will these three print? Well, it turns out that line 4 prints the sysID. Because this is a reference field, the sysID is actually stored in the reference field. On line 9, we also see that we get the sysID of that field, so this doesn't work either. Every table that's being referenced from a reference field has a display value defined. Oftentimes it's the number on something like an incident field, or maybe the user's full name on the sysuser table. Well, it turns out that every table that is referenced via a reference field actually has a display property that's set. On something like the incident or problem table, this is commonly the number field. On the sysuser table, this is the name field. So when we use the getDisplayValue, it's actually pulling whatever the display value is set on the user table, since caller ID references the sysuser table. So for the third example, we can see that we get Mark Miller instead of the sysID. Alright, now let's take a look at Glide Element's getHTML value. So this does just what it says. It gets the actual HTML stored within an HTML field. So for example, we'll use Glide Record to query a specific knowledge base article. And if we print kbarticlegr.text, which is the text of the actual knowledge base, this is an HTML field type. But if we print the text using the getHTMLValue method, we can see that the actual HTML is fetched and sent to us. Now let's take a look at the getJournalEntry Glide Element method. So there are certain fields in ServiceNow, such as comments on an incident or problem table, that actually keep a journal. So when you leave a new comment and that comment gets saved, it keeps track of the time and some other metadata about who saved that comment. If we try to retrieve these comments just using incidentgr.comments, say on line 3, we wouldn't get anything back. Because this is a journal field, we need to use the getJournalEntry method. And if we pass in a -1, this will go ahead and send us all of the journal entries affiliated with the comments field. Alright, and now let's jump into ServiceNow and take a deeper look at Glide Element. So to start with, we'll actually copy the sysID of an incident. And we'll quickly provide a caller in the caller field. So we'll provide Mark Miller. We'll save that record. And now let's jump into our text editor. So in this first example, we'll actually recreate what we just saw in one of the slides. So on line 4, we'll print incidentgr.callerID using the direct access. On line 9, we'll print incidentgr.callerID.toString using the toString method. And finally, on line 14, we'll print incidentgr.callerID.getDisplayValue using the getDisplayValue method. So as we can see again, the first two have the sysid, which is what's stored in that reference field, but the third has the display value. Now let's quickly jump into a knowledge article and copy the sysid of this specific knowledge article. We're actually going to be grabbing this HTML text found in this text field here. So let's jump back into our code editor. We'll do a glide record and pass in that sysid within the get method. And now we'll print the HTML using kbarticlegr.text.getHTMLValue. Here we can see that we have the raw HTML sent to us. Now let's go back into an incident and let's add some comments to the comments field. Next, let's copy the sysid and then jump in the code editor to take a look at get journal entry. So we'll create a glide record and pass in the sysid within the get method. And then on line 3, we'll print incidentgr.comments.getJournalEntry -1, which will print all of the comments stored in the journal field. So here we can see the comments. We can see the metadata associated with them. So when this comment was created, who it was created by, and the actual comment itself. Now if we provide a 1, we'll get the first comment back. Alright, so as we saw in the glide system video, it turns out glide element also has a nil method. So let's test this out now. So let's say we want to print all of the incident numbers to the screen whose short description is nil or null. So we'll create a new glide record. We'll do our while statement. And then within that, we'll do an if statement. If incidentgr.shortDescription.nil, then we'll go ahead and print that incident number to the screen. Alright, and here we can see a handful of incidents without their short description. To verify, we'll copy a number and we'll search for it. And we can see that there is no short description within the short description field. Hello, and welcome back. In this video, we'll take a look at the XML Document To API. So the ServiceNow docs state, XML Document To is a JavaScript object wrapper for parsing and extracting XML data from an XML string. So as a developer, we would use the XML Document To API when working with XML documents and nodes commonly found within web services. This is a server-side API, so we cannot use this on the client side. Alright, Now let's take a look at an example. So here I have a snippet of the XML found from a specific incident. We can see that it looks very similar to HTML. We have an XML tag, then we have an incident tag, and then within the incident tag, we have a number of other tags or nodes that contain values specific to this incident. Now below, I have some JavaScript. So on line 1, we have an XML string variable which contains just that. It's simply a string, but it's valid XML if we were to parse this. So on line 3, we'll initialize the XML document2 API by calling new XML document2 and assigning that to the XML document variable. Then on line 4, we can do XML document.parseXML and then pass in the XML string. Now to test that this works, and now the XML document variable represents an actual XML document, on line 5 we can print the value found within the active node by doing XML document.getNodeText and then using XPath. So we'll do // active to grab the text found within the active node. And this does in fact print true to the screen, which is the value found in that node. Alright, so now let's jump into ServiceNow and take a look at an example. First, we'll recreate our example we just looked at. So on line 4, we'll do XML doc.parseXML and provide the XML string. And then on line 5, we'll simply print the text found within the active node. So we'll go ahead and copy and paste that in a background script, and we can see that we do in fact get true printed to the screen. Now we'll jump back to the code and print activity due. So we'll copy and paste that, and now we can see that we get a string of the date and time. We can also create a new element on the XML document. So on line 5, we'll do XML doc.createElement, and we'll pass in pet. Now on line 6, we'll simply print the XML doc variable, and we can see that we have a pet node. Now let's add some text to that node using the createElementWithTextValue. So on line 5, we'll do XML doc.createElementWithTextValue and then pass in two arguments, the first being pet and the second being the actual text found within the node, in this case Oscar. So we'll copy and paste that code. And now we can see that we have a pet node with a start and end tag with the text Oscar found within that node. Now let's take a look at the getFirstNode method. So on line 5, we'll print XML doc.getFirstNode and then pass in /XML/incident. And when we log that, we can see that we get everything within the XML node. If we add /active, we can copy and paste that, and then we get the active node printed. Hello, and welcome back. In this video, we'll take a look at some additional documented APIs within ServiceNow, as well as some undocumented APIs, and we'll cover how we can find out what these undocumented APIs do, and we'll also cover how many of the out-of-the-box scripts leverage script includes. Alright, so let's get started. So in addition to the APIs that we've already covered in this course, there's also a number of other APIs that you can find useful. Keep in mind that these APIs aren't as common as, say, something like a glide record API, but I just want to expose you to these APIs so you're aware that they exist. Up first is the glide modal. You can use this for pop-ups within ServiceNow. So if you ever go to delete a record or something of that sort, a lot of the times you'll get a pop-up or a modal saying, "Are you sure you'd like to delete this?" Well, it turns out that that's actually using the glide modal API. And if you're creating a custom application or something like a UI action, or even in Service Portal, you can leverage this glide modal. Next is the workflow API. And this is used in a lot of scripts that deal with workflows. So you can initialize workflows, and this makes it a lot easier to work with the underlying process of a workflow. There's also a glide sys attachment API that is used to work with attachments. So if you have to programmatically add attachments or manipulate attachments somehow, you can use this API. Then we get into some of the web service APIs like REST Message v2, REST Response v2, SOAP Message v2, and SOAP Response v2. Anytime you're dealing with web services within ServiceNow, so integrations to other systems, you'll more than likely use either the REST API or the SOAP API to process the message or responses to and from the other systems. There's also a glide duration API that makes it very convenient to work with durations within ServiceNow, so over a period of time. There's also many more APIs within ServiceNow, and I highly recommend going to the ServiceNow API website and just spending some time to go through the entire list. That way, when you're developing applications or customizing the platform, you're at least aware that there's other APIs out there that you can leverage instead of spending additional time creating your own. Now let's quickly go over some undocumented APIs. So when I say undocumented APIs, I'm referring to the ServiceNow API website, where these APIs just simply aren't listed. Now, that doesn't mean you can't find documentation out there by Googling or even using the old wiki website. So a lot of these undocumented APIs are actually script includes, or they're inaccessible server-side scripts where we, the developer, just don't have access to them. Some common undocumented APIs are JS utils. This is a general JavaScript utility API. There's also another workflow API. There's a discovery CMDB util to help developers when working with discovery. There's an asset and CI API that provides a lot of helper methods for dealing with asset and CI records. A CMDB item API, an SNC API for general ServiceNow helper methods, a glide string util, and then cart and SP cart for dealing with service catalog carts, and literally hundreds of additional APIs. It's important that you never modify these out-of-the-box script includes. So even if they aren't read-only fields and you can modify them, I highly recommend never modifying them. If you want to leverage these, you can either extend these via script includes or just reference them directly from a script. All right, so now let's quickly look at spotting script includes. So in out-of-the-box scripts, you might often find something very similar to this line of code here. So a lot of the times you'll see a new variable, and it's assigned the value new sum script dot sum function. As we've seen in the Glide Ajax section, when we see something like this, we have a pretty good idea that some script represents the name of a script include, and some function represents the name of a method in that script include. So if you ever see something similar in an out-of-the-box script and you want to know more about what it actually does, I would recommend first searching the script includes table with the word some script in this example, and then within that script include finding the method, in this example, some function, and just reading through the code and getting an understanding of what it does. A lot of the out-of-the-box script includes are actually very well commented, and they're pretty easy to follow along. So now let's jump into ServiceNow and take a deeper look at some of these out-of-the-box script includes. So we'll go to the script include table. And we'll go into this some script include. And you can see here that sure enough, some function is defined within this some script API. So now let's jump into the business rules table, and we'll actually do a search. So we'll search the script field, and we'll do a contains JS util. So we'll find all business rules where there's a script field that contains JS util. We'll go into the first one here, and we can see that this is related to the CMDB. And if we click the Advanced tab, we can see that on line 5, they're using jsutil.notnil. So from this line of code, even though we don't know much about the JSUtil API, we can kind of put together what this is doing. It's referencing a notnil method, and this method is just finding whether this value is nil or not, so null or not. Now to test this, we'll go ahead and copy that. We'll go to the script includes table. We'll find the JSUtil script include, and within here, we'll actually search for that notnil method. All right, so here it is. And what this is actually doing is returning the opposite of jsutil.nil. So it's actually referencing itself and calling the nil method. So the nil method is right here. And you can see that this is in fact leveraging another method. So this should give you an idea of how to research script includes. So if you see these crazy looking scripts in out-of-the-box scripts, this is a good way, or this is a good start to exploring and finding out more about what a specific script or API does. All right, let's try another one. So let's go back to the business rules table. And we'll try the Discovery CMDB util API. So here we have one. And here we can see on line 10 that we have discovery CMDB util, and it's calling the create or update app method. So we'll go back to the script includes, look for that script include, and find the actual method. So as I said before, this has a lot of comments in it to help us understand what exactly is going on here. All right, and we'll do one more. We'll actually just go ahead and find the cart script include. And in this one, there's actually a nice description within the description field. And then we can also look within the script, and we see that there are a ton of helper methods. And that gives us an idea of what this API helps us with. Hello, and welcome back. In this video, we'll actually create our own API using a script include. So in order for you, the developer, to benefit from taking the time to create your own API, you kind of need a few things in order for it to make sense. First, you would need a collection of common functions. So functions you're calling or referencing in a number of locations. If you're just calling this method or function once, it probably doesn't make sense to take the time to create your own API. You'll also need a script include to create the API. So this will actually store our API for us. And then third, you would need a place to invoke or call our API. So in our example, it's going to be pretty simple. We're going to have our API stored within a script include. And we're actually going to leverage a ServiceNow API, the glide record, within our API. So let's jump into ServiceNow and get started. So on the script includes table, we'll go ahead and click New. And we'll provide a name for our script include. So in this case, we'll just give a name of incident utils. Keep in mind that this name must be unique. So once we've provided the name, we can see some script that automatically generated. And we'll start by creating a new method, getLatestIncidents, which will take an integer for the limit of records we'd like to return. So on line 7, we'll do var limit equals num, which is the integer passed in to us. Otherwise, assign it to 5. So the logic here is if there's no number passed in, we'll go ahead and default the limit to 5. Now on line 8, we'll create our glide record object. On 9, we'll do an order by descending, the sys created on. And then on line 10, we'll do incident gr.setLimit, where we provide the variable limit. Then we'll query. And we'll actually create a results array. And within our while loop, we'll just simply push the number of the incident to the array. And then on line 16, we'll return the results. So let's test this by going to background scripts. And we'll do var incidents equals new incident utils, get latest incidents, and we'll pass in 10. So we'll go ahead and gs.print our incidents variable. And we can see here that we get 10 of the latest incidents back to us. So if we go back and remove 10, so we're not passing in any arguments, we can see that it defaults to 5. All right, great. So let's extend this a little more. We'll go back into our script include. All right, so now let's create a grab records method, which will be much more flexible. So we'll actually be able to provide 3 arguments: the table name, the limit, and the order. So we'll start by creating a variable that holds our table. So we'll do var table equals tab. Otherwise, we'll set a default of the incident table. Then we'll create a limit variable where we set it to lim. Otherwise, we default to 5. And then we create an order by variable where we set it to the order argument. Otherwise, we set it to a default of the syscreated on field. So now we'll create our glide record object and we'll initiate it. So we'll pass in the table variable. Then we'll do an order by and pass in our order by variable. And a set limit, passing in our limit variable. And now let's actually create a results variable that will hold our results. And within our while loop, we'll just do a results.push gr.number.getDisplayValue. And then after that, we'll just simply return our results. So let's save this and go ahead and test it in background script. So we'll do var records equals new incident utils dot grab records. We'll pass in incident, 10, and syscreated on. And then we'll go ahead and print these. So we can see our 10 incidents ordered by the syscreated on field. We'll go back and provide a value of 2, so we can see 2 incidents this time. Now we'll go back and actually provide the problem table. So here we can see 2 problem records. Now let's order by the number field and change the limit to 20. So here we can see 20 problem records ordered by the number field. So these go 01, 02, 03, etc. Hello, and welcome to the last video in Section 8, where we'll provide a section recap. So first, let's go over where we can use these APIs. So within this section, we actually discussed client-side and server-side APIs. So it really just comes down to what specific API you're dealing with. Now, a lot of them were server-side APIs, such as glide element, glide date time, XML document 2, etc. But there were a few, like glide modal, that are actually client-side. The API documentation will tell you whether an API is client-side or server-side, so just be on the lookout for that. But I would say 75 to 90% of the time, you're going to be dealing with server-side APIs. Alright, so as a developer, you'll use the glide date time API when dealing with dates and times and wanting to manipulate these fields. You'll use glide element when manipulating fields in a glide record query. And you'll use the XML document 2 when dealing with XML, such as in a web service. When trying to research or get an understanding of what an undocumented API is doing, I would recommend first trying Google and seeing what else is out there. A lot of the times, these will bring back results from the community site, or even old wiki sites, or even third-party websites that do a nice job at explaining what this API does. If a specific script include is accessible, I recommend reading through it to get a better understanding of what exactly it does. And don't forget, you can create your very own APIs within script includes that you can then reference from many other parts within ServiceNow. Hello, and welcome to Section 9, Becoming a Scripting Master. In this section, we'll go over some important topics that will make you a better ServiceNow developer. So to start with, we'll go over some best practices, some general scripting best practices, as well as server-side and client-side best practices. Then we'll take a look at debugging in ServiceNow. Then I'll show you how you can validate JavaScript faster than doing it inside of ServiceNow. I'll also show you some additional JavaScript tools that might help you. And then we'll take a look at a debugging demo where I'll jump into ServiceNow and we'll actually debug some scripts. Then we'll cover version control inside of ServiceNow, and I'll go over some important tips and what to do when you're stuck and need some help. We'll end this section with a demo on version control. Alright, so general scripting best practices. It's best practice to always add a short description to scripts when available. So for example, if a business rule has a short description or description field, it's always best practice to explain what you're doing within your script, since you probably won't be the only ServiceNow developer for a specific instance, especially if the company has the instance over many decades and you move on to another career path. It'll always help the next person looking at this script to read a simple, short description that explains what you're doing in a script. While we're on this topic, I'll actually skip down to the third bullet to comment your code. This kind of goes hand in hand with the short description. If you have a long and complex script, it always helps not only the next person, but even you when you come back to maintain it, to comment your code. So if you're initializing variables, or if you're calling a specific function, or looping through an array, it always helps to comment the code and explain what you're doing within your code. You can check out the link in this source here that actually goes to a ServiceNow wiki page and talks about commenting your code and some of the best practices behind that. Alright, let's jump up to the second bullet. Use condition statements if condition field is available, depending on the scripting location. So in order to improve performance, it's always best practice to use condition statements if available. So for example, on business rules, when you specify, I want this business rule to run when a record is updated, and then using the condition builder, you can specify if the state is new, if active is true, etc., etc. This will improve the performance. That way, if a record doesn't match the conditions, the script never gets evaluated. You don't have to spend time actually processing the script. That's irrelevant. In addition to the actual condition builder, sometimes scripts have condition fields as well. An example of this would be a business rule. So just above the script field, there's a condition field where you can apply similar logic to what a condition builder actually builds. So in this example, we have current.getValue priority equates to 2. So we're saying run this script if the current priority is equal to 2. Alright, so follow a convention, especially for debugging. So if you follow certain coding conventions that might be a little different from the norm, that's okay, but just make sure you're consistent with it. So when the next person is maintaining the code, they don't have to flip-flop back and forth between certain conventions. And it can also help when you wrap your code in functions to prevent polluting the global namespace. So what does this mean? Well, in this example here, this business rule, we have all of our code wrapped within an onBefore function. So it turns out ServiceNow will automatically invoke the onBefore function if this condition gets evaluated to true. All of our variables that we define in this script are going to be local to this onBefore function. Now, it's not as important in this example within a business rule because they already have their own scope. But say in client scripts, when you have a long client script with many functions, since the client-side scope can maintain hundreds of variables, a lot of the times it's important to wrap your code in functions to prevent polluting the global namespace. If you don't fully understand this, take a look at the source link here. That'll actually link to the ServiceNow wiki, where it explains how to wrap your code in functions. Alright, so it's best practice not to use hard-coded values. So a lot of the times, you might need the value of a specific record. So naturally, your first instinct might be to copy the sysid of that record and use that in some type of glide record.get method, etc. Well, it turns out it's actually best practice to instead use a system property which will hold that value and then reference that system property in the script. That way, for maintainability, you can refer to the system property record instead of locating that in a script and updating the actual script. This can be beneficial when you're referencing the same record many places in different scripts. So it's an additional layer of abstraction where we just reference that one system property and we can make a change there. Again, there's a link here that will explain how to do so. Alright, next is really for any programming language, and that's to use descriptive variables and function names. So instead of doing something like var a equals 1, var b equals 2, it really helps for code readability when you give descriptive and contextual names to variables. So if that variable represents a specific counter, then do var counter or var the name of this specific counter equals 1 instead of just simply a. Because again, you might not be the only one maintaining this code. Generally, I prefer longer descriptive names instead of shorter, oftentimes abbreviated words, just for readability. So for example, if the function name was getNextValue, instead of doing something like get nxval, I would write out the words getNextValue as the name. Alright, so this third bullet is probably one of the more important ones, and this will definitely bite you in the butt sooner or later. So verify a value exists before using it. For example, in the second image here on the right, on line 222, we see exclamation, commonly referred to as bang, which just takes the opposite of the value returned. gr.endtext.nil. So we can see here that they're testing that the value actually exists before using it. Again, I recommend checking out the link to read a little bit more about this. Alright, and finally the last one for general scripting is to let the database do the work. When we're doing a glide record query, it's best practice to apply any type of filters to the glide record instead of trying to create that logic within scripts. So for example, if you only wanted records that had a value in a certain field, then you could do that within a glide record. So as long as this field contains something, send me the results, instead of doing that logic within the actual script. Alright, now a bit on server-side best practices. So always use glide aggregate over glide record when dealing with aggregates like counts. In the image below, we can see that they're using glide aggregate to grab the count of this specific query. While you could do this using glide record's get row count, it's actually much more efficient to use the glide aggregate. It actually creates a different SQL query as opposed to running the script to generate that get row count variable. Alright, so if you're deleting some type of record or a set of records and something like a background script, it's best practice to first log those records to the screen or to the console before deleting them. So say you wrote a nifty script that will automatically delete a certain number of records. Well, to verify that your JavaScript and that your logic is correct, I highly recommend first logging those records and verifying that those records are actually what you want to delete before running that delete record method. Alright, the next one, use glide record secure where appropriate. So, oftentimes this comes down to a script include, where if we're calling a script include from an outside source, maybe like a client script, we want to use glide record secure to verify the ACLs on a specific record. Alright, and finally, use script includes over global business rules. This convention offers better performance, so the global business rule doesn't have to load. You just store that code in a script include, which gets invoked when called. Alright, now let's go through some client-side best practices. So the first is probably one of the most important ones when dealing with client-side. Because ServiceNow is software as a service and everything is stored in the cloud, performance is always an important topic. So it's important to make as few calls as absolutely possible when dealing with things on the client side. If for whatever reason you need to fetch many values after the initial page is loaded, maybe try using something like the Scratchpad or calling one script include via Glide Ajax that grabs all of those values instead of making individual calls. Number 2, do not make synchronous calls. This is bad web application practice. So for example, using glide record on the client side or gform.getReference without a callback. These are synchronous calls, so you're essentially locking up the browser until this value is returned. Instead, make asynchronous calls, so something like getReference with a callback, or using Glide Ajax to call a script include, which is holding your glide record. Alright, so use Glide Ajax when passing data between server-side and client-side. And specifically, we want to use JSON when passing data from server-side to client-side. Especially if you're passing sets of records. So, if you're just returning one value, then you don't necessarily have to encode it into JSON. But if you're returning a set of records, maybe a set of incidents, it'll save you a lot of time to encode them as JSON. Debug using console.log. If you're debugging client-side code, try logging it to the browser's console to find out what's going on. Avoid direct DOM manipulation. So if you're within a client script, avoid using jQuery or even vanilla JavaScript to manipulate the DOM. Instead, use the gform API to do this. This becomes a huge pain point when companies want to leverage the new service portal, and some client scripts within the service portal, you can't actually manipulate the window or document object. This is why it's always best practice to use ServiceNow's supported APIs over something like jQuery. And finally, use UI policies over client scripts when available. So if you're ever doing logic to show or hide a field, make a field mandatory, or set a field to read only, use a UI policy over scripting that logic in a client script. UI policies can be much more efficient than loading and running many client scripts. Alright, and finally, here are some best practice resources. So in addition to the links I've added in the previous slides, here are some additional best practice resources. So ServiceNow has a number of best practice pages for coding, specifically client scripts, business rules, commenting best practices, update set best practices, etc. Also, third-party sites like ServiceNow Guru oftentimes naturally include best practices in a lot of their documentation. Best practices may seem like a boring topic, but I promise you if you follow these, it'll save you a lot of time in the long run. Hello and welcome back. In this video, we'll take a deeper look at debugging. Alright, so the first thing about debugging is you will run into bugs, and it's okay. Oftentimes, it can be very alarming when you run into your first few bugs, but as a developer, this is naturally going to happen. So oftentimes, the first thing to ask yourself is the issue reproducible? And if it's not, why is it not? This is actually the first question you get asked if you ever submit a high ticket. A high ticket is essentially a ServiceNow ticket submitted to ServiceNow about a specific instance you have. So if you had a severe problem with your instance and you could not figure out what was going on, you would submit a ServiceNow high ticket to ServiceNow. So the first question they ask is if this issue is reproducible. Now, I would say 95, probably 99% of the time, the issue is going to be reproducible. There's either a problem with the code or the process that you have created. Now, for that 1 to 5% when it is not reproducible, oftentimes this comes down to strange browser errors or rendering issues on the client side. It's important to debug the smart way and know your tools. Debugging is such a fundamental concept that ServiceNow has gone out of its way to create some very powerful tools for you to debug things. So if you're not aware of these tools or you don't know they exist, you're really kind of shooting yourself in the foot. It's important to determine, is the error or bug due to a ServiceNow API, maybe a JavaScript problem with your logic, a scoping issue, etc. Oftentimes, simply logging values either to the server side's logs or the client side via something like console.log will be enough. Many times, it's just the value of a specific variable is not what you're expecting it to be. Alright, so now let's talk about the debugging tools that ServiceNow offers you. So on the server side, we have something called the script debugger available to us. You can do a lot of cool stuff with the script debugger, like set breakpoints in your scripts, examine the call stack, and even examine the values of specific variables. Then on the server side, we also have session debuggers, which we'll actually take a look at here in just a second. On the client side, we have the browser's native console method, so we can do console.log in our client scripts. And we also have available to us the JavaScript executor, And here are some other resources for debugging inside of ServiceNow. Alright, so debugging tools, script debugger. Again, this is a very powerful tool when you need to examine a specific script. So you can set breakpoints, and breakpoints are a way to stop a script at a specific point in time, or more specifically, at a certain line, and then on the right-hand side, you can examine what values are assigned to variables. This can shed a lot of light on the process or the flow of your script. You can also examine the call stack, which can be extremely important when dealing with larger applications that are calling many functions and creating a long call stack. Then we have the session debugging. So oftentimes this is used as a last resort because it can log just about everything, and it can be a bit overwhelming at times, but extremely powerful. So the image on the right shows the application navigator, specifically under the session debug section. You can see that we can set debugging on for business rules, SQL, security, UI policies, etc. And you can even enable all or disable all. Then in the image at the bottom in the center, we can see the log on a specific page. So one of the cool things about session debugging is if you enable all of them, or if you enable a specific debug, then this will run for every single page you go to in ServiceNow. The log is displayed at the very bottom of a page within the ServiceNow frame. We'll take a deeper look at this within the next video where we demo this, but if you would like to read more about this, check out this wiki page. Alright, now I'd like to talk about validating your JavaScript using my personal favorite, JSBin. Now there's many alternatives to JSBin, but for the purposes of this section, I'll be using JSBin. So JSBin has nothing to do with ServiceNow. However, it's a web application where you can write and run JavaScript. So a lot of the times, if you're facing a problem with your code, it might be the logic you're using. So in order to test your JavaScript code, it can be beneficial to copy and paste that into something like JSBin, where then you can run the script in a much quicker fashion within the web application. Again, we'll take a deeper look at this in the next video, where this will hopefully make more sense. But essentially, it's a way to test the logic of your JavaScript in a quicker fashion than within ServiceNow, where you have to save the record and then navigate to the page that executes the script, etc. So we have the browser console and ServiceNow JavaScript executor available to us on the client side. 99% of the time, the JavaScript console is enough. However, if I want to test a value after the page is loaded, the JavaScript executor can be handy because you can leverage the ServiceNow client-side APIs as well. In this example, I'm alerting the text hello plus whatever's assigned to the full name field value. You can also use the browser's console.dir method to explore the JavaScript scope. This can shed a lot of light on what's going on behind the scenes on the client side. ServiceNow leverages a ton of libraries, which the majority of are internal ServiceNow JavaScript libraries. And this is a cool way to examine a lot of the scripts that are loaded behind the scenes. And finally, here's a list of other JavaScript tools. Now, these tools aren't specific to ServiceNow, but they are specific to JavaScript. And they'll help you better understand the language so you can solidify your understanding of JavaScript, which will be directly applicable to your scripting environment in ServiceNow. So there's a website called Loop, which is an amazing visual indicator of the JavaScript event loop and how the event loop works within ServiceNow. We also have Meta.js, which is a JavaScript abstract syntax tree web application that'll help to visualize the AST for a specific script. And then we have JSBin, JSFiddle, and Plunker, which are all web applications where you can write and execute your JavaScript. Then there's also JSLint, which is a syntax checker and much more. So if you want to write best practice JavaScript, I recommend copying and pasting your JavaScript into JSLint to check the syntax and follow best practice JavaScript conventions. And then if you ever need to dabble in regular expressions, this regular expression website is amazing for helping you build regular expressions and testing those all within the browser. Hello and welcome back. In this video, we'll actually jump into ServiceNow and perform some debugging. So for our first debugging example, we're actually going to use a business rule on the incident table that is triggered anytime an incident is updated. And all of this we'll be doing is calling a script include, which that script include calls another script include, and we'll perform the debugging on these script includes. So if I go to the incident table and go into a specific incident and click Configure Business Rules, we'll go into the debug trigger. And you can see that this is very simple. It just runs before an update happens on the incident table. And in the script field, all we're doing is calling the debugging script include. So we'll actually copy that name and go to the script include table. And this debugging script has a few variables. We have hello text, which is equal to a string hello there. And then var a equals new, and then we actually call another script include, another debugging script. Then we invoke a method within that script include, so we do a.callMe. So we'll actually copy that name and go into that script include. And we can see here that this script include has one method, callMe, and we assign a counter variable equal to 0, and then some var equal to 1. We immediately increment some var, and then we run a while loop. While some var is less than 5, we will increment the counter and some var. So the first time this runs, some var is equal to 2 before it gets to the while loop. So 2 is less than 5. We'll run this once. Some var is now 3. It'll run again. Some var is now 4. And then when it runs the next time, 5 is not less than 5, so it'll quit. So now if we type in debugger and open up the script debugger, we can see our two script includes pop up. And the reason these load is because the system knows that we've assigned breakpoints in those scripts. So in another debugging script, we have a breakpoint at 10 and 12. And then in our first script include, debugging script, we have a breakpoint at 2 and 5. So if we go to the incident table and make an update to a specific incident, we see a pop-up come up, transaction pause at breakpoints, and we'll go ahead and click the Start Debugging button, which will bring our script debugger into focus. And now we have a number of details. We can examine the call stack, as well as some transaction details. Then on the right, we can actually see our variable assignments. So we have our local scope, A is undefined, hello text is undefined, etc., as well as our global scope, and any closures that we might have. So if we go to the breakpoints tab, you can see that that the script is paused at our very first breakpoint, so on line 2. If we click the play button, the script will run until our next breakpoint. So now we can see our hello text variable has been set on the right-hand side to the text hello there. And now, if we click play again, we will run line 5, which is a.callme. And now this jumps into our second script include. So because there's no code on line 10, it actually jumps to our second breakpoint, line 12. So here we can see our counter and some var variables. Our counter is currently at 0 and some var is at 2. If we click play, it'll run again. Counter's at 1, some var is at 3. Click play one more time. Counter's now at 2, some var is at 4. And finally, if we click play again, the script include will reach the end and stop the debugging process. So this can be very helpful for long and complex script includes, or really just any server-side script for debugging purposes. We can set breakpoints so we can pause the script at a certain point in time and examine what's going on by looking at the scope. So we can see the local scope and the global scope variables, and even the call stack. So if we have a script include that's referencing many other scripts, we can examine those here as well. So really powerful stuff. Now let's take a look at the session debugging. So if we type in debug, we can see system diagnostics come up, and then under the session debug section, we have a number of debug flags. So we can debug business rules, we can debug SQL, security, escalations, UI policies, etc. So to start with, we'll click the debug SQL, which will turn on the SQL debugging. So now when we go to a page in ServiceNow, the SQL log will appear at the very bottom of any page within ServiceNow. So if we go to the incident table and we scroll all the way down, we can see the debug log. And this has all of the SQL that was ran to render this page. So we can examine the actual select statements that ServiceNow is generating and actually running against the MySQL database. Now if we go back to the debugging, and we'll actually click enable all this time. So this will turn on all of the debugging. So now if we scroll down to the bottom of a new incident form, we can see that we have SQL, log, business rules, security rules, others, etc. So if we select the business rules checkbox, we can see at the bottom all of the business rules that run on this incident form. So we can see execute before query business rules on sysuser, finished executing before query business rules on sysuser, etc. This can be helpful if you need to check the order of operations for specific business rules. We'll examine the security rules. So we'll leave that checked and then uncheck the others. And here we can see all of the ACLs that are running for incident. So if you ever need to debug certain ACLs, this would be a good place to come to do it. Alright, so we'll actually go back to the session debug and click the Disable All button. This will turn off all of the session debugging. So now let's examine some client-side debugging. So we'll navigate back into an incident form. And to start with, we'll bring up the JavaScript executor. So on a Mac, we'll press Shift-Control-J, and this will bring up the JavaScript executor window. And to start with, we'll just alert the value of the state field. So here we can see that we have a value of 1. We can even alert the get label of. So we have state. So that can be helpful when you want to examine specific values on the form. Now let's jump into a client script, specifically the onload hello. And see if you can spot the error in this script. We'll actually come back to this in a second. But if we navigate back to the incident form and check out the browser's console, I know that the short description field is not being updated. So I know that there's something wrong with this script. In order to help troubleshoot, I'm actually going to use the browser's console. So if I go back to the incident form and open up the developer tools and go to the console tab, and we can see this reference error G-form is not defined. So it looks like I'm missing an underscore between G and form. If I click the link on the right, this will actually take me into the client script that's loaded within the browser. So we can see here on line 1719 that we are in fact missing our underscore. So we'll jump back into that client script. And add an underscore, update that. Now if we go back to the incident, we can see that short description is in fact being updated. Hello and welcome back. In this video, we'll discuss version control, we'll go over some general ServiceNow tips, and we'll also discuss what to do when you get stuck or need help with something. So just about every major script field in ServiceNow, so the script field on business rules, the script field on client scripts, etc., have version control. And if the versions related list is activated on the current form, you can go down to a specific version, right-click on a row, and click Compare Version. We'll demo this in the next video, but essentially you'll get a pop-up box that looks like the one shown here. And it's essentially the same thing as any other diff merge tool out there, if you've ever used one of those. On the right, you have the current version, so the current script version. And on the left, you have the selected version, so the version that you're comparing the current version to. Then the tool will highlight any differences between the two scripts. So we can see on line 5 that there's a difference. And we can see that on the current version, we've added lines 13 through 16 that don't appear there in the selected version. So if you're working with different versions and scripts and you make an error in the current version and need to go back, this is a great tool for doing so. You can scroll through the entire script and compare differences between the two scripts. Alright, now let's go over some general ServiceNow tips. So in the application navigator, there are a few keywords that you can type that will do special actions. So as I've pointed out before, if you type in the table name followed by .list and hit enter, this will take you to a list view of the table. So you can type in incident.list to go to the incident table, or literally the name of any other table .list to go to the list view of that table. Now, you can do the same with .do. However, .do will take you to a new record form view for that table. So this is the same action as if you were to first go to the list view and then click the new button to insert a new record. So if you want to save some time and you know you have to create a new incident or a new record on any table, you can do the table name .do to take you directly into that form view. You can also clear the ServiceNow cache by typing cache.do. Sometimes this is important when ServiceNow caches certain properties or ACLs and you need to flush the cache. The last one I have here is stats.do. So if you type in stats.do, this will render a page that shows a number of stats about the current system. So you can use this to see what version the current instance is on, and some uptime stats and all kinds of other stuff. The next tip is the show XML UI action. So if you're on a record and you're scripting something and you need to know the field names, not the field labels, but the actual field names to fields, a lot of the times the show XML UI action can be very helpful because it'll bring up a new window and it'll show that entire record in XML format. And one of the nice things about that is it shows the field names as opposed to the field labels for each XML node. So again, we'll go over this in the next video where I demo this. But for now, just know that this is a helpful tool when you need to know field names for a specific table. If you're ever dealing with an object that is not documented or is not exposed to use in somehow, you can actually write the following code to take a peek inside of the object or to view the object's properties. So if you write a JavaScript for-in loop, you can actually log the properties of that object. And you can get creative and write a recursive for-in loop within the parent for-in loop, so you can log all of the properties and nested properties. This can be helpful if you're curious as to what other properties an undocumented object might have. Then there is, of course, the ability to right-click a form field to view additional information about that specific field. So maybe you just need to know one field name, or you need to know the reference table for a specific field. If you're on a form view within ServiceNow and you have the admin role, you can right-click a field and click additional information to see additional information about that field. And finally, the last tip I have here is you can use the contains filter on script tables to find scripts that contain certain keywords. So this can be very helpful if you want to find a script to reference if you're creating a new script. So say you're creating a new script and you're using the Glide Ajax API, but you can't remember the exact syntax. So what you can do is go to the client scripts table and search the script field and do a contains query for the class name Glide Ajax. Then this will return all scripts that contain Glide Ajax. This is very helpful for a number of things in ServiceNow. So don't forget to search the script field with a contains query. And you can even chain these with ORs or create a more granular search with the AND query. Alright, so now let's discuss what to do when you're stuck and you need help. So if you're scripting and you get stuck or you're running into an error, I highly recommend you first give debugging a try. It's very important to get into the habit of debugging. If your script isn't doing what you want it to do, you need to ask yourself why. What about this script is failing? Well, a lot of the times debugging can help. And a lot of the times just simply logging the values of variables will help locate the error in your script. If you're running into an order of operations problem, then try debugging the business rules or other debug session options. Next, of course, is Google. A lot of the times, if I'm searching for an undocumented API, I will Google ServiceNow plus the name of the undocumented API. I will typically prepend all my queries with the word ServiceNow, so it'll only bring back information related to ServiceNow. If Google isn't returning the answers you need, try going to the ServiceNow community and posting your question. Now, you could either post your question in the ServiceNow community, there's also a Stack Overflow ServiceNow page, or there's even a ServiceNow subreddit to post your questions to. So either one of these community pages can help. Now keep in mind the ServiceNow community is probably the most active one here. It's important to note that when you post a question, you must be very clear with what you're asking. Think of it from the person answering your question. If you read a question that doesn't make much sense or doesn't help you out into what the poster is trying to achieve, then chances are you won't get an answer or you won't get the right answer. So whenever you post, make sure you go out of your way to help the community get an understanding of what you're asking. Oftentimes providing an example is very helpful, or even screenshots. Typically when I post, I always provide at least one or more screenshots. Also, if it's a problem with a script, provide the actual script in the post and inform them of where it's located. If you take these steps, I can almost guarantee that you'll get a quality response back. There's also a number of other third-party websites that can be helpful that would show up in a Google query as well. And finally, there's the course Q&A. So on this course, if you have course-specific questions or just general ServiceNow questions, you're more than welcome to post on the course Q&A. This is beneficial for the community for this course because chances are if you have a question, then other students will have the same question. So if you post these questions here and I answer them, then it helps everyone else out with the same questions. Hello and welcome back. In this video, we'll demo the tips we went over in the last video, as well as the version control, and I'll show you JS bin as well. So let's get started. The first thing we'll take a look at is using the keywords in the application navigator. So we'll start with the .list command. So obviously, as we've seen before, if you type in incident.list, you'll be taken to the incident table. And I can type in problem.list and be taken to the problem table. And we'll go into the sccat item table, which is the catalog item table. Now if we type in incident.do, we'll be taken into a new record form view on the incident table. Now I'll type in cache.do, and we can see a few statistics on the garbage collection process. And now we'll check out the stats.do page. So here we can see a ton of information about this instance. The build name shows us which version we're on. Under the build tag, we can also see the patch we're on, which can be very helpful. We have some servlet stats and some information about the semaphores and a number of other things. So now let's go into an incident. And to start with, we'll take a look at right-clicking on a field and clicking Show Field Name. So this will load a little pop-up box, and we can see here information about this specific field on the table. So we can see that this is on the task table. So because the incident table extends the task table, we can see that this CMDB CI field is actually on the task table. The field shows us the field name. So it's CMDB_CI is the field name. It has a type of reference, so we know that this is a reference field, and it references the CMDB CI table. So this can be helpful if we want to find out what that referencing table is quickly. And then it also has some other attributes for this field. Generally, I use this to find out the name of the field, and if it's a reference field, what is the referencing table. So now if we click the hamburger menu in the top left and click on Show XML, we'll see a new window, and this is the XML for the current incident. So each one of these XML nodes represents a field on the incident table, specifically a field for this record. So this is another way we can quickly find out the names of the fields on the incident table. And what's really nice about this is it shows the XML for the entire record. So even if the current form doesn't have a specific field on it, if we show the XML here, this will load all of the fields stored within the actual database. Or maybe you just have a complex form that has a lot of show hide UI actions or maybe tabs, and you just want a quick and easy way to locate a specific field name. This can also be a great method. So we know that the caller ID field here is a reference field. And going back many sections ago, when I said that reference fields actually store the sysID of the referenced field in the referenced table. So we can see here that the caller ID node is storing the sysID for my user record. And it turns out that the display value is included as an XML attribute as well. So we have the display value of Mark Miller. All right, now let's take a look at looping through the properties of an object. So for the purposes of this example, we'll bring up the Mozilla console, and we'll type for property and guser, and then we'll log the property as well as the property value. So if we click enter, we can see all of the properties on the guser API. So again, this can be helpful when examining an undocumented API. And finally, if I go to the script includes table, I can search the script field for contains, and we'll just use the keyword JSUtil. So here we can see a list of all scripts that reference the JSUtil API. Alright, so now I'd like to show you JSBin and testing the logic in our JavaScript. So I have some code here, and because we're not in a ServiceNow environment, this will throw a lot of errors since we don't have glide record defined along with the properties on glide record like .query or .next. But for the purposes of this example, I know I'm having some issues with my for loop, so I'd like to test this logic. Well, what I'll do is go ahead and comment out all of the GR code, and instead I'll create a temporary variable answer and just create an array with incident numbers. So because I'm running this on the client side, I can do console.log. So for the purposes of this code, what I'm looking to do is loop through each element in the answer array, and if the number contains 009, I want to log that specific element to the console. So something isn't right, something is not working here. So now we can start to isolate the problem. So we can play around with a few things, change a few signs. Here we can see that we're getting everything except the 009 incident. So because of that, we know there's something wrong with our if logic. And it turns out we have the wrong sign. So instead of a less than, we need a greater than sign. So now when we run it, we get what we're looking for. So when you're wanting to test your JavaScript logic in a quick fashion to where you can just click a run button and instantly run your JavaScript, using JSBin can be a great tool. Now, obviously, there are some limitations, and this might not work for large scripts where you're referencing a lot of ServiceNow specific APIs, because those, of course, won't be accessible to us in JSBin. But if you have some type of JavaScript that's causing an error, it might be beneficial to copy that code into JSBin. Create some temporary variables so you can run your script and play around with your JavaScript here. Alright, now let's take a quick look at version control. So we'll go into a script include. And if we scroll to the bottom, we can see that this script include has 3 different versions. The first one being the current version. So if we go down to the second one, we can right-click on this row, and we have a few options. We can revert to this version, or we can compare to current version. So if we click that, we'll be taken to the compare to current page, where it's currently comparing the entire record. But if we want to specifically look at the script field, we can click the little pop-out box, and this will show a modal of the 2 scripts. So again, on the right we have the current version, and on the left we have the selected version. And we can see here that we're adding a completely new function here. So this is a great way to quickly compare 2 versions of scripts. And in the UI actions at the top, we can revert to the selected version or even save our merge. So we can do this for any script field where that table is watching versions. So if the table has the versioning on, then we can use this compared to current version on the script field. Hello, and welcome to the last section in ServiceNow 201 Development, Section 10, Creating a Custom App. In this section, we'll take a number of APIs that we've learned throughout this course and apply them within a custom application so we can see just firsthand how these APIs are actually used. So we'll start by going over what we'll be building with the custom app. Then I'll go over some requirements, we'll discuss the design, and go over the API overview. Then we'll talk about the execution, and then finally we'll jump into ServiceNow where we'll actually first create the application, and then second, where we customize the application using the APIs that we've learned. We'll end this section with a section recap. So, what will we be building? We'll be building a simple dog adoption application. This application will focus on scripting and will use rapid prototyping. The purposes of this application, more specifically this video, is just for demo purposes, and you should not take this as best practice for building custom applications. A lot of what we will do could be achieved without scripting. However, because I want to demonstrate and show you the APIs, I'll be building custom components that leverage these APIs through scripting. It's also important to note that this would not be production ready. We won't be performing a lot of checks for our data, and we'll just be kind of creating a prototype of what the application could be within ServiceNow. Now let's take a look at the requirements that we received from our customer. So first will be from the adopter's point of view. So as a person adopting a dog, I'd like to view all available dogs, and I'd like the ability to send an adoption request to an adoption center. Now, as an adoption center, so someone who's working at the adoption center, I'd like to post new dogs. I'd like the ability to receive emails about adoption requests, and I'd like the ability to edit information about a specific dog. So let's quickly discuss the scope of this application. So obviously, for the purposes of this demo, we'll stay simple and we'll only have two tables. We'll have a UI page and a UI action so we can leverage the APIs. And we'll be creating this minimal viable product. Again, we will not be representing best practices for custom application development. All right, so let's take a deeper look at the design. So again, the components are as follows. We'll create two tables, the first being a dogs table and the second being an adoption centers table. The second component is a UI page where we'll give the ability to create new dogs. The third component is a UI action, which will create an adopt button on the dog form. The fourth component is an event, and the fifth component is an email notification. So here are the two tables we'll be creating. On the dog table, we'll have a number field, which is a string, a name field, which is a string, a status field, which will be a choice field, a picture, which will be an image, a breed, which will also be a choice field, an age field, which will be an integer, a shots field, representing if the dog has shots or not, which will be a yes-no field, a neutered field, which will be a yes-no field as well, a bio field, which will be a string field, and finally an adoption center field, which will reference the adoption centers table. So the adoption centers table will have a number field, which will be string, a name field, which will be string, a phone field, which will be phone number, and an email field, which will be a string field as well. This is a quick wireframe of what the dog form will look like. We'll have information on the left and a photo on the right. In this case, this is my dog Oscar, who has a tennis ball in his mouth. This is what the UI page will look like. So we have a very simple form. with 2 inputs, 2 checkboxes, and a button. When we click the Add Dog button, we'll get a message below saying that a dog has successfully been created. And finally, we have the UI action component, which will be an adopt button on the dog form that when clicked, there'll be a pop-up where the user can enter their email address, and then an email is sent to the adoption center. Alright, now let's quickly take a look at the API overview. So up first are our 2 components, a UI page and a UI action. We'll use the Glide Ajax API in the UI page as well as the UI action, and we'll use the Glide Form API in the UI action. We'll place the UI action within the form. The UI page as well as the UI action will both call a script include, and it's in the script include where we'll use the Glide System and Glide Record APIs. Finally, the script include will also create an event, which in turn will create an email. So in order to create this application, we'll first create the custom app. Second, we'll create the tables. Third, we'll create the fields on those tables. Fourth, we'll configure the form views. Fifth, we'll create the UI page. Sixth, we'll create the script include. Seventh, we'll create the event. Eighth, we'll create the email notification. And finally, ninth, we'll create the UI action. Hello, and welcome back. In this video, we'll actually create the custom app fetch. We'll create its tables, and we'll create the fields associated with its tables. So let's get started. Alright, to start things off, we'll type in application, scroll down, and click Studio under System Applications. This will load the ServiceNow Studio, and we'll click Create Application at the top here. We'll click the Create Custom Application Create button, and we'll provide a name for our custom application, in this case, Fetch. You can see that automatically generates a scope for us, as well as a user role, and a menu. We'll go ahead and select that we want to create a table as well, and we'll come down and give it a label of dogs. And we'll also select the auto number feature, which will create a number field with a prefix and an incremented number. Looks good. We'll go ahead and click Create. We'll click OK, and this will create the application files. Now we'll select our newly created application, Fetch. And on the left, we can see all of the records associated with this application. So we have our table, we have our access controls, we have our application menu, modules, etc. So to start, we'll add some fields to the dogs table. We'll click the New button, provide a type of string, and we'll add the name field with a max length of 100. Go ahead and click Submit. And then we'll create a new one. This one will be a choice field. And it'll be status. So we'll go ahead and save that, and now we'll add some choices to this choice field. So we'll click New. We'll add a status of active. Save that. Then we'll add a status of pending. And insert and stay. And then we'll add a status of adopted. And insert and stay as well. So now we can see our 3 choices on the status field. All right, that looks good. Now we'll go ahead and create a new field, and this will be our picture. So it'll be a type of image. We'll create another field. This will be a choice field. And we'll give it a label of breed. Now we'll go ahead and create some choices. So we'll create a choice of Labrador. Then we'll create German Shepherd. And finally, we'll just create a mixed choice. So here we have our 3 choices. All right, next we'll create the age field, so it'll be a type of integer. That looks good. Now we'll create the shots field, so this will be a true-false type. And then we'll create the neutered field, so this will be a true-false type as well. Now we'll create a bio field, give it a type of string, and we'll do a max length of 4,000, so it's a nice big field. Go ahead and submit that. And now we have our main fields on the dogs table. So next, we'll create the adoption center table. We'll click Create Application File, select Table, and click Create. We'll provide a label of Adoption Center. And we'll create the module, and it'll be added to our fetch application. We'll provide an auto number and its prefix. And then click Submit. Now we'll add some fields to this table, so we'll click New. We'll add the name field, so we'll give it a type of string. And then we'll add the phone field, so we'll give it a type of phone number. And finally, we'll add the email field, so we'll give it a type of string. And submit that. Now we'll head back to the dogs table and create a new field. And this field will reference our adoption center table. So we'll create a type of reference, and we'll provide the column label of adoption center. Then under the reference specification, we'll provide the reference table, adoption center, and click Submit. Now our two tables should be created, and all of the fields should be created as well. So in the application navigator, we'll type in fetch, and we can see our two tables here, adoption centers and dogs. Now we'll go into the dogs form and modify the form a little bit. So we'll move things around so it matches our wireframe. And we'll go ahead and create a new dog. Now we'll personalize the list columns. And finally, we'll create a new Adoption Center record. Then we'll go back to the dog, Oscar, and provide the Adoption Center Franklin County Dog Shelter. Hello, and welcome back. In this video, we'll start to extend our custom application fetch. So we'll start by creating our UI page, and then we'll create our script include that we'll use throughout the rest of these videos. Alright, to start with, we'll type in UI page, and click on New. And we'll give it a name of Create Dog. This will generate some HTML for us. So we'll just go ahead and copy that and paste that in our text editor. So for the purposes of ServiceNow development, you don't actually need to know HTML. However, for the purposes of this demo, I will be using HTML so I can demo the Glide Ajax API. So if you don't know HTML, don't worry. The only reason I'm using it is to create a basic form with a few fields, and then from that point on, we'll use JavaScript on the back end. So if you do know HTML, feel free to follow along. So to start with, we'll just create an h1 tag, add a new dog. And then we'll create our form using some Twitter Bootstrap classes. Again, if this doesn't look familiar, don't worry about the specifics of the HTML too much. Just know that we'll be adding some IDs to the field so we can collect this data from the form. So we'll go ahead and create a label, name of dog. And then provide an input with an ID of dog name. And we'll copy and paste that and do the same for dog age. We'll change the ID to dog age. And then we'll create our checkboxes for shots and neutered. We'll create an input and give it an ID of dog shots. With a label of shots. And then we'll go ahead and copy and paste that for neutered. And do dog neutered for the ID. Finally, we'll provide a button that has an ID of add dog and a text value of add dog. Then below this, we'll provide a div with an ID of message. Alright, so we'll go ahead and copy and paste that in the HTML field and click try it. Oh, we got an error. Looks like I forgot to add a div, so I'll go back and fix that real quick. Update that, and now we'll click try it. Alright, so I'll provide a name and an age, and we'll select shots. And obviously when I click add dog, nothing is happening. We haven't built that in yet. So we'll do that now. So for the purposes of this client script, we'll actually use jQuery, which will help us write this faster. So to start, I'll use jQuery and I'll select the button. So we'll give an ID of add dog, and then we'll create a click event for this button. Alright, so on line 2, we'll start our Glide Ajax API. So we'll create a variable, GA, and we'll initialize our Glide Ajax API, where we pass in fetch utils, which will be the name of our script include we'll create here in just a second. And then we'll do sysparm name, where we'll provide a name of create dog for the method. And then we'll copy and paste this 4 times, where we'll provide our dog information as parameters in the Glide Ajax request. So we'll use some jQuery to provide the values for the dog name, dog age, dog neutered, and dog shots. And then finally on line 8, we'll do ga.getXML. And we'll provide our callback, fetch ballback. All right, so let's build out this callback function. All right, so on line 12, we'll grab the answer from the XML. So we'll do response.response.xml.getAttribute_answer. And finally, we'll actually chain on the JavaScript split method, and we'll pass in a pipe delimiter. So instead of sending JSON back, we'll actually just do a long string that's pipe delimited. All right, and once we receive that response, we will use jQuery to append HTML to that message div. And we'll just do answer 0, so the first element in our answer array has successfully been created. Dog ID is the second array element, so answer 1. And then we'll even create a link to the dog. All right, so we'll copy and paste that in the client script. And now let's go ahead and create our script include. So we'll go to the script includes table. Click New, and provide the name fetch utils. We'll make sure client callable is checked, and then we'll copy and paste that JavaScript in our text editor. And now we'll start to build out our create dog function. So we'll create a variable dog name and assign this the value from our get parameter method of sysparm dog name. And we'll do this for dog age, dog shots, and dog neutered. Now we would like to use glide record to insert the actual dog. So we'll initialize our glide record object, passing in the name of our dogs table. We'll use the new record method, which will initialize our record, and then provide the dog name and age. And then we'll say if dog shots is true, we would like to add new dog.shots equal true, and the same logic for dog neutered since these are Boolean values. Then we'll create a variable for the dog number, which we'll pass back to the client. So we'll do new dog.number.getDisplayValue. And then we'll create a variable sysID, which will hold the sysID to this newly created record. And we'll actually do equals new dog.insert. So what this will do is this will insert the new dog record, and then when we do insert, it actually returns the sysID back to us, which will be then held in the sysID variable. Finally, we'll get the link to this dog. So we'll do var dog link equals new dog.getLink. It's important to note that we still have access to the new dog glide record, even though we've inserted the record already. Alright, so now let's return those values. So we'll do return dog name plus pipe plus dog number plus pipe plus dog link. Go ahead and copy and paste that in our script include. Now we'll save it, and let's test out the UI page. So we'll go to our Create Dog UI page. Then we'll click Try It. So we'll provide a dog name of Bill, provide an age of 10, select shots and neutered, and click Add Dog. Now we see a nice message that says Bill has successfully been created. Dog ID is dog001027. View new dog. So we'll click on the link, and that does in fact take us to the newly created dog record, Bill. Hello and welcome back. In this video, we'll continue extending fetch. So we'll start by creating an event, then we'll create an email notification, and then we'll create the UI action that'll trigger our event. So let's get started. To start with, we'll go to the event registry and click New. And provide a suffix for our new event. We'll just provide adoption_email. Because we're in a scoped application, we can see that our event name has the scoped application prefix along with our suffix adoption_email. We'll leave table blank, and then we'll provide a fired by and description. We'll go ahead and copy the event name and submit the event. Now we'll create a new email notification. So we'll click on Notifications and click on New. We'll provide a name, Adopt Dog Email. And then provide none as the table. We'll go ahead and save this. And we can see that the table actually gets defaulted to incident. So first we'll click the Advanced View related link. And this will show us the send when, which shows all of the system events. So we'll provide our newly created event here. And now we'll go back to the table field and provide a table of none. We'll save this record, and now we can see that the table is in fact none. So for who will receive, we'll check the event parm1 contains recipient. And now we'll start to build out the actual HTML email. So for the subject, we'll provide new adoption request. And then in the message HTML, we'll just provide a simple message for now. Hello, you have a new adoption request for, and then we'll provide the variable within parm2 by doing $squiggly event.parm2. Now we'll go ahead and update that notification. Alright, now we'll go back into our script include and add a new function. So we'll scroll down and under our create dog method, we'll create a new method, create email notification. Because we'll be calling this from the UI action, we'll use glide Ajax in that example. So we'll do var adopter email, and this will be a parameter, so we'll use the get parameter sysparm adopter email. We'll also provide the adoption center. And then we need to grab the adoption center email. So we'll create a variable, adoption center email. And then we'll query the adoption center table using glide record. We'll use the get method, passing in the adoption center sysID. And then we'll set the variable adoption center email to the ac.email.getDisplayValue. Now that we have our variables, on line 36 we'll create our event using gs.eventQueue. We'll pass in the name of our event, then AC for our current glide record, then the adoption center email, and finally the adopter email. Then we'll add a return statement. So now we'll head to the dogs table, go into a record, and click Configure UI Actions. So we'll click the New button under the UI action to create a new UI action. We'll provide a name of adopt. And select the client checkbox. And unselect show insert since we only want this to show on update. We'll provide the name of our client-side function adopt dog in the onClick field. And then we'll provide a condition, so we only want this to show if the current record status is active. Now we'll select the form button checkbox and create our adopt dog function. So we'll start by prompting the user for their email address and assign that to the email variable. We'll do a simple check as long as the email does not equal a blank string. We'll initialize our glide Ajax API. So we'll provide our fetch utils script include name, and then the name of our newly created function, in this case, create email notification. And then we'll provide the adoption center's sysID using gform.getValue, and then the name of the field, in this case, adoption center. And then we'll pass in the user's email address by simply putting in the email variable. Then we'll use the getXMLAnswer method, and we'll pass in our AJAX processor callback. And then if the email equals a blank string, we'll alert the email address you entered does not appear to be valid. Alright, so now we'll build out our AJAX processor callback. And all this will do is simply alert, "Thank you for your request. Someone will be with you shortly." So we'll go ahead and submit that. And now our application is complete based on the requirements we've gathered. So if we go to the dogs table, we'll select this dog's status to pending. And we can see adopt disappears. We'll set it back to active, and now we'll click on the adopt button. I'll provide an email address and click OK. And now we see the message here. "Thank you for your request. Someone will be with you shortly." And now before we verify that the email was sent, we'll first check the event logs. So we'll click on Event Log, and we can see our event is here, and we can actually see the parm1 and parm2 values as well. So now we'll go to the emails logs, find our email, and if we scroll to the bottom, we can click the Preview HTML body, and this will show us the email that would have been sent if our email servers were configured. Alright, and that's the fetch application. Hello, and welcome to the last video in section 10, where I'll provide a section recap. So, we successfully created an application that uses the following APIs. We use the Glide Record and Glide System APIs in our script includes. We use the Glide Form API, as well as the Glide Ajax API. The custom components that this app contains are a UI page to insert new records, a UI action to adopt a specific dog, a custom event, and an email notification as well. So with that, we've reached the end of the course. I wanted to personally thank you for taking the ServiceNow 201 development course and reaching the end. So congratulations. If you have any questions, concerns, or feedback, feel free to send me a message on Udemy or post your questions in the Q&A section, or even send me an email or connect with me on LinkedIn. So again, thank you for taking the course, and I hope to see you in the next one.